Hey, this is Andrew Brown, your favorite cloud instructor, bringing you another free cloud certification course. And this time it's the AZ-400. This is specifically for the Azure DevOps engineer. And we're making this available on freeCodeCamp as always. So the way we're going to get the certification is by doing labs in our own Azure account, lecture content, and as always, we provide you a free practice exam. And I want to tell you that our exam simulator has case studies, which is the most important component when we're looking at these expert certifications with Azure. So if you want to support more free courses like this one, the best way to do that is to purchase the additional study materials over on ExamPro.co. That's where you get the cheat sheets, additional practice exams. The content is layered. And again, it helps produce these courses. If you don't know me, I've taught a lot of courses here. I've taught AWS, Azure, lots of Azure, GCP, Kubernetes, Terraform, you name it, I've taught it, so you're in good hands, and I will see you soon, okay? Hey, this is Andrew Brown. I just wanted to tell you that in this video course, I am utilizing my synthetic voice. Synthetic voices is when you utilize software that emulate your voice. The reason why I utilize a synthetic voice is a couple reasons. This is when the real Andrew, not the synthetic voice Andrew, has lost his voice. And this happens to me because I have muscle tension dysphonia. And so if I use my voice a lot aggressively, I can lose my voice. And so I have to be careful when I'm recording a considerable amount of content. And right now, when this video is being made, I am recording a lot of AWS content. And so, I've asked my support team to just generate out my words and stitch the video together. And the reason for that is that I don't want my content to go stale. So when I create content, it has to get shipped, whether my voice is ready or not. So this is the case for the AZ-400. Otherwise, this course would just go stale and you wouldn't get it for like 6 months to a year. But, that's the trade-off that we have when I'm a single content creator and I'm trying to get all this content out. So I just want to point out that the content is made by me. It's just utilizing the synthetic voice. So it's not like it's somebody else doing 100% everything else otherwhere. But there you go, okay? Hey, this is Andrew Brown from ExamPro, and we'll be going over an introduction of the AZ-400 certification. The Azure DevOps Engineer Expert is an expert-level Microsoft certification. For the prerequisites, you must earn at least one of the following: the Microsoft Certified Azure Administrator Associate, or the Microsoft Certified Azure Developer Associate. The key topics covered in this course: design and implement processes and communications such as GitHub Flow and Azure Boards. Design and implement traceability and flow of work. Configure collaboration and communication. Design and implement a source control strategy such as branching strategies, pull request workflows. Design and implement build and release pipelines. Design and implement a package management strategy like GitHub Packages. Develop a security and compliance plan. And implement an instrumentation strategy like Azure Monitor and Log Analytics. So, who is this certification for? The certification is designed for individuals who are interested in learning how to design and implement DevOps practices for continuous integration, continuous delivery, and infrastructure as code. You may consider this certification if you are new to DevOps and want to learn the fundamentals and benefits of DevOps practices. You are a software developer, systems administrator, or IT professional. You want to understand the capabilities of Azure DevOps and GitHub, including building pipelines, implementing source control strategies, and managing security and compliance. You are a senior DevOps engineer or in a related role who needs to reset or refresh your knowledge after working for multiple years. So, what's the Azure DevOps Engineer Expert roadmap like? Well, the most common route that people take to reach the DevOps Engineer Expert is to start at the Azure Fundamentals. It's not mandatory, but it helps build a solid foundation. Then you take the Azure Developer Associate for designing, building, testing Azure applications, and eventually take the Azure DevOps Engineer Expert. Another common path is to take the Azure Administrator Associate and then the Azure Solutions Architect. You can also take the Azure Solutions Architect after the DevOps Engineer Expert to further enhance your Microsoft Azure skills and widen your career prospects. Other popular associate-level certifications may include the Azure AI Engineer, Azure Database Administrator, and the Azure Security Engineer, and many more. So that's a general outlook on the roadmap to Azure DevOps Engineer Expert. How long to study to pass? For beginners, so if you've never used Microsoft Azure or any cloud provider, have no prior experience with DevOps practices, or no tech background or experience, You're looking at around over 50 hours. You shouldn't take this exam if you're a beginner. You'll need to pass the prerequisites and build a solid foundation. If you're experienced with Microsoft Azure or any cloud providers, have experience with DevOps practices and tools, and have a strong background in technology, you're looking at about 15 hours. The average study time is about 25 hours. You should dedicate around 50% of the time to lecture and labs, and 50% of the time to practice exams. We recommended to study around 1 to 2 hours a day for 20 days. What does it take to pass the exam? Watch video lecture and memorize key information. Do hands-on labs and follow along within your own account. Do paid online practice exams that simulate the real exam. Sign up and redeem your free practice exam. Exam guide, content outline. The exam has a total of 5 domains. Each domain has its own weighting. This determines how many questions in a domain that will show up. Skills measured. Design and implement processes and communications. Design and implement a source control strategy. Design and implement build and release pipelines, which consists of 50 to 55% of the course. Develop a security and compliance plan. Implement an instrumentation strategy. Where do you take the exam? You can take the exam at an in-person test center or online from the convenience of your own home. You can use Certiport or Pearson VUE. At Proctor is a supervisor or person who monitors students during an examination. The passing grade is about 700 out of 1,000. You need to get around 70% to pass. Microsoft uses scaled scoring. There are about 50 to 55 questions. You can afford to get roughly 12 to 14 questions wrong. There is no penalty for wrong questions. Format of questions: multiple choice, multiple answer, drag and drop, yes and no. Keep in mind that there's usually one lab with about 8 questions that you do on the Azure portal, and the exam is open book, but you can only access the Microsoft documentation as the resource. The exam duration is 2 hours. You get about 2 minutes per question. Exam time is 120 minutes. Seat time is 150 minutes. Seat time refers to the amount of that you should allocate for the exam. It includes time to review instructions, show online proctor your workspace, read and accept NDA, complete the exam, provide feedback at the end. The certification is valid for 1 year. You can renew the certification for free within 6 months or before the expiration date. So that's an introduction to the Azure DevOps Engineer Expert certification. Hey, this is Andrew Brown from ExamPro, and we'll be going over a quick overview of the exam guide. You can find the exam guide by searching for Study Guide for Exam AZ-400 on Google. So as we scroll down, it will show you the 5 domains covered, and it'll be broken down into more sections. I won't be able to go through all of it, so I'll just go through some of the key topics that I think you should focus on for the exam. Design and implement a structure for the flow of work, including GitHub Flow. Design and implement integration for tracking work, including GitHub projects, Azure Boards, and repositories. You need to know the flow of work, such as cycle times, time to recovery, and lead time. Configure release documentation, including release notes and API documentation. Design and implement a strategy for managing large files, including Git large file storage and Git fat. Recommend package management tools, including GitHub Packages Registry and Azure Artifacts. Design and implement quality and release gates, including security and governance. Select a deployment automation solution, including GitHub Actions and Azure Pipelines. Design a deployment strategy, including blue-green, canary, ring, progressive exposure, feature flags, and A/B testing. Implement feature flags by using Azure App Configuration Feature Manager. Design and implement desired state configuration for environments, including Azure Automation State Configuration, Azure Resource Manager, Bicep, and Azure Auto-Managed Machine Configuration. Implement and manage GitHub authentication, including GitHub Apps, GITHUB token, and personal access tokens. Implement and manage secrets, keys, and certificates by using Azure Key Vault. Automate container scanning, including scanning container images and configuring an action to run codec L analysis in a container. Configure Azure Monitor and Log Analytics to integrate with DevOps tools. Configure collection of telemetry by using Application Insights, VM Insights, Container Insights, Storage Insights, and Network Insights. Inspect distributed tracing by using Application Insights. Interrogate logs using basic custom query language queries. So that's a quick overview of the exam guide for the AZ-400. Hey, this is Andrew Brown from ExamPro, and we'll be starting off asking the most important question first. What is DevOps? DevOps is an approach that brings together software development and IT operations with the goal to enhance the speed and reliability of software delivery. It focuses on continuous improvement, automation, and collaboration between teams that were once siloed, aiming to shorten the time from development to operation. The process includes frequent code versions, which allows for incremental improvements to applications and systems. The ultimate goal of DevOps is to create a culture and environment where building, testing, and releasing software can happen rapidly, frequently, and more reliably. So, why DevOps? DevOps eliminates the inefficiencies, miscommunications, and delays that arise from the traditional gap between development and operations teams. It creates a collaborative culture that accelerates and improves software delivery. Some of the key challenges addressed by DevOps include this communication and collaboration gaps enhances communication and collaboration, reducing misunderstandings and accelerating the release process. Conflicting goals aligns the goals of dev and ops teams towards quick, reliable, and high-quality software delivery. Manual processes and bottlenecks advocates for automation to decrease manual effort, errors, and delays. And streamlined processes, automation leads to fewer errors, shorter deployment times, and improved software quality. So, what's the role of a DevOps engineer? A DevOps engineer facilitates this collaboration and automation, focusing on continuous integration and continuous delivery, establishing pipelines that automate code integration, testing, and deployment, ensuring rapid, reliable software releases. Infrastructure as code, managing and provisioning infrastructure through code to increase efficiency and consistency. Monitoring and operations, implementing monitoring solutions to track application and infrastructure performance, ensuring high availability and reliability. Transition to cloud infrastructure. Many organizations are transitioning to cloud infrastructure, such as AWS, Google Cloud, or Azure to cut costs and improve manageability, offering intuitive tools for network and security settings, but necessitating knowledge of platform-specific features. Some of the tools and technologies that will be used in DevOps are version control, such as Git, essential for managing code changes and facilitating team collaboration. Agile and lean techniques for planning, sprint isolation, and capacity management. Containerization, such as Docker, enables scalable deployments with lightweight containers that are faster and simpler to configure than traditional virtual machines. Orchestration, like Kubernetes, efficiently manages containerized applications at scale. CI/CD tools, such as Jenkins and GitLab CI, automate the software delivery process from code integration to deployment. IAC tools, like Terraform and Ansible, automate the provisioning and management of infrastructure. Monitoring and logging, such as Prometheus, provides insights into application performance and operational health. And public and hybrid cloud streamline operations, offering scalable infrastructure with iOS for seamless app migration and platform as a service to enhance productivity through sophisticated tools. Some examples of DevOps technologies across the different DevOps stages, mainly related to Microsoft Azure, include: for planning, we have Azure Boards, GitHub, and Atlassian Jira. Continuous integration, Azure Repos, GitHub Repos, SonarQuebec, Selenium, OWASP, ZA, NuGet, and NPM. Continuous delivery, Azure Pipelines, GitHub Actions, Bicep, Terraform, Jenkins, Red Hat, Ansible, Chef, and Puppet. Operations, Azure Monitor, Azure Automation, and Microsoft Power BI. And for collaboration and feedback, there's Azure DevOps Wikis, GitHub Wikis, GitHub Discussions, Microsoft Teams, and Slack. Overall, DevOps revolutionizes IT by merging development and operations, enhancing delivery speed, and fostering a culture of rapid, continuous innovation. The next topic we'll be covering are the differences between DevOps and traditional IT. In terms of time, DevOps teams spend 1/3 more time improving systems to avoid tech issues than traditional IT. Less time is needed for administrative tasks because DevOps uses more automated tools and helpful scripts. This saved time allows for a 33% increase in enhancing their tech infrastructure. They also have 15% more time for learning and training, boosting their skills. For speed and data, DevOps groups are typically small and adaptable, driven by creativity and speed. One of the main goals of DevOps is agility, aiming for swift completion of tasks. Traditional IT operations typically have less feedback data, focusing only on the immediate task. IT operations often have to handle unexpected downstream issues they didn't see coming. Cloud DevOps is more effective in delivering business applications due to its quick pace. Traditional IT must strive to keep up with the rapid changes and demands of the business world. Regarding recuperation and crunch time, DevOps teams focus on readiness for failures and have strategies like ongoing testing and real-time alerts. These strategies mean they can address issues quickly and keep systems running smoothly. Traditional IT may need more time to recover from setbacks because they might not have these proactive measures in place. Fast recovery in DevOps is often helped using automated systems and flexible infrastructure setups. For software distribution, DevOps teams take roughly 37 minutes to deploy software. Traditional IT operations typically need about 85 minutes for the same task. This indicates DevOps teams can release software more than twice as quickly as traditional IT teams. Next, we'll quickly go over a few key aspects that DevOps has an advantage over traditional IT. Product reliability, reduced likelihood of failure. Adaptability, enhanced flexibility and support. Market responsiveness, decreased time to market. Team productivity, greater efficiency in teams. Vision clarity, more defined product vision within teams. So that's an overview of DevOps versus traditional IT. The next topic we'll be covering is Agile and Agile development. Agile is a philosophy in software development that emphasizes incremental progress, collaboration, and flexibility. It revolves around the idea of breaking down large projects into smaller, manageable sections called iterations or sprints. Teams work in these short bursts to produce tangible results regularly, allowing for frequent reassessment and adjustment. This approach enables a quick response to change and promotes continuous improvement, both in the product and the process used to create it. The term Agile methodology refers to the specific frameworks and practices that embody the Agile philosophy, such as Scrum and Kanban. These methodologies provide the structure and tools for teams to execute Agile principles effectively. They include techniques for planning and tracking progress, such as stand-up meetings, sprints, and visual boards, all designed to enhance team coordination and project transparency. Agile development encompasses various methods that follow the Agile Manifesto's core ideas. It's about teams working together, managing themselves, and using practices that best suit their project's needs to gradually improve their software. In Agile development, teams aim to produce fully working and high-quality parts of the software at the end of every sprint. This means they must write code, test it, and make sure everything is of good quality within each sprint's short time frame. The key success factors for Agile development teams include diligent backlog refinement, integrating early and often, and minimizing technical debt. Diligent backlog refinement, this means organizing the list of upcoming work, prioritizing the most important tasks, and clarifying them. Product owners are key in preparing for future sprints by providing clear goals. Integrating early and often, by using continuous integration, continuous delivery, teams automate their workflows, which speeds up coding, testing, and deployment. This helps catch and fix problems early. Minimizing technical debt, just like unwanted financial debt, technical debt happens when taking shortcuts, which may later require code fixes. It's important to find a good mix of adding new features and fixing these issues, needing careful planning and discipline. So that's an overview of Agile and Agile development. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be going over two popular Agile frameworks or methodologies called Scrum and Kanban. Scrum is an Agile framework designed for managing complex projects by breaking them down into small, manageable tasks completed in short phases called sprints. The key roles in Scrum include a product owner guides what and why the team builds, prioritizes the work backlog. A Scrum Master facilitates Scrum processes, supports team improvement, and removes obstacles. And a development team engineers the product, ensuring its quality. In Scrum, a team self-manages its sprint tasks with daily stand-up meetings to ensure progress and address impediments. They track work using a task board and a sprint burn-down chart, and at the sprint's end, they showcase their increment in a review and identify improvements in a retrospective. Scrum's short, repeatable cycles facilitate continuous learning and adaptation, making it a practical framework for teams adopting Agile principles. On the other hand, Kanban is an Agile methodology focused on visualizing work, limiting work in progress, and maximizing efficiency. Kanban boards are used to display work at various stages of the process using cards to represent tasks and their stages, highlighting work in progress and facilitating team flexibility. Cumulative flow diagrams visually track a project's workflow over time, showing task distribution across stages. The horizontal axis represents time, and the vertical axis represents task volume, with each color marking a different work stage. CFDs highlight trends, progress, and bottlenecks. Parallel colored areas indicate balanced workflow. Bulges suggest bottlenecks needing attention for smooth project continuation. Let's go over a quick comparison between Scrum and Kanban. While broadly fitting under the umbrella of Agile development, Scrum and Kanban are quite different. Scrum focuses on fixed-length sprints, while Kanban is a continuous flow model. Scrum has defined roles, while Kanban doesn't define any team roles. Scrum uses velocity as a key metric, while Kanban uses cycle time. Teams often blend Scrum and Kanban features to optimize their workflow. They continuously refine their approach to find the best fit, focusing on simplicity and regular value delivery to users. The next topic we'll be covering are some of the key flow metrics you'll need to know for DevOps processes and for the exam. Starting with velocity, velocity in Azure DevOps is a metric that tracks the amount of work a team completes during a sprint, helping teams estimate how much work they can handle in future sprints. It's represented in a chart that visualizes work items completed over several sprints, offering insights into the team's work patterns, efficiency, and consistency. By analyzing velocity, teams can adjust their planning for better predictability and productivity. Consistent velocity metrics can help in identifying the impact of process changes and guiding strategic decisions to enhance overall team performance. Next, we have Sprint Burndown Chart. The Sprint Burndown is a graph that plots the daily total of remaining work, typically shown in hours. The Burndown chart provides a visual way of showing whether the team is on track to complete all the work by the end of the sprint. It also helps in identifying any bottlenecks or issues in the workflow that may need attention before the sprint's end. Moving on to lead time and cycle time. The lead time and cycle time widgets indicate how long it takes for work to flow through your development pipeline. Lead time measures the total time elapsed from the creation of work items to their completion. Cycle time measures the time it takes for your team to complete work items once they begin actively working on them. The following diagram illustrates how lead time differs from cycle time. Lead time is calculated from work item creation to entering a completed state. Cycle time is calculated from first entering an in-progress or resolved state category to entering a completed state category. These measures help teams plan, spot variations in efficiency, and identify potential process issues. The lower the lead and cycle times, the faster the throughput your team has. So, these are some of the key flow metrics you'll need to know for the exam. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be covering Azure Boards. Azure Boards is a web-based service designed for planning, tracking, and discussing work throughout the development process, supporting Agile methodologies for a customizable and efficient workflow. Key hubs in Azure Boards. Azure Boards includes several key hubs, each serving distinct project management needs. Work Items Hub. Manage work items based on specific criteria. Boards Hub. Visualize workflow using cards, ideal for Kanban. Backlogs Hub. Plan and organize work items, including backlogs for project and portfolio management. Sprints Hub. Handle sprint-specific work items, incorporating Scrum practices. Queries Hub. Generate custom work item lists and perform bulk updates. Delivery Plans Hub. Track cross-team deliverables and dependencies in a calendar view. Analytics Views Hub. Create Power BI reports for detailed project analysis. Key benefits of Azure Boards include scalable simplicity, easy to start with predefined work item types, scalable for growing teams. Visual tools, visualize progress with Kanban boards, Scrum boards, and delivery plans. Customization, configure boards, task boards, and plans, including custom fields. Built-in communication, capture real-time communication and decisions within work item forms. Cloud storage, support for rich text, inline images, attachments, and comprehensive change history. Efficient search and notifications, tools for quick work item searching and customizable alerts. Dashboards and analytics, access to dashboards and analytics service for reporting. Integration and support. GitHub and Office integration connects with GitHub repositories and supports import-export with Microsoft Office. Autonomous team support tailors to independent teams, integrates with Microsoft Teams and Slack, and offers a variety of marketplace extensions. So that's an overview of Azure Boards. The next topic we'll cover is traceability. Traceability allows tracking connections and dependencies among different parts of a software system. It helps teams grasp the effects of changes, handle risks, and comply with regulations. Defining and managing requirements. A key part of traceability is documenting and overseeing requirements effectively. Azure DevOps has tools like Azure Boards for handling requirements and tracking their progress, linking requirements to related items like tasks or bugs. This tracking clarifies each requirement's progress and its influence on the project. Version control and change management. For traceability, a solid version control system to monitor modifications to code and files is essential. Azure DevOps Git repositories let developers manage their work efficiently. By using branches for features or releases, you can track changes and understand their role in the project's bigger picture. Building and release management. Traceability must include build and release processes. Azure Pipelines facilitates building, testing, and deploying apps, linking build artifacts and code changes to specific tasks, showing what changes made it into each build. Test management and quality assurance. For software quality, traceability is crucial. Tools like Azure Test Plans support detailed test management. Linking test cases to requirements or user stories shows how well the testing process covers the initial needs, ensuring thorough validation. Auditing and compliance. Traceability also supports meeting standards and regulations. Azure DevOps' auditing features track and log changes, providing details on who changed what and when, supporting accountability and regulatory compliance. Overall, by setting up a clear traceability system, organizations can make sure that any changes during the software development process are properly tracked, recorded, and checked. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be going through how to get started with Azure DevOps and some of the basics of Azure Boards. So the first thing you want to do is search for Azure DevOps on Google. Then you want to click on the link that leads you to the Azure DevOps page, which is usually the first link. On this page, you want to click on the Try for Free button. I'm assuming everyone already has a Microsoft account or Microsoft Azure account already set up. Otherwise, you wouldn't be taking the AZ-400 level expert certification. If not, you should create one before clicking here. So we'll enter in our email and click on Sign In. Enter in our password. And enter in the authentication code if you have one. Now you'll want to sign up and create your own Azure DevOps organization. I'll be hosting the projects in Canada. I'll name the organization something like ExamPro 1. You can name this whatever you like. Also enter in the CAPTCHA as requested, then press Continue. The first thing they want you to do is to create a project. So we'll name this something like ExamPro Test. Of course, you can name this whatever you want, such as your name or org project, and so on. So now we're on the main page of the ExamPro Test project on Azure DevOps. So here you can see the overview. So we'll quickly go through some of the blades, starting off with Azure Boards. Then we have Repos. After that, there's Pipelines. Next is Test Plans. And then there's Artifacts. We'll be going through most of these in the course. So that's how to get started with Azure DevOps. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be covering how to create or add new users in your Azure DevOps organization. The first thing you want to do is to go to Organization Settings. After that, you want to click on Policies under the Security category. Under the User Policies, you want to toggle and turn on External Guest Policies. This will allow you to invite users from outside the organization to access and collaborate on your Azure DevOps projects and resources. After that, you want to click on Users under the General category. On the right side, you want to click on Add Users. Here is where you can add new users or service principals. So, for example, we'll add Cindy at ExamPro.co. We'll keep the access level to basic. We'll want to add the user to the ExamPro test project we created earlier. We can also set a role for the user, such as project readers, project contributors, or project administrators, but we'll leave it at project contributor for now. Then click on Add. After a short wait, the user should be added to the organization. The user is sent an invitation to join the org, and they'll have to accept to join. We'll add another user. This time it'll be Peter at ExamPro.co. We can keep the access level at basic. Add the user to the ExamPro test project. And this time, we'll assign the user the project administrator's role. Then click on Add. Another thing you can do is add members to a specific project. So from the Projects tab, you can click on the project ExamPro test. click on Teams, click into ExamPro Test. After that, click on the Add button, and we'll search for Peter at exampro.co. Click on the user, and then click on the Save button below. And there we go. The user is now added to the ExamPro Test project team. So that's a general overview on how you add users to your organization in a specific project. The next thing we'll be covering is how to create work items. So first you'll need to be at the Boards tab, and then you'll need to click on Work Items. On the top right here, we'll click on New Work Item. We have three options here. There's Epic, Issue, and Task. Epic is simply a large body of work that can be broken down into smaller, more manageable pieces of work. This is also known as user stories. So we'll click on Epic as an example. Now we'll have to fill out some fields to define the work item. So starting with the title, we'll call it something like Test New Login Feature. Right below it, we can assign people to the item. This can be one or many, but we'll select only one for this example. So let's choose Andrew Brown. For the state, we'll leave it at To Do. For the area, it's already set at ExamPro Test. The iteration is set to ExamPro Test Sprint 1. We would want to give the work item a description to help understand what it's about. For this example, we can write something simple like conduct a series of tests on the new login features. For the priority, we can adjust the importance of the work item, 1 being highest priority and 4 is the lowest. We'll keep it at 2, so it's about medium priority. We can set a start date, so we can just use the current date as of this recording. For the tags, they already have some suggestions for us, so we'll use testing, login feature, and security, which matches the item. We don't really need to set the link for this example, so we'll click on the top right and hit Save. After that, we can head back to the Work Items page, and we should see the work item we just created with all the information we provided for it, such as the title, user assignment, state, area path, and so on. Another thing we can do is click on Boards. This is an easier way to visually view the items. So we have 3 columns that work items can be placed in: To Do, Doing, and Done, which are all pretty self-explanatory. On the top right here, we can filter to epics or issues. And we can drag and drop the work item from To Do to Doing, and eventually we can place it in Done when the item is complete. So that's a general overview of how to create a work item in Azure Boards. Hey, this is Andrew Brown from ExamPro, and in this section, we'll quickly go over how to create a sprint. First, on this page, we have 3 work item examples that were created beforehand. And we'll want to click on the Sprint tab on the Boards section. Here, we don't have any sprints created yet, so we'll need to create a new sprint by clicking on the top right. We'll need to give the sprint a name, so let's just call it Sprint 1. And we'll need to identify a start and end date for the sprint. So we'll start it on Monday, April 15th, 2024, and end the sprint on Monday, April 22nd, 2024, so that's 1 week length. Then click on Create. Next, we can click on the Schedule Work button from your product backlog or create new work items. On the right, we have our Sprint 1, and we can drag and drop the work items to include them in a sprint. So let's drag some of the work items created earlier into Sprint 1. We can also create new sprints by clicking on the New Sprint button below Sprint 1. So for this sprint, we can call this Sprint 2, and for the date range, we can set the start for Monday, April 29th, 2024, and end the sprint on Monday, May 6th, 2024. Then click on Create. We can do a quick refresh so Sprint 2 appears. Let's add one of the work items to Sprint 2. So if you click into Sprint 1, you can see that we added 2 of the work items on the backlog from earlier. If you want to delete a sprint, you can go to Project Settings on the bottom left. Under the Boards section, click on Project Configuration. And as an example, we'll delete Sprint 2, so we'll click on the 3 dots next to Sprint 2, and keeping it at ExamPro Test is fine. Then we'll click on Delete. So after that, we can go back to the backlogs or sprints. And we can simply add the other work item into Sprint 1. When we go to Sprint, there are additional tabs such as Taskboard, Backlog, Capacity, and Analytics. We'll quickly go to Capacity. We can assign days off, activity, and capacity per day. We'll just assign an activity for both of the users, such as deployment and design. And for the Analytics tab, there's the burn down trend that shows a visual graph of data, such as the amount of work that has been completed in a project versus the total amount of work that was planned. So that's pretty much a quick overview of how to create a sprint and a few of its features. The next thing we'll be covering is how to connect Azure Boards to GitHub. First, you want to click on the project you're working on. Then on the bottom, you want to click on Project Settings. And under the Boards section, click on GitHub Connections. After that, under the Connect GitHub with Azure Boards, click on Connect your GitHub account. Next thing you'll need to do is to log into your GitHub account. So sign into account using your username or email address or password, and click on Sign On. After confirming the information, click on Authorize Azure Boards. Now, you'll need to select a GitHub repository that you may want to use with your Azure Boards. Click Save after choosing that. Then, after confirming all of this information, click on Approve, Install, and Authorize. You can choose to add more repositories or remove them. You can remove connections as well. You could also add new GitHub connections as well. So that's a really quick and simple walkthrough of connecting Azure Boards to GitHub. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be going through an overview of custom Azure Boards dashboards. Centralize with custom dashboards. Custom dashboards in Azure Boards are crucial for presenting a comprehensive overview of your project status and key metrics. By tailoring these dashboards to highlight crucial data, your team can streamline workflows and improve decision-making. Customize with widgets. Widgets are the heart of Azure Boards dashboards, presenting diverse data from progress charts to work item queries. Select and tailor widgets that best display the team's critical information, ensuring essential insights are readily accessible. Monitor backlogs with query widgets. Incorporate query widgets to filter and display work items based on defined criteria, like outstanding tasks per team member. This enables efficient task management and helps in setting clear priorities. Track progress with burn-down charts. Use burn-down chart widgets to graphically track project progress, helping to identify any delays. Regular review of these charts keeps the team's progress aligned with project goals. Visualize performance with charts. Enrich your dashboard with charts that convey performance metrics, such as bug trends or team velocity, providing a clear picture of the team's dynamics and highlighting areas for improvement. Enhance team engagement. Share dashboards with your team and stakeholders to offer a live view of the project status, fostering a culture of transparency and collective accountability. The image on the left shows an example of a dashboard customized to the way of the DevOps team or stakeholders. This shows information such as the velocity, sprint burndown, backlogs, completed and active work items, and so on. So that's an overview of custom Azure Boards dashboards. The next topic we'll be covering is Wiki for documentation. Wiki offers a collaborative space for team members to compile and share crucial details about a DevOps project. Here's a simple guide to leveraging wikis for effective project documentation. Start with an overview page. Begin by setting up an overview page. This should introduce the project, its goals, and the team working on it. Mention the technologies, tools, and methods your project employs, keeping it broad but informative. Detail project requirements. Dedicate pages to outline the project's requirements. Break down what the project needs to do and how it should perform, using clear and achievable language. Add user stories, what needs to be true for the project to be considered complete, and any other elements that rely on each other. Architecture and design documentation. Use the wiki to detail the project's structure and design. Make a separate page for each part, whether it's a component, a larger section, or a service. To help visualize how these parts interact, include diagrams like UML or system architecture sketches. Encourage team input. Get your team involved in the documentation process. Allowing everyone to edit and update wiki pages not only promotes teamwork but also helps keep the information current. Make sure to use the wiki's version tracking to monitor changes and roll back if needed. So let's take a quick look at where this is in Azure DevOps. So at the overview section, we'll need to click on Wiki. And we already created an example wiki with proper documentation. So this is what it'll pretty much look like using Markdown. We can click on the Edit button on the top right. This will allow you to edit the wiki to your fitting. You can also create more than one wiki if you want. So we can name it like example wiki 2. So that's an overview and guide to using Wiki for documentation. The next thing we'll be covering are process diagrams for documentation. Process diagrams are visual guides that show the steps in a process, making it easier to see how everything connects, especially in DevOps projects. Here's a simplified guide on using them effectively. Pinpoint essential processes. First, identify the main processes in your DevOps project, such as managing source code, integrating changes continuously, testing automatically, deploying, and monitoring. Break down these processes into smaller parts. Make flowcharts or BPMN diagrams, which stands for Business Process Model and Notation. Use software like Microsoft Visio, Draw.io, or Lucidchart to create diagrams that map out the process. These diagrams should clearly show where the process starts and ends, include decision-making points, and outline the steps in order. These visual tools are effective for mapping out the workflow, making complex processes easier to understand and follow. On the right, we have a process diagram or flowchart that outlines a customer support procedure. It begins with a ticket submission, followed by case assignment. If during business hours, the support team responds, otherwise an on-call technician is alerted. At assigned tickets prompt reminders, while assigned ones are prioritized for review and resolution by the support team. The process cycles until issues are resolved, culminating in ticket closure and a follow-up email. Detail what goes in and comes out. For every step in your process, note down what you need to start, which are the inputs, and what you expect to get out of it, which are the outputs. This might be code, test results, deployment packages, or anything else relevant. It's important to show how each step is linked to the next. Clarify who does what. Make sure your diagrams indicate who is responsible for each step. This removes confusion and makes sure everyone knows their responsibilities. So that's a quick overview of process diagrams for documentation. The next topic we'll be covering is configuring release documentation. Release documentation is a cornerstone for the successful deployment of software releases within Azure DevOps, focusing on the non-code aspects that define the scope, quality, and functionality of the release. Here are the key elements of release documentation. Release notes. These should highlight what's new, what issues have been resolved, and any enhancements made, as well as outline any modifications to settings and their effects on existing features. Installation guides provide clear, detailed instructions for the setup process, including a list of required software and system prerequisites and post-installation actions. Configuration changes document updates to configuration settings, clarifying any default settings and essential changes. Changelog keep an accurate record of commits or work items in the release using a consistent tracking method. Rollback plan have a clear, predefined plan for reverting to an earlier software version if necessary. Creating release documentation in Azure DevOps. Azure Repos. Store your markdown or text files alongside your code. Version control your documentation for consistency and traceability. Azure Pipelines. Automate the generation of changelogs and other documentation during the build and release processes. Artifacts. Attach generated documentation to specific builds or releases as downloadable artifacts. Wiki. Utilize the built-in wiki to share detailed guides and notes with the team and stakeholders. On the right, we have an example of a release notes entry in Azure DevOps, which displays all of the key elements shown earlier. This includes the new features, enhancements, configuration changes, note issues, and rollback plan. So that's an overview of configuring release documentation. Next, we'll covering API documentation. Properly configured API documentation is essential for developers and stakeholders in understanding and interacting with software interfaces. This guide highlights the key steps and best practices for creating and managing API documentation in Microsoft DevOps solutions. Steps to generate API documentation. Generate documentation. Utilize Visual Studio to generate API documentation. Access this feature via the Build menu. Use tools like Swagger, Azure API Management, or OpenAPI for automatic documentation generation from your codebase. Documenting endpoints. Clearly define and describe each API endpoint, detailing the purpose and functionality. Include information on request and response formats, as well as any authentication requirements. Selecting formats and styles. Decide on your output format and style, ensuring it's readable and accessible for your target audience. Integration and automation. Integrate documentation generation into your continuous integration and deployment pipelines within Azure DevOps. On the right, we have an example of an API documentation. This API documentation details two endpoints for version 1.2.3 of a service. The first endpoint is POST API login, which authenticates users and returns a token upon successful login. It requires a username and password in the request body. The second endpoint is GET API users, which retrieves a list of users. Both endpoints provide example responses indicating successful operations with a 200 OK status. Best practices for API documentation. Consistency. Use a consistent format for all API endpoints to make the documentation easy to follow. Clarity. Ensure that descriptions are clear and concise, avoiding ambiguity. Version control. Manage your API documentation within Azure Repos for versioning and historical tracking. Regular updates. Keep the documentation current with every release, deprecating outdated information promptly. Feedback mechanisms. Include a process for developers and users to provide feedback on the documentation for continuous improvement. By focusing on these elements, your API documentation will be an invaluable resource for your team and stakeholders, supporting the effective use and integration of your software's API. So that's an overview of API documentation. With the rise of DevOps and Git's stronghold in version control, the manual slog of updating docs has given way to automation. Now, developers can create dynamic documentation straight from their Git history. Here's a guide on how to automate documentation using Azure DevOps Solutions and its Azure Pipelines feature. Prerequisites: a Git repository hosted on platforms like GitHub or Azure Repos. An Azure DevOps account connected to this repository. Automating documentation with Azure Pipelines. Step 1. Set up your pipeline. In Azure DevOps, select Pipelines from the project menu and click New Pipeline. Pick your code repositories platform in the repository itself. Choose the main branch as the source for your docs. Tailor your pipeline settings, pick the right agent, and decide when this pipeline should run. Add tasks for building the code and another for generating docs. Step 2. Build the code and insert a build task into your pipeline to compile your code. This can be .NET Core, Node.js, Python, and many more. Fine-tune this task to match your project. This might mean different commands or scripts, depending on what you're building. Confirm a successful build before moving on. Step 3. Generate the documentation. Post-build, select a tool like DocVex, tailored for NAT projects, to parse your Git history into documentation. Add a new task in your pipeline for DocVex. Set this up with the correct paths and configurations and let it craft your docs. Step 4. Publish your work. Once your documentation is ready, pick a spot to publish it. This could be Azure Blob Storage, an FTP server, or Azure Pipeline's own artifact storage. Add a publishing task to the pipeline and configure it with the necessary details. Deploy this task and see your documentation go live. Step 5. Make it automatic. To really put your feet up, configure triggers in Azure Pipelines to run your documentation job on autopilot. You can set these to activate on new commits, merges, or even on a schedule. Once set, your documentation updates as your code does, no extra input needed. So, this is a simplified overview for automating Git history documentation with Azure DevOps. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be going over what are webhooks. Webhooks are user-defined HTTP callbacks triggered by specific events like code pushes or comments on a blog. When an event occurs, the source site makes an HTTP request to a configured URL. This allows for automated actions such as data transfer, notifications, or initiating other workflows. How webhooks work: event occurs, a specific event triggers the webhook. This event could be an update, a deletion, or some activity like a user action or system event. HTTP request: the source site makes an HTTP request to the webhook's URL. This request can be a post, which is the most common, GET, or any other HTTP method, depending on what was configured. Action taken: the server that receives the webhook does something with the information, like updating a database, notifying users, or initiating other workflows. Some of the common uses of webhooks include automating workflows. Webhooks can automatically update a testing server, deploy applications, or update a backup. Notifications: they can notify other systems or services in real time when events happen. For example, if someone posts a comment on a blog, a webhook could automatically tweet the comment or send an email. Integrations: many services offer webhooks to integrate with other services without requiring a custom interface. For example, PayPal uses webhooks to notify your accounting software when you receive a payment. Advantages of webhooks. Efficiency. Webhooks offer a more efficient method for receiving data than continually polling a service for updates. They push data as it becomes available, minimizing latency and reducing the amount of bandwidth used. Real-time processing. Webhooks can facilitate real-time data processing by triggering a reaction immediately after the event occurs. So that's a quick overview of webhooks. As we mentioned briefly earlier, webhooks in Azure DevOps trigger HTTP notifications to a URL for events like code updates or build completions, facilitating integration with other systems. So let's go over some of the steps to configure notifications with webhooks. Select the event, navigate to the project settings, and then to the Notifications tab, as shown in the image on the right. Identify the event you want to track. For instance, if you're interested in when a build completes, you would select that event. New subscription. Click on New Subscription to create a new webhook. Select the specific event you want, such as build completes. Configure action. Define the action that should happen when the event occurs. This typically involves sending a notification to an external service. Customize your webhook. You can customize what information you send along with the webhook. Azure DevOps allows you to send specific data related to the event. Authentication, if needed. If your endpoint requires authentication, you will need to configure the appropriate headers or payload with authentication tokens or keys. Test the subscription. Once configured, it's crucial to test the webhook to ensure it works as expected. Azure DevOps typically allows you to test it through the interface. Monitor and adjust after setting up. Monitor the notifications and ensure they're firing correctly. You might need to troubleshoot or adjust settings if you're not receiving the notifications as expected. So that's a quick and general overview of how to configure notifications with webhooks. Hey, this is Andrew Brown, and we are taking a look at version control systems, which are designed to track changes or revisions to code. And there's been a lot of software over the years that helped us do that. We had CVS, Subversion, Mercurial, and Git. So back in 1990s when we got CVS, even though we had it, I don't think a lot of companies were using it. It took some time to adopt. If you ever heard of like Doom or Wolfenstein, you'd be interested to learn they didn't use version control systems. And what they would do is they would literally copy files onto floppies and hope that they don't lose their files. But of course, version control systems makes it really easy to not worry about losing floppies or CDs or drives because they keep track of all the history. Then came Subversion in 2000, but the real game changer was in 2005 when we were introduced to a new type of version control system. And we had Mercurial and Git. But the key difference between the old ones and the new ones was the old ones were centralized and the new ones were decentralized. And these decentralized ones became very popular for very specific reasons. They had full local history and complete control of the repo locally. They were straightforward and efficient for branching and merging, which was a really big deal. Better performance, improved fault tolerance, flexible workflows, work fully offline. And out of the two, Git was the one that won. And there are reasons for that, and we'll talk about that when we look at version control services. Yeah, Git is the one that everybody is using today, and that's why we are taking this course. I just want to point out, you're going to come across a lot of terms that sound like trees, tree, trunk, branches. The reason for this is that version control represents the revisions or changes in a graph-like structure. You can even say a DAG if you're familiar with that. And so, you'll see these terms, and we're not talking about real trees. We're talking about the components of a version control. So there you go. Hey, this is Andrew Brown, and we are taking a look at Git. So Git is a distributed version control system, a DVCS. That's going to be hard to remember. And it's created by Linus Torvald. If you've ever seen that name before, you might know that Linus is the creator of the Linux kernel, but he is also the creator of Git. And Git right now resides with the Linux Foundation, which I believe is a nonprofit set up by Linus as well, or has some part to do with it, where a lot of open source projects reside. But I don't really want to focus on that. I want to focus on the practicalities of Git. So the idea with Git is that each change of your code, a Git commit, can be captured and tracked through the history of your project, a Git tree. So I'm going to get my pen tool out here for just a second. And so I just want to make this very clear. So we have over here a file, and a Git commit a commit can be made up of multiple files with multiple changes in them, and then they're represented over with a message. Okay, so here this is a single git commit, and it can have multiple files and changes in that single one, and then that's your tree. Okay, so hopefully that is clear. If it's not, don't worry, we'll get hands-on skills and we'll definitely be able to remember them later. I want to take a look at a bunch of common Git terms, and it doesn't matter if you remember these now, but you will know what they are hopefully by the end of this course. And so there is this nice graphic here that is provided by Wikipedia that gives an idea of how all of these terms work together. But let's go quickly through them and see what we can make sense of. So the first term is a repository. This represents the logical container holding the code base. In fact, you could interchange the word code base and repository and mostly mean the same thing. We have a commit. This represents a change of data in the local repository. And so that's pretty clear. Then we have the tree. This represents the entire history of a repo. So when you see tree, just think of that graph. We have remote. This is a version of your project hosted elsewhere, used for exchanging commits. Some people might be a bit picky about this because they might say remote is actually a remote reference to a repository. So it's pointing. It's a pointer. But I'm just going to make it think that it's a remote repo. It's just somewhere else. And there are branches. So these are divergent paths to development, allowing isolated changes. You're absolutely going to know what branches are. You're absolutely going to have to work with them quite a bit. There is a branch known as main. It was formerly known as master. The word was changed because it was not a popular term anymore. And so now main is the new name. And this is usually the default branch or the base branch, if that makes sense there too. So we have clone. This creates a complete local copy of a repository, including its history. So this will create like a little .git folder. So it's not just the contents of the files, but some configuration around the Git repo. We have checkout. So this switches between different branches or commits in your repo. We have pull. So this downloads changes from a remote repository and merges them into your branch. We have push. This uploads your local repository changes to a remote repository. We have fetch. This downloads data from a remote repo without integrating it into your work. We have reset, so undoes local changes without options to unstage revert commits. We have merge. This combines multiple commit histories into one. We have staging files. This prepares and organizes changes for commits. It's not a command, but like it's just where you would work with your files. In the example here, I'm just going to get my pen tool out again. It's kind of over here. It has to relate with this up here as well. And so within staging files, we're going to have commits, which we already talked about prior. And then there's that add command, so adding things that will get committed. So hopefully that makes sense, and we'll see you in the next one, okay? Hey, this is Andrew Brown, and we are taking a look at version control services. And if you're thinking that we already covered this, it looks that way, but the other one was version control systems. This one is version control services. And yes, they have the same initialism, which is confusing, but it's very important to make that distinction because those are two separate things. So version control services are fully managed cloud services that host your version controlled repositories. These services often have additional functionality going beyond just being a remote host for your repos. Git is the most popular and often the only choice for a VCS. And we often call these Git-only providers Git providers. I need to also point out that some people call version control services version control systems and vice versa, and it just gets really confusing. So I did my best to make that clear distinction between the two. Okay, let's take a look at some VCSs. So the first here is GitHub, and it's owned by Microsoft. It's the most popular VCS due to its ease of use, offering and being around the longest, at least for Git. And they've always been very developer focused and super friendly. GitHub is primarily where open source projects are hosted and offer rich functionalities such as issue tracking, automation, pipelines, and a host of other features. I remember the day GitHub came out and I signed up for it because I was so done with using Subversion. Then came along GitLab. So GitLab was an emerging competitor to GitHub and at the time had unique features such as CI/CD pipeline and improved security measures. This is no longer the case as GitHub is now on par with GitLab. But yeah, at one point, a lot of people were looking at GitLab. Then there's Bitbucket. This one is owned by Atlassian. You might have heard of Atlassian before because they are the same company that makes Jira. And Jira is the most commonly used project manager for people in tech. So, even though GitHub is really great for developers, a lot of companies still use Bitbucket. And the interesting thing about Bitbucket was that they originally hosted Mercurial. So remember I said back in 2005, Mercurial and Git came out? Well, Atlassian adopted Mercurial, GitHub adopted Git, and Git won, and GitHub won. And so what's really interesting is that Bitbucket then eventually added Git and then sunsetted Mercurial. So everything basically is Git now. There is another provider called SourceForge. They're one of the oldest places to host your source code. They existed before GitHub. And they were the first to provide free of charge Git repository hosting to open source projects. The only thing about SourceForge is that they never really dominated because they just had so many ads and bad practices. And so it just didn't work out for them. They are still around, and a lot of open source projects like to only host there. They might make a copy to other providers like GitHub. But for the most part, everybody's on GitHub. But there you go. Hey, this is Andrew Brown. We are taking a look at GitHub, and this is a version-controlled service that initially offered hosted, managed, remote Git repos and is expanded to provide other offerings around hosted code bases. If you go look up what GitHub calls themselves today, they call themselves like an AI developer-powered platform. It's really bizarre because they are basically a host for Git repos with extra stuff on top of it. But I guess since AI is so popular, they got to try, right? But let's take a look at all the functionality that they have. So we have Git repository hosting. That is their main bread and butter. We have project management tools, issue tracking, pull requests and code reviews, GitHub pages and wikis, GitHub Actions, GitHub Copilot, GitHub Code Spaces, GitHub Marketplace, GitHub Gists, GitHub Discussions, collaboration features for organizations and teams, API access and development, so GitHub Development, they have a GitHub CLI, they have SDKs, we have security features like auto-detecting credentials in repos, they have education-specific things or course automation like GitHub Classroom, and I'm sure they have more. We're going to learn about all of these things because this is what the GitHub course is about, to understand the full offering of GitHub and to make best use of it. And just a fun fact is that GitHub was originally built in Ruby on Rails. Ruby is my favorite language. Rails is my favorite framework. So I've been on the ride or the train since day one with GitHub. So I know it pretty well. But let's jump into it, okay? Hey, this is Andrew Brown, and in this follow along, I want to show you how to create your own GitHub account. Every single developer on the planet should have a GitHub account because it's a great way to showcase your work. We'll talk about that later, but you can see that I'm already logged in here, so I already have a GitHub account. And what I'm going to do is log out, and I'm going to create a new one from scratch. So here we can see we can have multiple ones. I'm going to just sign out of all of my accounts here, and let's go ahead and create ourselves a new one. So I'm not sure. Remember I told you they're like the leading AI-powered developer platform, which is such a silly term. But let's go ahead and see if we can make a new one. So just in case it's the future and they've changed this homepage, I'm going to go up to sign up. And I'm going to see if I can make an account, if I can find an email that has not been used so far. So I'm going to type Andrew@ExamPro.co. If you're using Gmail, so I can't use that one. If you're using Gmail, you can use like plus signs to create multiple ones. So like my really, really personal email, don't email me because I don't ever check this one, is like omenking@gmail.com. You'll learn that my username on GitHub is omenking. Why it is that, I don't want to talk about it. It's like forever ago. I made this account like so long ago, and I really wish I could have got Andrew Brown as my username, but that's not what it is. And so I'm just going to go here and say alt. Okay, so this is a trick with Gmail that you can do. You can put a plus alt on it, or maybe a minus, I'm not sure. But let's go ahead and see if that works. And I need to create a password. So I like to generate really strong passwords. You can use whatever you want. I like to use, hold on here. I like to use this site, which is the Password Generator Plus, passwordgenerator.net. I should make a disclaimer, if this isn't secure, don't use it, blah, 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 but I'm pretty sure it's fine. So I'll usually go like 24 and get a nice long password. And I'll just generate a few different ones off screen here, and I'm gonna enter that in, okay? So just generate out a few, and I'm gonna drop this in on here. Okay, and we're gonna hit continue. Says it's strong, that's good. And then I gotta choose my username. So I probably can't get Andrew Brown. And so I need like another name. I'm gonna try Durano. Not available. That's like my gamer tag on Steam. So what's another one that I could have? We'll just say Andrew Cloud. Can I get that one? So hard. We'll just say Andrew WC Brown. Can I get that? There we go. WC is my middle initials. It doesn't stand for water closet, okay? I know it looks like that. We'll go ahead and hit continue. I'm gonna hit continue again. And so now what I need to do is do this verification. Please solve this puzzle so we know you're a real person. Verify? Okay, use the arrows to rotate the object to the face in the direction of the hand. Okay, use the arrows. So I think I have to make it face the same way, match the angle. Okay, this way. Okay. There we go. Create my account. And so now I need to open up that email. Just give me a moment, okay? All right, so I've been waiting a few minutes and I haven't seen anything, and I resent the code, so maybe it doesn't like emails that have that plus in there. It's totally possible. So I might actually have to go ahead and create a new email, which is quite the headache, as I've ran out of emails here. Unless I can think of another one. You know what? I think I have another idea. I'm gonna use a different one here. So it looks like unverified. Can I change this? I'm gonna try, because you have a privacy email, will be used for account related stuff. Yeah, I'm not really sure what's going on here. I thought maybe my account didn't exist, but it looks like it already does exist. So what I'm gonna do is I'm just gonna add another one. I can do Andrew maybe at teacherseat.com. We'll try that. Oh, it's already in use. Oh my goodness. It's so hard to get an email out here. Okay, let me just think about this for a second, all right? All right, another thing I'm gonna try is I'm gonna try maybe accounts at teacherseat.com. That's another one that I might be able to use. Okay, and then I'm gonna change this over here and save it. Great, and that should be my primary now, right? Oh, it really wants to send it to this one. Maybe what I can do is I can click. Oh, it looks like we have both. Okay, so we have this one. Please verify the. I'm going to get rid of this one here because that one's not working. I'm going to try accounts at teacherseat.com. So that's in my Outlook, so I'll go take a look there and see if I get it. All right, so this is working out totally fine. So over here we have the confirmation email, so I can go ahead and just verify that email. We can also just grab this link. I kind of prefer using the link here because that just gives me kind of a guarantee. And we'll go here, and now we're in. So this is exciting. It's been a long time since I've made a new GitHub account, so I'm not sure exactly what to expect. But it looks like we have some places we can start a new project, collaborate with your team, learn how to use GitHub. Hey, I'm already doing that. You don't need to do that, GitHub. Let's go ahead and skip this for now, and we should get back to our main dashboard. So we are now in, and we have an account that we can use. So yeah, that's all I wanted to show you in this video, but I'll see you in the next one, okay? Ciao. Hey, this is Andrew Brown, and this fall along, I just want to show you that I'm going to be setting up multiple accounts to quickly switch between them. If you want to take full advantage of learning how to use GitHub, you're going to need probably another account because you're going to have somebody else to work with. So I already have my primary account. I already showed you how to make an account. So what I want you to do is make a secondary account. I know it's a pain, but go ahead and do that. But what I'm going to do in this video is show you how you can log into both and switch between the two. And I'm also going to set up a repository that I'm going to put code examples in if we happen to put any in there. So what I'm going to do is go up here at the top right corner. I'm going to go add account. And so this is going to allow me to log into my other account. I can put in my username or my email. So this one is This is monsterboxpro.com. That's my old, my old company that's not been around for a long time, but I've never updated it. And the ExamPro email is on another GitHub account. But I'm going to go ahead and find the password so I can go log into this one. So just give me a moment. I'm just trying to find it. Here it is. There is the password. I'm going to paste it in here. Okay, we'll hit sign in. Okay, and notice it says GitHub Mobile. So now it's my opportunity to show you GitHub Mobile. So what I'm doing is I'm opening up my phone, and right away it pops up. It says, new sign-in request. Now it says reject or approve. I'm going to hit approve. It says authentication request was approved. The first time I had to do that, I had to enter in like a code, like 2 numbers. But now from then on, I just have to do that, and it's very easy to do that. So if I want to switch between accounts, we can go here and just switch between them freely. So that is really easy. And so what I want to do is go to ExamPro. This is my other organization. You'll learn about organizations in this here. That didn't really help. But what I want to do is create a new repo. I can create a new one up here in green, or I can go up here. I never notice these up here, but this is another place to do that. Anyway, you're just watching, you're not doing right now, okay? So I'm going to go ahead and hit new. And in here, I'm going to go to ExamPro. I'm going to say GitHub examples. So this will be the GitHub, or we'll say a repo containing GitHub examples for programmatic examples. For programmatic examples, this will be public because I want you to have access to it. I want to have a README. I'm going to create that repository. And so this will crop up later in the course. And you'll have to know where this is, but just remember where that is. But the key part of this video was how to log into another account and be able to switch between them, okay? So we'll see you in the next one. Ciao. All right, so what I want to do in this follow along is set up a GitHub organization. And the reason we want to do this is so that it's going to make it easier when we get to that section. So what I'm going to do is go to the top right corner, and I want to, I can make this an either or account. I'm going to make it in the alternate account because I already have enough organizations in my main GitHub account. And what I want to do is go over here to maybe organizations. And here it says, you are not a member of an organization. We could turn this account into an organization. I don't want to do that. Or we can make a new org. So I'm going to make a new org. And notice right away, it's going to hit us with some pricing. So, Teams gives you the full functionality. We just want to have the free one, which might have some limitations, but it should get us started. If there are things that we can't do, then I'll switch over to our paid one that I have in my account. But for the most part, we should be able to do pretty much everything as long as we're using a public GitHub repo. So I'm going to go ahead and hit create a free organization. And so I need some kind of name for this organization. I don't know, but we'll just say GitHub Cloud Learners or Journeyers. Okay, notice that's going to be the name of it. Let's say accounts at teacherseat.com. And this organization belongs to a personal account. We could say business or institution, but then we get a little bit more details there. So I'm going to just stick it to normal and go to personal account. Then down below, we need to solve our puzzle. So we've seen this one before. We'll rotate that out and we'll submit. Okay. And you'll have to name your organization, whatever you have to name it. But that's what I'm calling mine. You can put some numbers on the end here if that makes it easier. You could do like 4, 5, 6, 7 or something, because these are going to be unique names, just like your username. I'm going to go ahead and hit next. And so now it says add organization members. So we can go ahead and add some people. So what I want to do is I want to add Omen King. So I'm going to go ahead and do that. Please don't add me. All right. Add your own other account, your 2 accounts. Okay. We'll hit complete setup. And so now this person has been invited. I'm not sure if they're instantly added. Not yet, but I believe that I was, yeah, here's the invitation. So we'll go here. And so the invite has been sent and we'll have to go look for that. So I'm going to go over here and switch to my other account. Okay. And so now what I'll do is I'll click up here and maybe it's up here, my notifications. No. Do I have invites here? No. And maybe I got an email. I'll check my email. No email. And this is something you'll learn about GitHub, which is like invites are a pain and you always have to really figure it out. So I'm just trying to think about where that could be. What we could try to do is type in the organization name, which I thought we already did. So this one, let's see, my profile is this. Yeah, so the organization is going to be, what was it, Cloud? Oh, I don't even remember. We'll switch back to the other one. What a pain. Okay, and we will look for that organization. GitHub Cloud Journeyers. So I'm just going to copy this URL. I want the view organization. I want to go to this page actually. I'm going to copy it here. I'm going to switch back and I'll enter this in. And so now notice that it's showing me where the invitation is. So it says, Andrew Brown invited you to join this organization. View invitations. Okay. And I don't know if there is, but I'm just going to double check here because a lot of times GitHub will have like invitations. They might have a page for it. They don't. GitHub, if you're watching, make a /invitations page so we can easily find them across them here. So as you've been invited to GitHub Cloud Journeyers, ask for a GitHub Copilot seat optional. I guess this is kind of an upsell. They're like, hey, do you want to be able to use GitHub Copilot? But I'm going to go ahead and join this organization. And now I'm in there. So there's 2 people in here. Again, we'll come back to this later. I'm the member. This is the owner. You know, if your company is using GitHub, they're likely going to be using an organization. So it's good to get some knowledge on that. But I'll see you in the next one. Ciao. All right, let's make sure we understand clearly the difference between Git and GitHub. I don't think it's that confusing, but it is in the study guide or exam outline. So I'm just trying to make content that they want us to know. So let's do a comparison and go through some things to make sure we understand the difference. So Git is a distributed version control system, a DVCS, and GitHub is a version control as a service. I called it a version control service. It can also be called a Git provider, or you can call it a version control as a service. I'm just trying to get you exposure to all those different terms you could call what GitHub is. For functionality, for Git, it manages source code history. For GitHub, it provides cloud storage for Git repos. Of course, it does more than that, but that's its main functionality. For access, you're doing this via your local system installation, or it's basically wherever it's installed. But the point is that you're working on it on a machine, on a server, or some kind of compute. And GitHub is accessed through a web interface because it is a cloud service. For the scope, we're talking about local repository management. And then for GitHub, we're actually talking about the online collaboration and remote hosting. So anything that has to do with remote or things around the repo, the Git repo itself. For collaboration, it's for local changes, requires manual sharing. For GitHub, it has integrated tools for collaboration like issues and PR and a lot of other features. For usage, you're going to be using this primarily by the command line interface. There's definitely software out there that makes it a lot easier to use. We'll get into that, but generally it's a command line tool that you're using. For GitHub, it has a graphical interface and it also has its own CLI tool, but most people are interacting with it via the website. Okay, so there you go. Ciao. So a Git repo or repository is your Git repo, think of your local one, that you push upstream to GitHub to be hosted remotely. And GitHub allows you access to manage your repo with several functionalities. So here is a screenshot of a GitHub repo. This is when I ran a bootcamp in 2023. And so let's talk about what is on this GitHub repo page. I don't know what they want to call this page. I just called it the GitHub repo page for a specific repo. But you can view different branches, view tags, view commit history, explore repo files, view releases, see codebase language breakdown, view top-level markdown files. And so those top-level files might be the README, the license, security, other things like that. You can perform actions from this page or quickly to it, such as pinning, watching, forking, starring, cloning. So a lot of stuff going on this page, and this is going to be, we're going to be spending a lot of time or going from here to somewhere else, but that is a GitHub repo. So there you go. All right, in this follow along, I just want to give you a tour of GitHub repos so that you have a general familiarity so that when we start diving a bit deeper, we understand what we're looking at. So I'm on my dashboard and I have a lot of different repositories. And so I can go here and find a repository. I can search stuff and say, like, if I'm looking for my bootcamp, I can type in bootcamp here and then make my way over here and find it. A lot of times when you are looking for stuff, you're going to use the global search. So up here, you could do that as well. And I could find my own repos or other repos. There are a lot of open source repos on GitHub. And so I know Rails pretty well. So I'll go ahead and type in Rails. And so we have this Rails repo. I'm going to go open this up and take a look and see what we can see, because this is a very mature GitHub repo. And we'll make it very clear of all the functionality that's happening. So notice we have our main area. This is where all of our files are. We can actually view any of these files, so I can click into any of them. So I can go into the gem file, and it will show me the contents of the gem file. What I like about GitHub is that when you click into here, then you kind of get this file explorer, and it's extremely powerful. If I click this on the right-hand side, it will show me symbols. That's not a very good example. I might open up a Ruby file to show you what I mean. So I'm just looking for a Ruby file here. And so this will show you like places you could jump towards in your code. That's really nice. You can see who did what by going to blame. So we can see exactly what somebody's doing. By the way, I'm going really quick here. It's not important for you to remember any of this. I'm just giving you a tour of stuff. So just relax and enjoy the information that we're learning here. You don't have to write it down. If I wanted to find a file really quickly in this repo, I could go here and type something in. So maybe I'm looking for something like view. And so it's going to drop down and it has this fuzzy search. If I want to find a Ruby file, I could type this in, and we have a lot of them here. I believe there's a hotkey here. So if I hit T, if I'm over here and I hit T, it will bring me over there. I can switch branches really easily. Does that let me add a file? It's not my repo, but if I add a file, I'd have to create a fork. The search brings that up there, but we'll go back over to code, okay? So my point here is that you have all the files here and you can browse them. You can switch branches. You can go and take a look at all of your branches. You can take a look at all your tags. You can star, you can fork, you can watch. Here for code, you could launch this up in Codespaces, which is a cloud developer environment. I normally have Gitpod installed, so if I hit refresh, that button might show up here. This button, you will not have this button. I installed this because it's like Codespaces, but different. On the right hand side, you get a bunch of information about the repo, like stars, watching, fork. Some of these probably are conditional because I don't remember seeing these on my repos. You have releases, so maybe you are building up binaries like downloadable files that people can utilize. So some people, they will host all their code here and they'll build the binaries for quick downloads. So that's somewhere else you can go to. Packages is probably similar to releases. I don't think I've ever used packages ever in my life. Let's go over here and take a look. Browsing all packages. Yeah, I don't know what packages do. We can see who's using it, the contributors, so people that are writing code. We have the languages, so you can see this is mostly a Ruby library a repo, which makes sense because it's Ruby on Rails. Down below, we get a preview of our README file, so that is in the top level directory. They have a codes of conduct. I imagine that is a markdown file here as well. The license file, I'm sure that's in here as well. The security policy as well. So yeah, there's a lot going on in here. And then there's all this stuff up here. These are features on top of your repo. So lots and lots and lots of stuff. If we want to see our commits, we can go here and click on commits. And this is kind of like a tree. It doesn't give you the full view because when you are looking at a tree, there's branches and stuff. So we're missing that information here. But the idea is you can go here and go to different branches and look at those commits. And that's basically all I wanted to do here. We'll get into it a lot deeper later on, but that is your tour of GitHub repos. Ciao. Hey, this is Andrew Brown from ExamPro, and we are taking a look at Git commits. So we're going to take a look at a series of Git components. In this course, it's not really a focus on Git skills, but more so GitHub. But I want to make sure you still have some Git skills. So after we go through some of these things, I'll then do like a really quick and dirty Git command crash course, okay? So a git commit represents incremental changes to a code base represented with a git tree, so a graph, at a specific time. So here we can see that git tree. This is in GitHub, so it's not the full representation. When we go into VS Code, we can see a better representation of it. There are external tools for that, but for the most part, the idea is that you have git commits that are over a historical period of time. Then we have our git commit. Here is one within GitHub that I clicked through and I looked at, okay? And from here, a git commit contains additional modifications, deletions of files, additions and deletions of file contents, and it's not the whole file themselves. And this is a strategy to make the commits efficient, because if you were to store full copies in every single commit, your repo would get really big, really fast. I'm going to repeat that again, and we'll talk about the contents of commit files here just shortly. Each commit has a SHA hash that acts as an ID, so it looks something like this. We can use this to check out very specific commits, which is very useful. I want to repeat, Git does not store the whole files in each commit, but rather the state of changes. This greatly reduces the file size. So for developers, to the developer, it will look like a whole file, but really when you store it in your Git tree, it's not going to be like that. So what are the components of a Git commit? We talked a little bit about that, but we have that commit hash. That is a unique SHA-1 hash identifier for the commit. I don't know if it's really SHA-1 because I'm not really familiar with all the different types of SHA, but it's SHA something. We have the author information, so we have name and email. Often you have to configure Git to say what email you're utilizing in the name, so that's attached to the commit message or the commit itself. You have the commit message. This is the description of the commit. We're going to be spending a lot of time when you are making commits because you want to write good commit messages. You have a timestamp, so this is the date and time when the commit was made. You have the parent commit hash. This is a SHA-1 hash of the commit this commit is based on. I don't really understand that because I've never had to bother with the parent one, but it is something that's in there. And the snapshot of the content, a snapshot of the project at the time of the commit, not the actual files, but references to them and the changes that are occurring. So if you had VS Code open and we were taking a look at changes that we have staged, so they haven't been committed yet, but you can see here we have the commit message. It says remove old comments. We have files changed that we plan on putting in the commit, and you can see some deletions there on the right hand side. We can have additions. So hopefully it's very clear what a git commit is. You are going to need to know these basic commands, and we will get a little bit practice. Again, quick and dirty. This is not a full-blown Git course, but it'll be enough to get you by so that you can do the GitHub stuff. And so we have a bunch of stuff there like git add, git remove, git message with the -m flag to add a message, -a to automatically stage all track changes. If you have a commit and you haven't pushed it up to your remote repo, you can amend it. You can create empty commits. You can specify the author if you need to. You can check out a very specific commit. But yeah, that is Git commits in a nutshell, and I'll see you in the next one. Ciao. Hey, this is Andrew Brown, and we are taking a look at Git branch. So Git branch is a divergence of the state of the repo. There might be better descriptions than that, but that's the way I think of it. You can think of branches as being copies of a point in time that have been modified to be different. And so what I want to do is step you through what it would look like working with Git branches. And this is going to be a little bit messy, and it doesn't matter if you can remember or make sense of all this because it will make more sense when we start working with it, but do your best to follow along here. So imagine we have a Git repo. In that Git repo, we have a main branch. And basically all Git repos have a main branch, and that's pretty much the standard name for them now. And we're going to also have a production branch. So the main branch is where we're going to have code that features and bugs will be rolled up into. And then when we're ready to push it out for production, it will go to the production branch, and some CI/CD tool will push it out and automatically deploy it. So let's imagine we already have a commit in the main branch. Maybe there are previous versions in the production branch. We're not going to worry about it. So you have developer A. Developer A needs to work on a very specific feature. They're going to open up a feature branch. And in there, they're going to put in some commits, and they're working along. Meanwhile, in the company, somebody already has pushed some stuff into the main branch. It's not ready to go in production, but that commit is now out. So what's important to note here is that feature branch 1 is not aware of that new commit because things are happening in async manner in different branches. And this is the challenge with Git, is that you have to deal with all this async stuff and make sure you bring those changes into yours, deal with conflicts, things like that. Now let's say we have developer B, and developer B is working on feature branch 2. And when they started on their feature, they decided to branch from this point in time. Okay, and so they start working on it, and they get their feature done, and they talk to their the director of engineering, and they make a pull request. The pull request gets accepted, and it gets merged back into main. Okay, and so developer A, who's working on feature branch 1, has all these changes that they still don't have. So let's remember that they're going to have to deal with that at some point. But anyway, that feature got merged into main, and it looks like it's ready to go in production. So it gets merged into production. And so this particular commit contains, I'm going to get my pen out here, contains all of this information, right? And it's all packed into here, if that makes sense. Okay, I'm just going to erase that here. And so that gets pushed to production, and it gets tagged. A lot of CI/CD systems will trigger when a tag is applied. That's definitely how I do it. But now coming back to developer A, they're on feature branch 1, and they have all this stuff that they need to get their branch up to date. So what they'll do is they'll merge back in their direction. I know it doesn't show a merge, but they'll merge that information into feature branch 1, so they are now up to date. And they have now finished their feature by doing a bit of extra work. And so they've merged back into the main branch. And now their stuff is to be rolled out to production. So it gets merged into production, and then that gets tagged. So hopefully that gives you kind of an idea of this kind of workflow. This should have really been like that. And this actually has a very particular name. It's called the GitHub flow. Now, there are some variations of this, so that's why I say very close to it, because in case I'm wrong, I want to have that buffer to say that, well, I didn't say this is exactly the GitHub workflow, but this more or less is the GitHub workflow, where you are creating branches, feature branches, merging it back into some other branch, and then you have a branch for production. You can have branches for all sorts of things. You can have specific environment branches like staging, development, and production. You can have specific branches to developers, so like based on their names. You can have branches per features, branches per bugs. It's going to be based on what your team wants to do. All right. There are definitely Git branch commands you should absolutely know, and we will do, again, a quick and dirty crash course so you are familiar with it. This is a extremely common pattern that you're going to find that you'll be doing, which is you'll be creating a new branch for a feature. You're going to be adding changes. You're going to be pushing it upstream. We might do this via VS Code using the Git CLI. We might be doing this using GitHub, creating a branch from an issue, but we'll definitely be doing this because this is something that happens a lot in professional teams, is that they're creating feature branches. So hopefully that makes sense. And again, if it doesn't, wait till we go ahead and do it, and then it will make more sense then, okay? Ciao. Hey, this is Andrew Brown, and we are taking a look at Git repos. So these represent the reference to a remote location where a copy of your repo is hosted. So when I say remote, Git remote, I'm saying remote reference or remote ref. You might see those terms used all over the place. You can have multiple remote entries or remote references for your Git repo. And the most common one you're going to see is called origin. It's almost always there. Everybody seems to use it. It indicates the central or golden repo everyone is working from and represents the source of truth. The remote entries or references are stored in your .git config. We don't really talk about this .git folder in any of the slides, but the .git folder is how you know that your project is has a Git repo in it, because it needs that folder to initialize a Git repo. We'll look at that in the quick and dirty crash course. So in here, in the config file, you can see we have remote defined. So this format of a file is called a TOML file. So anytime you see those square braces and then definitions, that's usually a TOML file. But I'm just going to get my pen tool out here. But the idea here is we're saying we have a remote named origin, and the URL is pointing to our GitHub repo. This part says how it should fetch. I'm not going to get into that right now. And then down below, we can see we have some branches that we are tracking, and they're pointing to remote origin. And then they're saying that we want to merge there. So hopefully that is clear. Notice remote names can be referenced. So we have origin up here, and it's referencing this up here. Okay, so I'm just going to clear my annotations here so this is a little bit more clear. And there are a bunch of git remote commands you should know. I don't remember them most, like the git remote add. I don't ever remember that one because often when you clone, it's going to add them anyway. And so usually you pull them from GitHub, but you should know push, you should know pull, you should know fetch. And when you are creating branches, you should know how to push upstream. And we'll talk about upstream and downstream next, okay? All right, let's talk about the concepts of upstream and downstream. So imagine we have GitHub, who is hosting our remote repository, and then we have our local developer environment or cloud developer environment. This is local, basically, where we are doing our work. And so they both have a main repo because we know that Git is decentralized, so we can have repos in more than one place. We might already have some commits on the remote side, but what's going to glue these two together is going to be the remote. And so we set up a remote tracking branch, okay? And you'll see that term when you create and you push branches up because the idea is that it's tracking, the origin is pointing to main, so this is the way we track them. We saw that was stored in the .git/config. So when we go ahead and we perform a pull from our local developer environment, we call this downstream. We're pulling downstream. So a repo that pulls or clones from another repo. And just understand this is relative to the direction or the perspective of who's pulling. So if the remote was pulling, it would be downstream. It's anytime you're pulling, it's always downstream. And now imagine we have commits. We've been working locally and we want to push those up to remote. We would call that upstream. So this is when you are pushing changes. So that's upstream, that's downstream. And when we have a remote reference, it is a tracking branch. So there you go, okay? Hey, this is Andrew Brown. We are taking a look at GitHub Flow. So this is a lightweight workflow for multiple developers working on a single repo. There's a lot of variations on this. So this is not a technically perfect description of it, but there really isn't one. And I want to show you a really old graphic. I don't know how old this is, but I've seen this and older ones, maybe all the way back to 2008 at least. And I remember before GitHub Flow, because Git came out in 2005 and it took a few years to gain adoption. So for a long period, for a few years, we just had a mess of stuff. And then somebody came up with this. Maybe it was GitHub, I'm not sure, but it's called the GitHub Flow. And here we have a bunch of branches, and it looks very similar to the one that I showed you in Git branch. It's a little bit different. And so the big difference is that, well, first of all, we don't call it master anymore, we call it main. But my main was the develop branch, and then I would call this branch master. I would have called it production, because I think that makes more sense, and a lot of people do that these days. But when it first came out, this is how we were doing it. Okay, so understand this variation. But the idea is that you have this one branch, I call it main, this is develop, and it holds things that that hold feature branches or hotfixes and everything. It's basically like rolls everything up, but it's not in production yet. And so the idea is that when these things are ready for production, you can push them out into a release branch. A release branch could be also called staging. That's normally what we call it today. And this could be where it would roll out. So once you push stuff here, this could go out and execute a CI/CD pipeline, and it would set up a staging environment so that QA could be done on it, or any kind of load balancing could be done on it, or stress testing. there. And the idea is that as developers, you would open up feature branches off of develop, and as you complete them, they would come back in here and they would get merged in. And then when things were really ready, you take it from release branches and push it out to your production branch, which they're calling here master. If for whatever reason you had a serious problem you had to fix really quickly, you could create a branch off of master into the hotfixes and then merge it back in, skipping all the stuff down below. Again, I wouldn't do it this way anymore. I would be surprised if companies are sticking to this method, but this is the original way. I just wanted to show you that there is variation. And a lot of people do skip having a release branch and they'll just deploy often and into production. So it's going to be really dependent on your team. So here we'll just kind of loosely describe GitHub flow. You create a branch for each new task or feature, create a new branch off the main branch. Add commits, make changes and commits, commit them to your branch, open a pull request, start a discussion about your commits, reviewing code in the pull request, discuss a review, share your pull request with teammates for feedback, deploy, test your changes in production environment. Yeah. Oh, and the last thing would be merge. So once your changes are verified, merge them into the main branch. So that's the general concepts of it, and hopefully that makes sense, and we will see you in the next one. Hey, this is Andrew Brown, and we are taking a look at the GitHub CLI. So this is a command line interface to interact with your GitHub account. You can quickly perform common GitHub actions without leaving your developer environment. And if you went through the quick and dirty Git crash course, then you definitely got some exposure to GitHub CLI, but the idea is that you'd have to log in and you can perform actions there. So we have something like creating a repo, creating an issue, reviewing a PR. There's a lot of CLI commands. The GitHub CLI can be installed on Windows, Linux, or Mac OS. That's an example of using brew to install it if you have it. For dev containers, you can specify it as a feature to get installed. So that is a very easy and quick way to have it installed there. And just to give an idea of commands, we have our core commands, we have a lot of additional commands, and then we have one specific to GitHub Actions commands. So we're definitely going to get some exposure to a GitHub CLI in this course, but there you go. All right, so in this follow along, I want to take a look at the GitHub CLI and see if we can do a few different things with it. What I'm going to do is switch over to my other account. This is just my play around account for GitHub. And we should already have a repo in here called GitHub Examples. And what I want to do is I want to just do some things in the CLI. So I need some kind of environment to work in. And so what we'll do is launch up a code space. We do have this older one. I think what I'll do is make a new one. I don't think it really matters if we make an old or new one. That other one is stopped. So we'll open this one up and we'll see if the GitHub CLI is already pre-installed. It could be pre-installed on this because I would think that if I was GitHub, I would have it pre-installed so people could start using my product right away. But if it's not, we'll definitely go ahead and take a look at how to install it. We did install it manually locally in the Git crash course, the quick and dirty crash course. So if we don't have to show the install, I'd rather skip that, but we'll wait for this to spin up, okay? I have no idea why, but that took a little bit time to spin up. Our goal isn't to really make anything, just to play around with the CLI here. The code space is currently running in recovery mode due to a configuration error. I didn't do anything. I don't care. It's, it's a new environment. Why should it be recovering? Is there something it can't do? Yeah, I'm not sure about this. So what I'm going to do, because I don't trust this workspace, is this one is running here. I don't know. We'll just see what we can do with it. But it didn't pick up my settings when I told it to save it earlier. So I don't know if it's because it's in recovery mode or not, but for the time being, I'm going to go ahead and change the theme so I'm not upset. There we go. That's a lot better. And I want to see if we have GH installed. So it's not installed, which is totally fine. So what I'm going to do is, if we had this installed, can we install it through here? Sometimes you can install stuff through plugins, right? And so I'm just curious if we could do that there. No. Okay, so that's fine. We'll go ahead and install this. And I definitely know that brew is installed Or maybe it's not installed on this. Let's find out. It is installed on Gitpod, but I'm not sure about GitHub. It's not. Okay. So what we'll do is we'll look up the GitHub CLI and we'll go ahead and install it. We already did this before, but we'll do it again. And what we're looking for is those install instructions, and we want it for Linux. Okay, so we'll go over into here, into Linux, and we'll grab this one-line command. It looks like a lot, but it's really just doing this update and this install, like down here. But it has to add the repo so it knows where to install it from. But I'm going to grab that big thing there, and we're going to go ahead and paste that on in, say allow, and hit enter. And it failed. It failed. And I can't see what I'm doing, so I'm going to bump up this font. I do not like GitHub Codespaces. I'm so sorry. I really like Gitpod. And we're going to go here and say terminal font. I'll try not to complain too much about it in the course, but I can't promise anything. I'm going to copy that again, and we'll try this again and hit enter. No such file or directory. Okay. Yeah, I don't know what you want. So there's this line here. Okay. Maybe because GPG isn't installed. Sometimes you don't have to do a GPG check, but we might have to with this. And failure to write destination. Okay, so if that's not working, maybe what we could do in an easier way is we could just add it to this file, this Codespaces file. So we could just make a dev container, and maybe that would be less of an issue. So what I'll do is I want to add a dev container. We'll go up to here, dev container, like that. We actually already have one from before, and maybe we can just throw it in here. So I'll grab this. Maybe we do want to commit this. Maybe this is a good idea. And so I'll put this here, and I need a comma there. And so the idea here is that this should install the CLI into this environment. And maybe the reason why this thing messed up was because it wasn't specifying any base image. And that's why it got upset. Because when we did this in the tutorial earlier, it kind of complained. Or sorry, like when we spun this up, it complained. But we didn't specify a base image. So I'm going to look up what the base image is for dev container. The base image for GitHub is. And maybe that will help us. If that doesn't help, let's go ask ChatGPT. Log in. Let me in. Let me in. Come on. I pay for this. Let me in. What is the base image used for dev container for GitHub Codespaces? Let's see if that can figure it out. It's probably just going to go to the documentation, but I don't remember where it is. So if you don't specify one, it will create in the default one. Okay, that's what I would rather it do. So I'm going to leave it alone. And what I want to do is rebuild this environment because we've added this change. Before we do, I need to commit this maybe. So I'll just say it should install the GitHub CLI. We'll go ahead and do that. And I'll say OK. So it should sync it up. Good. And so let's see if we can find the rebuild. So I'm clicking up here, rebuild. That's no good. We can open up the command palette this way. Command palette has all the commands for VS Code. And there should probably be something for Codespaces. So if I type in Codespaces, there's probably something here to rebuild. There it is. Rebuild container. So I'm going to go ahead and rebuild that container. I'm going to go ahead and hit rebuild. And so I'm hoping that will install the CLI and that avoids us having to install GPG or whatever it wants because that's a headache and I don't want to deal with that. So see you back here when this finishes building, okay? All right, we're in. It says the Codespace is currently running in recovery mode due to a configuration error. Please review the creation logs, update your dev container as needed, or rebuild the container. So it clearly doesn't like something about my file. I'm not really sure because there's not a whole lot in it. So we have Command Control Shift P. Okay. Control Shift P. Hey, like learning's learning, right? And we want to view creation logs. Oh, that's just to open up the command palette. View creation log. And somewhere here it's messing up. Now, I don't understand how it could be messing up because we literally have next to nothing in it. Yeah, this is supposed to be an easy GitHub CLI tutorial. Failed to create the container. An error occurred. Unified containers error creating fail. Doesn't even tell us why. It's just like, nope, it doesn't work. Maybe it's up here. No matching entries and unable to find user dev container. Okay, maybe it's this. Okay, let's take this out. All right, and that's probably the reason why. Okay, so we'll save that. Okay, we'll have to update that. Don't change remote user. Okay, and we'll push to main, and I'm going to try to rebuild this again. I'll open up a command palette down here below just in case. And I want to say rebuild. I want to do like a full rebuild. Let's do a full rebuild. That's fine. Let's rebuild. And we'll get it going this next one. Okay, I'll see you back in a moment. Okay, so I think that resolved the issue. It took a while for that to rebuild, but what I want to see is if the CLI is in here. So I'm going to type in GH. And there it is. Okay, great. So that's the easy way to get in there, as long as you don't make any mistakes in your dev container JSON or JS or JSON file. And so let's go ahead and see what kind of actions we can perform. So what I'll do is go over and type in GitHub CLI, and we'll take a look at the documentation and see. That's not what I want. I want the official documentation, so we can see what kind of commands we can get. Here it is. Okay, so here's all of our commands, and the question first is, are we logged in? Because that's something we might need to do. So let's go ahead and type in GH login. Oh, sorry, GH auth login to log into the CLI. And we have two options. We'll do github.com. It says the value of the GitHub token environment is being used for authentication to, okay. So it sounds like we already are authenticated because of GitHub code spaces, and it's loading some kind of temporary token in here. Something we could check here is to see if there actually is a token being set. So I'm going to type in env grep, and we'll type in gh. And I don't see anything there, but apparently it seems to think that it is ready to utilize. So maybe what we could do is list out repos. So I imagine if we go here, there's probably something like list. There is. And we could try to list our repos. So let's go ahead and try that. GH repo list. And we have a repo. And that's actually a really nice display. What else could we take a look at here? So again, back over to the repo. We can list our repo. What if we go to view? What would that do? Let's take a look. GH repo view. And I was hoping that it would select the current one, but apparently it didn't. Well, we can do GH repo set default, and we got to type it right. Maybe it'll let us choose the repo so we don't have to goof around. And so there it is. We can choose one, and apparently we have two: ExamPro Co. and the Andrew W.C. Brown. Curious that it's showing forked ones, but this is the one I want because this is the account I'm in right now. And so let's go ahead and type in GH repo view. And so now we can see some stuff in here. Not a lot of information. It looks like it's kind of the information about maybe the description or stuff like that. So I was hoping to see a little bit more there, but that's okay. Let's go down here and see what else we can do. We could edit our repo. Like we could change features, turn things on or off. That's not that interesting. Something we might want to do is maybe we might want to maybe change our labels. Let's go ahead and try that out. So I'm going to go here and say GH labels list. Is it just label or labels? Label. Oh, cool. Yeah, and we can see our codes. Can we add a new one in here? We'll go to create. So GH label. So we try this one here. Copy it, paste it in. And there already is a bug, so we can't have two. So I'll go here and just say danger. Something really not right. We'll hit enter. And so it looks like we've created another label. Let's go ahead and hit up. Okay, so it looks really good there. Bug isn't working, good. If we wanted to create a new repo, sometimes what they'll do is they'll create like a wizard in here. So if I typed in gh create repo and I said GitHub, we'll just do this. I bet it will prompt us. Oh, I got to type it right. I seem to be typing everything wrong here today. Repo create. And so it'll ask us some things like create a repo from a template repository, make a new one. So I could do this. I could say GitHub repo, GitHub CLI example. And I'll just go hit enter here. I'll just make this one private. I could add a README file. We could add a gitignore. We could say what we want the gitignore to be. So maybe it's for C++. Yeah, let's add a license. We could choose Apache 2.0. We want to do this. We'll say yes. And it seems like it should have created, but we get a resource not accessible by integration for 403. So I'm not 100% sure as to why we're getting that. It could be a permissions issue because everything is based on that token, right? And so maybe we have a personal access token that allows us to read but not write. And we got a 403, right? So 403 error is for forbidden, meaning we don't have access to do it. So what I'm thinking is that we can probably create our own personal access token and try to get around that. So I'm going to go to settings here. I'm going to go all the way down to developer settings, and we're going to go into personal access tokens, fine-grained tokens, and we'll generate a new token. Again, I don't know if this will work, but I'm just going to try it. So we'll just say repo access. Right. Let us create a repo. And I'm going to set this for tomorrow because I don't need it forever. And if it's for all repos, then that's a challenge, right? But then how would you create a token? This is public repos. So here it says, this applies to current and future repos owned by this resource. All includes public repos read only. So the other question is it because we tried to make it a private repo? But then why would it have it as an option if we can do that? I mean, we could also authenticate via SSH. So I'm not sure. So I guess that's where I'm not 100% sure. So maybe we'll just say all repos here. And we'll go to repo permissions. And I'm looking specifically for repos. Contents, no. And carefully looking here to try to find that. Account permissions, maybe? It feels closer to this. Type in repo. Let's see here. So what does this one do? Interaction limits. Interaction limits on repos. I don't think it's that. And so I'm just carefully looking to figure out what functionality we would have to provide. Managing repository environments. It could be this. Read write. I would probably put this in just because that is the usual. Oh, repo creation. It's up here. So I don't think we need these other ones. I'm going to leave them on because they're not that big of a deal. And this one says it's mandatory, so sure, we'll have that in there. Got it added in there. I'm going to go ahead and generate this token. And so now we have this token. I'm going to copy it. I'm going to go over to here. I'm going to type in export GH token, and I'm going to go ahead and paste this in. And so the idea is that when we use the CLI, it should pick up this as opposed to what else is on here. So type in env-grep because I want to make sure that this is actually set as our environment variable. If you have other tabs open here, it might not show up. So just stay on the current tab. We'll go ahead and try this again. Another reason why it might have not worked is because that name was already taken, but I don't think so because it's scoped based on our user. So we'll go ahead and try this again from scratch. So say GitHub CLI example, and then we'll say, we'll put nothing in there. We'll make it private. And it was interesting, there's a visibility of internal. I imagine that maybe that's for enterprises. We'll say yes, yes, and it doesn't matter, I'll just choose that one. We'll say yes, doesn't matter, I'll choose that one, and we'll say yes. Let's see if it works now. Clone the repo locally. Yeah, sure, let's do that. And so now it's working. So whatever key, whatever personal access token that is somehow being loaded in there did not have the correct permissions, we were able to get around that. So I don't really want this repo, so I want to go ahead and delete it. Let's go take a look and see what actions we have there. We have delete. So I'm going to hope that it just will like give me a wizard so I don't have to pick it. So we'll say gh repo delete. And I don't want to delete our current one. So I'm going to hit Control C because that's totally not what I want. And we'll go back over to here and we'll take a look and see what we can see for the repo. I really wish they would list them up here. Maybe if we go to the getting started or available commands. Yeah, that's a little bit easier. It's not great, but we'll go to repo here and we'll go to delete. And we can put the repo name here. So we'll go back over to GitHub here. We'll go to our names. This is going to be Andrew W.C. Brown. And we should be able to see 2 repos in here. There's our other one. I'm going to grab that name. And we're going to go back over here and I'm going to say that. So do I want to delete it? So type the name again, sure. And we have to put in also the username in front of it. We'll hit enter. And that repo should be now deleted. We'll go back over to here. Okay. And it's deleted. So that is in good shape. So that's all good. So I'm really happy with that. I'm going to go ahead and stop this code space. I'm just going to delete it. And I'm going to delete the other one. I'm just going to make sure I keep everything nice and clean and not worry about overspend. And what I want to do is just merge this into my other account. Again, you don't have to do this. You can just watch me do this, but it's good to watch because this is something that people have to do a lot. And actually what I should have done is I should have gone over here and I should have done it from here first. So I'm going to go here and create a PR, create a new PR, and we'll say create. Is it going in the direction we want? Yes, it is. We'll hit create. Fix dev container. We'll create that pull request. Good. We'll switch back over to our other account. And then I'm going to go into the same repo. I'm going to accept it, confirm it, and we are in good shape. I'll see you in the next one. Ciao. A common strategy for authenticating to perform Git operations on your remote GitHub repo is by using an SSH key. You're definitely going to want to use this because it is a great way to work with Git in your local developer environment. It's definitely the way that I like to use it as opposed to using a personal access token. But the way it works is you'll have to generate out your own SSH key using a command like SSH keygen for Linux. There's probably different ways, but that's the way that I know. And specifically an RSA key. I'm sure there's different kinds of keys that GitHub will take, but that's the one that I know. And so the idea here is that we have our computer, our local computer, and then we have the server, which is GitHub. And the idea is that there'll be a copy of the public and private key on your local computer, and then on GitHub, you'll store that private key. And so the process of authenticating and authorizing is going to go like this. So the server checks to see if you have the same public key. If you both have the same public key, it's going to send you a challenge message. That challenge message contains the public key encrypted. And so it's going to send that on over. And then the idea is that the private key on the local computer will decrypt it. And then it will be able, once it decrypts that message, it will then take the private key and do something there and then send back well, it won't do something. It'll send back a signature. And then that signature will be sent to GitHub and then they'll verify it and that will establish that connection, allowing you to use SSH keys to get clone or push or things like that. Under your account settings, SSH and GPG keys is where you'll be able to add the public keys. So here you can see I have a couple SSH keys in one of my GitHub accounts and it's there under SSH and GPG keys. And when you want to go use
or clone a repo, you're going to really want to use that SSH style address. It will not work with the HTTPS one or the GitHub CLI one. Technically, it will work with the GitHub CLI one, but that's what you're going to want to do there. So there you go. In this video, I just want to show you quickly how to create SSH keys. We did cover that in the quick and dirty Git crash course, but it's good to do things more than once so that we really get good at them. I'm going to open up a new environment here in Code Spaces, and we'll get that spun up. So I'll see you back here when this is ready, okay? All right, so we have this environment spun up, and it's just not remembering my settings whatsoever, but you know, that's just how things go. And I'm going to make a new folder in here. I'm just going to call it SSH keys. And I'm going to just go ahead and make a new README file. So normally what we'll use is the SSH keygen command. I realize that's small. I'm just going to jump it up like that. And so we use TRSA to make an RSA style key. I would imagine that GitHub can support different kinds. Not that I know much about the different kinds. Let's go take a look here and see what we can see. So that's from local. I'm going to go ahead and delete that because I don't need that right now. If we go here, you can see things like SSH, RSA, SHA-2, something like that. So it'd be interesting to generate something else out. So ECD, SSH keygen, ECD. So I want to see if we can generate something that's a bit more secure. I assume it's more secure. It's a relatively new cryptographic solution. It's been around for 5 years. Okay, so how do we make it? And the way we make it is probably by supplying this like that. Okay, great. So what I'll do is go back over here and we'll change it from RSA to this one and see what happens. I've never done this before, but I imagine it's super simple. And I'm going to cd into the SSH directory. I'm going to go ahead and hit enter. Say allow. Yes, I want to paste. We'll hit enter and see if it can do this. And so we'll go ahead and hit enter. It will create it in the CodeSpace directory. So I suppose that's fine. And we'll do that and that. And so then we're going to get that key. And then the idea is that we can then go ahead here and then we could go and cat out the contents of it. Right? All right, and so we could copy this. And it's actually a lot shorter. That's actually really nice. I like that. And then we could go over here and then we could add it. So just say cloud developer environment for CDE. And we could add that key. Now I want to point out that you can add keys to repo as well. So we're not going to really test this to make sure it works. I just wanted to generate out another one and show you that. But what we'll do is we'll go over to our repo because I want to show you where that deploy keys things is. And if we're in a repo like this, we can go to our settings and there should be deploy keys down below and we could add a deploy key and it's the same process. You just paste it on in, you say what it's from, you can say whether you want it to have a write access and boom, there you go. But a lot of these repos only need read-only. So especially if you're building, you're just cloning the repo. So you don't need that. But that's all I wanted to show you. So I'm gonna go ahead and commit this. Okay, so we'll just say basic instructions for SSH. Okay, so that's all good. We'll say okay. And then what I'm going to do is just switch into my other accounts. And I probably can merge the other way too, if I try that. So if we go here to pull requests, we go to new pull requests, and I could probably try to grab from that other repo. So I want to bring in from here, from there. Yep, I can do that. And then I'm just basically allowing myself to pull the changes in without the other Andrew having to put it forward. Okay. There we go. And we are merged. I will see you in the next one. So deploy keys allow you to attach public keys directly to a Git repo. And the use case for deploy keys are if you're using, let's say, a build server or a CI/CD third-party service that needs to clone the repo so they can perform a build or deploy, or maybe single repo access. So instead of using a shared key pair for for multiple repos, you have a single key pair for a single Git repo. And another reason would be to avoid using the personal access token. I'm going to tell you, I've definitely used deploy keys, especially if you're not using GitHub Actions and you're using third-party CI/CD tools, which is pretty common with GitHub. You will find yourself using deploy keys. And I just want to make aware that's very similar to the other one with some advantages. So you have to decide in your use case where you're going to want to use it, but it's as simple as that, okay? Hey, this is Andrew Brown, and we are taking a look at personal account access tokens, or specifically personal access tokens, or PAT, which is an alternative way of using a password for authentication. Now, PATs are not specific to GitHub, but they do utilize them. And the purpose of these tokens is to give you access to the API when you're making direct calls or using the command line or using the SDK. GitHub no longer supports the use of using a password directly with interacting with the API. They used to, but now you have to use an access token. If you're coming from like the AWS world, it's kind of like your access secret. So it's giving you that access. There are two types of PATs on GitHub. You have the classic token. They're less secure and no longer recommended for use. Customers with legacy systems may still be using the classic token, like some of my apps. Then you have fine-grained personal access tokens. These grant specific permissions. They must have an expiry date. You can only access specific repos. Or if you want all repos, it'll probably only be read-only. You can only access resources owned by a single user or organization. You can find this stuff under the developer settings. There are a few use cases where we'll use PATs. It would be like logging in using Git clone for HTTPS. And let's say we are using the GitHub CLI. You could set a token, or sorry, an environment variable called GH token to be used for the GitHub CLI to pick that up. If you're using SDKs, you're going to be supplying your token. I would imagine that that these SDKs would pick up that environment variable as well. But there you go. Hey everyone, it's Andrew Brown, and in this follow along, I want to take a look at personal access tokens. Yes, we've already played around with them, but let's play around with them a little bit more. Okay, and so what I'm going to do is go over to my repo, and I might already have a code space from before, and it's already still active, so I'm going to go ahead and open that to save myself some trouble. If you have to launch a new one, you can absolutely go ahead and do that. Remember to close your code spaces so you are not using up your free tier usage. You get so many hours per month. I don't know what it is. You can look it up if you want to know, or we'll find out when we make it over to the code spaces section in the course. And so what I want to do here is I just want to work with personal access tokens. Now, we might have one set from before. So I'm going to take a look here and see what we have. So I'm going to type in env grep gh and see if there's anything set. And there's nothing set here, so that's great. And what I want to do is go to the top left corner here, go to settings, and then down below, we'll go to our developer settings, and we have our personal access tokens. We have fine-grained tokens and token classic. Now, something I would like to know, I'm going to go ahead and delete this one. What I would like to know is, can we generate them out from the GitHub CLI? You'd think you wouldn't be able to because then you need permissions to have permissions, but I'm going to take a look here and see what we have because I'm just curious to see if it's actually there or not. And so I'm going to just type in token, and there is a token. So it says this command outputs the authentication token for an account on a given GitHub host. Well, that's really interesting. So what would happen if we wrote that in? So I'm going to type in gh auth token and see what we get. And we actually get a token back. So I'm not sure if that means that that's that token code, but let's find out if it is by generating out a new token. Another thing I might wonder is like, what permissions do we have? I'm not sure if it would tell us. I don't think so. What's refresh? Refresh our token? Expand or fix the permission scope of the stored credentials. That's kind of interesting. Like you could go out and request to have more permissions, but I'm not sure exactly how that would work. But let's go ahead and generate a new token. I'll just say create issues. And I'm going to set this for 1 day. Okay. And we'll go down below and we're going to select it for a very specific repo, this one here. And I'm going to go to permissions. I'm looking for issues. We'll say yes to issues, read and write, and we'll go ahead and generate that token. And so we can see that's what this token looks like. We're going to copy it, bring it over here, and I'm going to set it to this. So I'll say GH token equals, and then a double quotation, paste it in, enter. And so now it should be set. So if I type in env grep GH, we should see it there. Excellent. So now let's type in GS auth token and see if we get a different value. Notice that this is the one we have. Now it shows that we're using a personal access token. So this is getting loaded in by GitHub. How it's getting in there, I don't know. But this one looks exactly to be the same as this one. Let's go test and see if we can make an issue. So go down below here and we will say create. And I'll scroll down and grab an example. So we'll do this, and hopefully it'll just know to create it in the current repo. Hit enter. And we need to set a default repo, so we'll go ahead and do that. I'll choose this one here, and I'll try this again. And so it's created it. Oh, this repo has issues disabled. That's interesting. So we'd have to go ahead and enable that. So I'm going to go back to our repo here. I'm going to go over to settings. And we'll go down below and we'll turn on issues. Now we could do this via the CLI, but it's just easy to checkbox that. And we'll go back to our environment and we'll hit up. And now it's created the issue. So now the question is, if I get rid of that token, like I unset it, what would happen? So what I'll do is I'll just hit up till we get to that set. I'm just going to purposely set it blank. Okay. And that way this shouldn't work. And so now if I do GH list, issues list. I wonder if I can get a list of them. Now, remember, this repo is public, so it's going to work because it's public. But the question is, can I delete the issue? So I'm going to say delete. And it's expecting some args. If I type help, will it tell me how this works? The number of it, that's perfect. So the number is 2, so that's easy. And I wonder if I can just put a 2 on this. Type 2 to confirm, yes. Okay, and deleted it. Now the thing is that yes, I was able to delete it, but just understand that this thing has some base access underneath that original token, and so it probably had permissions, this one here, to do that. There's probably some things that this thing can't do, and we learned that before, which was that being able to create a repo. You know, if I did this on localhost, I would assume that this would have not worked, and that's totally fine. I think that satisfies us for learning about personal access tokens. I'm going to go back to our personal access token, go ahead and delete it. And we'll call this one done. Okay, so I'm going to go ahead and go into personal access tokens and delete this. And if you want, you can stop and delete your code spaces. I'll see you in the next one. Ciao. Let's quickly talk about README files. These are markdown files that provide documentation and instructional information, and a repo, a GitHub repo that has a readme.md or readme in all caps or readme in all caps with .md in the project's root will be rendered on the homepage. There's actually some other markdown files that will also be rendered there, but it's really important to remember the README one, as it will probably come up as an exam question, and they'll actually ask you like where should this be located? It's always in the root. That's what's going to render. I don't think it renders anything else but that one, and they might try to trick you there. You do get this nice little table of contents on the right-hand side, so if you have headings, it will figure that out for you there. I remember that wasn't there before, so that's really nice. But yeah, it's as simple as that, okay? So GitHub wants you to know about basic repo navigation. What that means, I don't really know, so I'm taking my best guess to show you what that is. So within a GitHub repo, you will have a navigation bar with various features of your GitHub repo, and this is how you get to all the cool stuff. And the main one is code. This is where your code's going to live, such as files, folders, things like that. We have issues. That's for tracking problems. It's basically a ticket tracker. We have pull requests. That's where we're going to be when we're managing collaboration with other developers and they want to bring changes into our repo. It's our opportunity to check that work before it gets merged in. We have actions. That's for GitHub Actions. For projects, that's for GitHub Projects. For wikis, that's the wiki. Security is like a list or a checklist of things that you should do. I think it changes if you are looking at the context of as a user and you're not the owner of the repo. You're going to see maybe the security policy or different information. But if you are the owner, you're going to have a checklist of things you should do. And it basically mirrors kind of what's in the settings page under security. So it's kind of weird that they do that, but that's how they do it. Then we have insights. This provides statistics, mostly in the form of charts and graphs about the repo. Sometimes this information is public, sometimes it's private. Then you have settings. This is where you control all the settings for your repo. The other thing is that when you are using, at least in the code section, you can navigate around files. So I showed you this in a prior follow along. But the idea is you can search stuff, you can see the contents of file, you can comment on code per line. So there you go. So when you create a repo, you can choose which owner you want it to be. So right now I have it set as my personal account, but you could drop that down and you could also choose an organization that you belong to. Repo names are scoped based on the account. So you can have the same name for different organizations. Other people can have the same name if they're a different user. So just understand that you can do that. You need to choose an available GitHub name, again, based on that scope. Your repos can either be public or private. Pretty self-explanatory. You can quickly add a README file, a .gitignore, and license. It's very, very important to remember those three because you might get an exam question asking about the three things that you can quickly and easily add. If you're using the CLI, you can add it this way or create one. We did this earlier when we did the GitHub CLI kind of demonstration, and we found out that repos require special additional permissions or personal access token permissions that the GitHub Codespaces would not allow you to do. But yeah, there you go. That's how you create a repo. All right, let's go ahead and create ourselves a repo. I know we already know how to do this, but it gives us an opportunity to talk a little bit more about some of the things that might appear on the exam. You can create one up here in the top right corner. And I have this double click problem, so it's getting a bit confused. I can go to this new green button. That's usually what I do. And we can have a new repo. So I'm going to say my cool repo, right? We can provide a description. This repo is amazing. And we can set it as public or private. I'm going to stick with private for now, and we'll add a README. We'll drop down to gitignore. We'll say maybe we're working with Ruby, so we'll get that by default. And we'll add a license like MIT. We'll go ahead and create that repo. I want to point out that you have other things that are rendered here, so that should be very clear. We have releases and packages, which we should talk about at some point. I'm going to leave this repo around if we want to play around with it. Yeah, it's pretty clear how to create a repo. It's not hard. Let's go take a look at a more popular repo like Ruby on Rails. So I'm just going to type this up here and type in Rails, and we'll take a look and see what they have. So if we go into here, you'll notice there are just more things. We have codes of conduct, right? We have our MIT. We have our security policy. If we go up here to the security tab, this is what we can see. So we have the security policy being rendered out here, and then it's showing possible exposures, probably based on one of the scanners. I'm not exactly sure which one is showing that. But that is that there. If we go back to our own repo, we might be able to take a look at security here. Hold on. Going back to wherever that one was. We just made that repo. And it can be a little bit of pain to sometimes find your own repos. I'm not sure why they've never made that easier, but just how it is. And if we go down, we can find my cool repo here. And there's a security tab. And notice that it's listing out things that you should do for your repo. It's important to know what these are because, well, if you have this, the exam is going to probably ask you like, what things can you access from here? And this is just from the public repo. If you have a private repo, it's going to be different. Sorry, this is private. Public can be different. So let's just open this up and make a comparison and see what kind of difference there is here. So if we go over to repo here and we go into this public one over here, what options do we get? So we get a lot more going on here. So notice that this is the private and that is the public. Probably because if you had a paid version, you then get additional code scanning and secret scanning for public repos. You automatically get that stuff. I just want to point out that all this stuff is also under your settings, under security options. So they kind of just like repeat it there. you know, so it's just what they do. But hopefully that makes sense. And that's all I wanted to show you. So I'll see you in the next one. Ciao. Let's talk about maintaining a repo. Now, what's unusual about this slide content, it's not unusual, but it's the fact that in the outline, they have a whole section for GitHub administration. And for whatever reason, I have it over here as opposed to into the other section because of the way the outline is designed. So understand that I'm not going to cover that stuff in that other section because it's just repeated. But anyway, let's continue on and look at maintaining a repo. So the first thing is your name. So you can change the name of the repo if you do not like it. As long as the name is available, you can absolutely do that. And a reminder that repo names are scoped based on personal or organizational accounts or organization accounts. I keep writing organizational, but it means the same thing. You can change the base branch, the default branch. You can rename it. Just so you know, main is the unspoken best practice for naming your base branch. Everybody does it. The old one was master. Nobody calls it master anymore. You can opt in and opt out of some features for your GitHub repo. I say some as a catch-all just in case there's features that do not show up or there's ones that are locked in. But that's pretty straightforward. You just check a box and you might have to do some additional configuration. Then there's the danger zone, which contains actions you need to think twice about because they cannot be undone if you make a big mistake. And in the danger zone, we have the ability to change the repo visibility. It's important to understand what happens when you make a repo from private to public. The code will be visible to everyone who can visit at github.com. Anyone can fork your repo. All push rule sets will be disabled. Your changes will be published as activity. Now, will this show up in the exam? Probably not. I didn't see it, but that is something to consider. You can disable branch protection rules. So branch protection rules are strict workflow rules that will do something like disallow someone from pushing to main, and you can temporarily disable them if you have to apply quick fixes and you can't work around those rules easily. You can transfer ownership to somebody else and they'll become the owner of the repo. You can archive the repo so it becomes read-only. You can delete the repo. So there you go. All right, time for some repo maintenance. So what we're going to do is I want to create a new repo. I'm going to make it in my other account just because we're going to want to transfer it from one to another. But I'm going to go here and just say under here, Omen King, and I'm going to say my cool repo 2. Okay, and I'm going to just make this private and I'm going to add a README here. I'm going to go ahead and create this repo. Okay. So now this is repo created, we can go over to our settings. And let's say I didn't like the name 2. I need it to be 3 because we already have another one called 2 in the other account. I'm going to rename that and it renames. Before we used to rename, it used to take time. Now it's instantaneous, which is really, really great. If we scroll on down here, we could change the main branch. We could change the name to main 2. There are some limitations there because it's not showing all of our options as we don't have other branches. Apparently, it doesn't create it instantaneously, but it will change it in a bit of time. There it is. So I think it has taken effect. If we go here and yeah, it shows that it's been renamed. So that sounds really good. We're going to go back over to settings. Notice that we can checkbox on and off features. Let's get rid of issues. Let's get rid of projects. If we go over here to our code, notice that they have vanished across the top. So that is great. We'll scroll on down. We have more abilities somewhere here in the danger zone. So we can change our visibility. It will give us a warning about it. I'm not sure why it's making it so hard. I'm going to make this public. I'm going to say that I accept the changes and we're going to make it public. And then apparently I have to confirm. So I'm going to get out my phone and it wants me to enter a number into my phone. Okay, so 37, approve, great. And I'll wait a moment for it to take effect. There we go. So now it is public. We can disable our branch rules. So I'm going to go ahead and do that. We can go ahead and transfer this repo. I'm going to send it to a specific person. So this is going to be, I want to send it to Andrew WC Brown, which is the other me. And then I got to type in the repo name. So we'll go ahead and do that. My cool repo 3. I understand. Okay, so now it should be transferred. And I think the other person has to accept. So I don't think it's instantaneous. So if we go over here, do I have the repo now? If I go up here, my notifications, how do I see the repo transfer? I'm not sure. I'm going to go check the email for this account and see if it shows up there, okay? All right, so in my email, we can see over here that there is a repo transfer link. So I'm going to go ahead and click that. GitHub repo templates is a feature for public repos that allow other GitHub users to make a copy of the contents of the template repo to use as a starting point for their own repo. And I believe it's only for public. I haven't checked for private, but I don't know why you'd want to use it for private. We set a repo as a template by checking a box on the template repository. And then you'll have this option to use the template. And when you click use this template, it will then ask you to choose a new name, and it'll say, what do you want to include? And then it'll show that that was generated from that other template. I use these in my boot camps because I will create a starter project, and then you will start from that template. How is this different from cloning or forking? The idea here is that you're starting with a clean repo. You're not having all the baggage of stuff that comes with it. It is a really clean repo. And so that's how you're going to go ahead and utilize it. But that use case that I explained for, which is like, you want to have something like a project that people are going to start as a basis of, that's where you're going to be using repo templates. Okay, ciao. Hey, it's Andrew Brown. In this follow along, we'll go ahead and make a repo template. So we have here, let's go over here to our other repo. I'm trying to find it. Sometimes it's a bit hard to navigate repos. There we go, that's a bit better. And so we have this my cool repo. What I want to do is convert this repo into a public repo for now, just so that we can utilize this feature. I want to go to the top and see if we can make a template. Actually, it looks like we can. I'm really surprised because what would be the point if it's private? You know what I mean? Because we go here, how's anyone going to click that button? It doesn't make any sense. So I really think that that is a public feature. And notice I actually checkboxed it on and it turned off. So I think it is. Yeah, it is. Nope. Okay, it's on now. All right. I mean, I guess you could use it to make your own from it. So I guess my thought was it was always about other people using it, but I guess you could make your own default template and use it for yourself. So I guess it's not just a public feature, but they're never going to ask you on that exam, so I'm not going to fix the slides because of that. But let's go ahead and create a new repository from this template. We'll just say my cool repo 2, and we'll make it private. And notice we can include other branches, but I don't want anything else. And there we go. So now we have this repo that is making a copy of. We'll give it a moment. And here it is. You can see it's generated from that one. And there you go. Ciao. So in GitHub, you can clone a repo programmatically 3 different ways. We have the first, which is HTTPS. You will have to supply a GitHub username and password on the clone, and you'll need to set Git to cache the credentials if you don't want to keep entering them in. I didn't write it in here, but when it says password, we're talking about the personal access token because GitHub does not let you use passwords anymore. But in the documentation, it kind of suggests that you can use a password because it says password protected. Oh, not here, but under here it would say that. For SSH, you can utilize that method. You'll have to have an SSH key pair, and you'll have to upload that to your GitHub account. Then we have the GitHub CLI, so we can do that as well. This is going to use credentials when you do GitHub login. It'll actually use either a personal access token or SSH. We can also clone repos in the GitHub desktop, and we can just download a zip. It's not really cloning, but we can download the contents of it. So that's pretty straightforward there. Sometimes you just want the code's repo. I want to point out that we did all this in the quick and dirty Git and GitHub crash course. So if you're wondering how to do these 3, make sure you have watched that video and you've done it all, okay? See you in the next one. Ciao.
You can add files to your GitHub repo directly via the GitHub UI. If you drop down code, add file, you'll have create new file or upload files. So it's great for both text and binary files. The idea here is that when you go ahead and add a file, if you need to have folders, you can put a / and it will end up creating as many folders as you want. And then you put the name in and you just create that file there. When adding multiple files that you also need to edit, you can also quickly use github.dev at no cost. But yeah, that folder trick is something that you should really want to know how to do. And we did show it somewhere in this course, but there you go. There are lots of ways of creating branches in GitHub and Git. Something that you should really know how to do is to use this single line command git checkout-b to both create and check out a branch in one go. You should absolutely know how to do git push-u origin staging, which is basically the -u is short for -- set upstream. I know it looks like a single hyphen there, but there's actually two for this flag. You can create branches from issues, and then the branch and issue will be associated and linked. You can directly create branches in the GitHub UI. You can create branches in the GitHub desktop, and I'm sure you can create branches in the GitHub CLI. And yeah, there you go. Hey, it's Andrew Brown, and this fall along, I want to create some branches. Nothing super difficult to do, but something that will take us just a moment. I'm going to go ahead and use our My Cool repo. And what I want to do here is I want to go ahead, actually, I want to clean these up. I don't want to have a bunch of junk repos hanging around. So actually, I decided against that. And I just want to keep things clean and keep with our single repo, even if it is public. So I'm going to go ahead and type My Cool repo here and clean this up. Andrew W.C. Brown. Or, oh, man, geez. Andrew W.C. Brown, My Cool repo. It's that autocomplete that's messing it up. There we go. And I'm just going to go ahead and also get rid of this one. And then we'll just be really focused on what we need to do at hand here. Just give me a moment. There we go. Okay, so now let's just go back to our GitHub examples. And there are a few ways that we can create issues. Branches. One way is to go to the branches tab, and I'm pretty sure we can just create them right here. So I can go here and just say feature cool one, okay? And we can say what we're branching from. So that's an example. And there it is. Another really useful way, and something I really recommend, is you create an issue, and we'll make a task saying create a branch from an issue. Okay, and then what we can do is then go ahead and create a branch here in development in the bottom right corner. Notice it's going to put the number in here. That's a very common pattern, is to have whatever your issued number is and then a short name for the branch. Okay, then it's saying like, what should we do next? Code spaces, locally. I don't really want to do anything next. I just want to do nothing, but I'll go ahead and hit create branch. And so then it gives us like a button where we could click to go ahead and play around with it. So that is something I do a lot when I teach boot camps. I show this a lot. This is a very common workflow and something you should absolutely remember that you can do. Let's go ahead and launch up this in code spaces. So I'm going to go here and we have this one here. Sure, I'll launch up this old one. Sure, why not? And once this is launched up, we'll take a look and learn how to use a very cool shorthand for implementing checkout and creating a branch in one go. Okay, so just back here when this is ready, all right? All right, so this is back up and running, and notice that we are currently in the main branch. We can type in git branch to get a list of branches. And so what I want to do is I want to create myself a new branch here. And actually there are other branches, it's just not showing them. If we do git pull, it might show us those other branches. There we go. And now if we type in git branch, it still doesn't show them, but that doesn't mean we can't check them out. But our
program is aware of it. We might also be able to create branches within a Git graph. These were things that we installed earlier. So they might have the option to do that here. I'm not 100% sure. So you create branch, so we could do that as well. I'm not going to do that. But what I really want to show you is something that will show up in the exam. I'm actually really surprised that it did, but it is a really good thing to know, is that normally when you create a branch, you'd have to type in git branch, and I'd say my new branch like this. And then I'd have to do git checkout my new branch. Okay. And so that's something you can do. But what is more efficient, I'm just going to check out back to main, is we can do that in one call. We can say git checkout -b for branch, my new branch 2. And that's going to create that branch and check it out. So really make sure you remember this one, because it will absolutely show up on your exam. It's absolutely something you'll use every single day, and I strongly recommend it. The last thing I want to go over is just pushing to origin. So what we can do is set upstream, but I think that U is a lot easier to do. And we say origin, and we just say my new branch here, 2. And then that will push that branch up there, because you really want to know how to set that origin. So that's all I really wanted to show you. And yeah, we can just stop this environment. So we'll go ahead to command palette, just say stop current code space, and I'll see you in the next one. Okay, ciao. So GitHub Releases allows you to create releases with release notes and linked assets, such as zip sources or binaries for specific platforms. So in a Git repo, you'll see releases, and from there, you can read about the release and see all the stuff that has changed. And there might be the source code or binaries. If this is something like, I'm trying to think of an example, like let's say you like to play video games and there's an emulator for like the PlayStation. They'll have like builds here for Windows, Mac, and other things here. Maybe you make a video game. In general, you could distribute the binary here. It's anything where you're distributing the binaries or the source code, but you're making it very clear what has changed as a release. And often, like when I'm having issues with something, I will actually go through and read the releases when, let's say, like React Router. Have you ever used React Router or DOM and they've changed versions? I'm trying to understand like what compatibilities have changed, what does not work anymore. Maybe I was experiencing a bug. And if they do a good job with the documentation, it will be in there. So there you go. Hey everyone, in this fall long, I want to take a look at GitHub Releases, as it is a very useful feature to let people know about changes that are happening in your repo. So before we do, let's go take a look at some other project that might have changes. I'm trying to think of something interesting, like maybe an emulator. So I'm just typing emulator in here. I'm just looking for one. Here's a Nintendo Switch emulator, or maybe PS2. I'd rather do PS2. I feel like they might have good information about changes, like PCSX2. And on the right-hand side, you can see we have releases. And if we open up the releases, they do not tell you much. Okay, so that's not a great example. So we'll go back to another one, and we'll try another video game emulator. Maybe we can just try putting the word emulator. You know, and people can write whatever kind of releases they want. This doesn't have releases. We'll try the 3DS emulator. This one doesn't have releases. We have... this one here, do they have releases? No. Oh, they do. They do. No, just tags. Okay, so I guess we're just going to not get really good ones here, but I guess we could just go to Rails because they seem to always have enough for us. But I just wanted something that was written a little bit more nicer so you could see a good example of a release. But here's one where, you know, they're talking about different versions. I feel like if there was a release for a specific tag version, right, that we get better information. Like when Rails first came out, like 7.0.0 probably would be a good one. So I'm just scrolling through here. I mean, these are pretty good, but again, I just want to try to find a major release one. This is 1.0. 7. I'm going to just type in 7.0.0. Might have to scroll a bit to get it to load. 0.8. There must be. Where is it? What? It just skips over it. Okay, well, I mean, 7.1 was pretty good. So we'll go over back to 7.1.
And yeah, like here it's telling you about all the libraries and things that are changed. This one's a bit better because it's showing examples of things that have changed. So you can put whatever you want in release, and it's just to help communicate what the differences are, because a lot of times you just don't know. So we did do some tagging, and that's a great opportunity for us to create our own release in our own repo. So what I'm going to do is go back over to our home. I'm going to find this repo that we have. I'm going to go over to releases, and we're going to create ourselves our own release. And we'll just say version 1.0.0, ready for the world. The best GitHub example materials around. My hands are cold. If you can't tell, I'm sorry, but I'm in like full snowsuit right now, and I got the heater blowing. So if you hear the heater, I apologize, but it's just how it is right now in my office. Anyway, you can choose a tag, which is great, and then you can then attach the binary. So the idea is we would download the zip and then re-upload it again. I'm not going to do that because that's pretty straightforward. We'll go ahead and do that. And so there's our release. And that's all I really wanted to show you for releases. Apparently there's a compare button. I didn't even know that. So that might be kind of cool to do. But yeah, there you go. So GitHub Packages is a platform for hosting and managing packages, including containers and other dependencies. And the things that it can host in terms of its package registry or repository is JavaScript packages, Ruby gems, Java, Maven, and Gradle packages, .NET packages, and Docker images. And the last one I think is going to be the most common one that people can utilize. They have a free tier, they have a pay tier, so you can start using this right away, and we will go give it a go. Probably the easiest thing we could do would be to create a Docker container and then push it to GitHub Packages. So that's kind of the code that we'll have to go through. We can make a simple hello world Docker file, run it, make sure we build it. And GitHub Actions could be used to build and then publish. I wrote the word public, but publish packages to GitHub pages. So there you go. Hey, this is Andrew Brown, and this fall along, what I want to do is go ahead and create a GitHub package. So what you're going to need to do is start up a code space. I actually already have mine running. I think by this point, you probably know how to do that. I just was working on the video earlier, and I had to close out and restart. So that's where we are now. So anyway, I'm going to make a new folder in here. This will be for GitHub packages. Okay. And if you're going to try to spell S, if you hear a bit of noise in the background, it's because I'm running the little space heater near my feet so my feet don't freeze. I'm in full snowsuit right now, okay? But anyway, what we'll do is we'll go into the packages directory and we'll make a new file and we'll call it Docker file, okay? And from here, we want to create this little Docker image. So we'll say Alpine latest. This isn't a Docker course, so I'm not teaching all this, but just follow along with me here. Or just copy paste it from my repo, whichever you want to do. Echo. We'll say hello world. Okay, so I'm going to go ahead and save that file. And now what I want to do is go into that directory and build it. So what I'll do is run docker build -t hello world period. We'll build that. Okay. And now we'll try to run it, make sure it works. There we go, that works. Okay. And so we're in good shape. The other part here, I would say, is now that we have our Docker image built, we want to now push that. So I'm going to make a new README file, so I just have a little bit of room to work with here. And there's a few things we need to do. We need to set our username. So I'm going to say username here. I'm just going to set mine as what I am, Andrew Brown. WC Brown, that's the account that I have here. Okay. And I'm going to put export in front of it. So I can export it. And yeah, I want to allow pasting, good. And we'll hit enter. It actually double pasted it, so I gotta be careful there. Right. I imagine this is a bit hard to read, so I'm just gonna bump up the font a bit. And so that should be set. The next thing is I'll need a personal access token. So I'm gonna go over here, and we've done personal access tokens quite a bit in this course.
And we'll go down to developer settings, and we'll make a new one. And this one is going to, well, I guess we got to confirm with GitHub Mobile first. Get my phone out here. And it wants me to enter a code in. 1, 2. Okay. This one's going to be for GitHub packages. Oh, I'm not registering an app. Whoa, 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 whoa. Let's go back. Personal access tokens. There we go. There's an old one. I'm going to delete that, and I'm going to generate out a new one. We'll say GitHub packages. I want this only to be for a day, just in case I forget it and someone tries to take it. And this is going to be for a specific repo. So we'll go down here and say this repo. And then for permissions, I'm looking for packages. Packages. It's under here maybe. Packages. Let's search for it. Packages. It says we need a personal access token. So I'm not seeing packages in here, and this makes me think that we should probably use a traditional one. I don't normally do this, but because I cannot find it, I'm going to use a classic token. So that's what I'm going to do. I'm going to go here. I'm going to generate a new token. Really wants to make a new one. And just say GitHub packages. And so it's really similar, very similar to the other one. Well, I want it to expire. And I'm looking for packages. Here it is. Read and write packages. Delete packages. So I'm not sure where that new one is in the new one. Maybe it's not, and we just have to use the classic token. We'll go ahead and generate that token out. I now have this token. I'm going to bring it on over to here. And I want to set this as our environment variables. I'm going to say GH token. And we're going to paste that in. Okay, and we'll copy this. Good. And we'll paste it in and hit enter. So now that's set. I need to set the image name. I'm just going to keep putting the GH under it, image name, just so it's a bit easier for me to find them when I want to find all the environment variables later. Hello world. We'll go ahead and do that. And copy that and paste it in. Hit enter. I'm going to put export in front of that just in case that didn't work. And then I'm going to do export. My hands are really cold. It's really cold in here. I think it's like -7. It's because my shed has a oil furnace or gas, oil furnace, and I have to go drive out to the reserve to get some gas, and it's just really bad weather. So I'm just trying to get this done so you folks can get this course as quickly as possible. So we've exported those values, so that's really good. I want to make sure that they're set, so I'm going to type in env grep gh, and there they are. Okay, so now we need to write some code. The first thing is we need to log into Docker, and so Docker somehow talks to GitHub. I'm not sure how that works, but we'll just go ahead and work with it here. So I'm going to say Docker login, and we're going to say GC, or say GHCR, so that's for GitHub Container Repository, I'm assuming, -u, and then we'll say GH username, and then we'll say password stdin, okay? So that'll pass the password, that's what that pipe does. And let's see if that works, we'll hit enter. Doesn't know what that flag is. Did I type it wrong? I did. And we'll copy that, and we'll paste that there, enter. And so now we're logged in. So that's step number 1. Step number 2 is we need to tag our Docker container. So we'll say Docker tag, and I want my image name, and then my version. This will be GH version, and this will be GH. I mean, we could just write it out if it's a bit simpler for everybody. So we could just say hello world 100, and then on the other side would be ghcr.io, and then that would be our username. So I could just type it in here. It's up to you whether you want to use environment variables or not. I just want it to work, so I'm just going to write it out in full, even though we made environment variables up here for this particular use case, but that's okay.
100. So the idea is we're going to tag our Docker image we built as, for 1.00 to map to here. Okay, we'll go ahead and copy that, hit enter. No such image. I mean, there is no tag called 1.0.0 on it. We do Docker list or Docker images. It's called latest. So we'll change this to be latest. We can make the other tag latest as well, but I'm going to make it 1.0.0. I'm not sure why. I'm just going to do that. That's how it's going to be. We'll go ahead and enter. And so now that's tagged. And so now we should be able to push it. ghcr.io / say Andrew WC Brown / hello world : 1.0.0. Copy, enter. So it says an image with the tag does not locally exist with that tag. So maybe I tagged it wrong. THCRIO. I spelled it wrong, yeah. And we could have just copied this one here to get it. All right. Hit enter, and there it's pushing it. Okay. So pretty straightforward. We could have even done this. We could have said like export tag name. Right. And we could have done this. Right. And then we could have just done that. And we could have done that. I'm just cleaning it up. Doing that post refactor here. And here we could have just put these in as such. So we could have done this. And then this would have been GH image name. And then this would have been GH version. And so you get the idea there. So that's pretty much it. Let's go take a look and see where this actually is. I'm done with this personal access token, so I want to delete it so nobody else is using it. And this revokes all personal access tokens in Classic. Just in case I'm going to do this, so I'm going to say Andrew WC Brown. I think they're all revoked, but just in case they're not, let's do that anyway. And we'll go over here and we'll take a look at our profile because it might show up under packages here. I'm not exactly sure how you set public packages. Oh, there it is. It's private. All right. And I'm not sure if it's specific to a repo. Link this package to a repository. So I guess if we wanted to link it, we would have had to apply a label. And so I guess labels are what you think they are. They're labels. And that way we could associate it. I'm not going to do that here today. I think that's fine. But I will copy this just in case anybody else wants to do that. And we'll go ahead and save our changes. Okay. And this really doesn't want to push here today. I'm not sure why. Git push. What isn't it like? Oh, push protection. Okay, it detects something here. Oh, is my token in here? Wow, that's cool. It actually detected it. So that because we turned on security scanning earlier, it would not let me do that. That's awesome. I wish I thought of showing that earlier. So don't show token. Actually, what we have to do is we can't even just push the old one. We have to amend the last one we had. So if we go over here, I'm going to have to go ahead and amend this. So I'm trying to figure out if there's a way I can just quickly amend. I'm going to get rid of this change here first. I'm just going to say discard this change. And I'm going to type in git commit -- amend. And so now what I should be able to do is go into here for all changes, right? And I should be able to just change it. Actually, no, that'll just amend the message. Sorry, that's not going to do what we want. What we actually need to do here is, we out of amend mode? I think we are, yeah. I'm going to do git reset soft head 1. And what that will do is bring the changes back into here. And so now I can go back and fix that. But that's really good that I had the secret scanner turned on. Do not commit your GitHub token, but we did also delete it, so it's less of a problem as well. GitHub packages. So just be really, really careful with that stuff, okay? And there you go. So I'll see you in the next one, okay? Ciao. Hey, this is Andrew Brown, and we are taking a look at pull requests, often abbreviated as PR, and you'll see that a lot. It's very common. Is a formal process to put forth changes that can be manually or automatically reviewed before it's accepted into your base branch, your main branch here. So here are pull requests in GitHub, and the benefits of pull requests is collaboration review or collaborative review. So enhances code quality through team discussions and peer feedback. It tracks changes. It says change tracking, but tracks changes, provides a record of code changes and related discussions. Automated testing enables integration with tools for automated checks and tests. Controlled integration manages safe and reviewed merging of code changes. Open source friendly, simplifies contributions and collaboration in open source projects. I want to point out that pull requests is not necessarily a Git feature, but a workflow, and GitHub has built a bunch of features around pull requests. Pull requests aren't unique to GitHub. It's just part of the workflow, and whatever they want to build around it, they can build around it. And that has to do with other tools that do this, like Jira and Bitbucket, or whatever other tools like GitLab and stuff, okay? So we can create pull requests using the GitHub CLI. That's one really cool way of doing it. The other way is using the GitHub website. So you go to the pull request tab in your repo, you create a new pull request, and there it is. I'm sure you know by now how to create a pull request, because it's almost impossible not to show you that 100 times over before we got to pull requests here, but that's how you create them. One thing I want to point out is that we have to set a base. This is who we're going to merge into, and a head, who the changes that we're going to pull into. Notice it says compare, and we'll talk about that in the next slide about base and compare, okay? So base and compare determines the direction of the merge for a pull request. And the idea is we have the base, so is who you want to merge into. This is usually the main branch or an environment-specific branch. It doesn't have to be main, but usually main is base, right? Then we have compare. This is what will be merged into base. Compare is choosing the head reference. So notice before I called it head, and if you look very closely, it says choose the head reference. So that's what compare is. This is usually a bug or feature branch. Another thing that I need to point out is that you can compare across forks. This is useful if you're trying to contribute to an open source project. So you're going to have the option to choose the base repository and the HUD repository to different repos from different owners. So there you go. So a draft pull request on GitHub is a feature that allows you to open a pull request but mark it as a work in progress. The use cases for draft pull requests would be indicating work in progress, so communicates the pull request is not ready for review or merging. Preventing premature merging ensures incomplete work is not accidentally merged. Facilitating early feedback and collaboration, so people can talk about it. Continuous integration testing, so maybe you want to just run test code, because when you have a pull request, it's automatically going to start doing that. Transitioning to a ready state, so easily switch from a draft to a ready for final review and merging. Organizing work and priorities, help in managing and tracking ongoing work in large projects. Draft pull request is a feature only for GitHub organization teams. I believe you can use it in the free organizations that are public. So we'll take a look and see if that's even possible. If I don't make a video, then you know that it wasn't. There are two things you need to remember for this. For the exam, draft pull requests cannot be merged. Code owners are not automatically requested to review draft pull requests, okay? So remember those two things, because they will show up on your exam. Ciao. Hey, this is Andrew Brown, and in this follow along, I want to take a look and see if we are able to open up a draft pull request in our GitHub organization free account that we created.
So what I'm going to do is make a new repo, because we're going to need to have one in our one here. And actually, you know what I'm going to do? No. I'm just going to, I don't want to make it too complicated. I'm just going to make a new repo. So just say like fun repo. We'll say fun repo. Okay. And this can be public. We're going to make it public, so just in case we need to have that, so we can have that functionality. Because a lot of times public allows us to have that paid functionality for free. So what I want to do is take a look here and create a new pull request and see if we have the option. We don't have any code. So we'll need to create ourselves a new branch. I'm going to just do that in here in the UI. And we'll just say dev. And we'll create that branch. And then from here, we'll go over and I want to switch over to dev. And then I want to edit the README here. And I'm just going to put in some exclamation marks. We're going to commit that change. Looks good to me. And then we're going to make our way over to pull request, and we'll make a new pull request. And what I want to know is if I can make a draft pull request. So we'll say create new pull request, and we'll drop this down, and there it is. Okay, so that's all it takes to create a draft pull request. If there are code owners assigned, they can't touch it. Notice I cannot merge it. I'm clicking like a maniac. It's not going to happen. And that is draft pull requests. So there you go. Let's talk about linking activity within a pull request. So you can link issues to a pull request so that the state of the pull request will automatically close the issue. We actually already did this before we looked at issues, during we looked at issues, and we're looking at it again. So the idea is that you go up to development on that cog and you choose the pull request, and then they're linked. Okay, so that will close it. The other way is via those supported keywords. So if you have any of those words, you put in the comment of the actual pull request, then that will close it. It says the pull request must be on the default branch. Okay, the pull request must be on the default branch for it to work. I don't know if that's true. I mean, it worked for me when we did it, but however we did it, I guess it was on the default branch. But anyway, that's that. I don't think there's any point of us showing this again because we've done it so many times, but hopefully you know that you can do that and the direction to which it happens. You're putting it in the body, the description of the pull request, so it links to the issue. Okay, ciao. Let us take a look here at the different statuses a pull request can be. Surprisingly, this isn't an exam question, but it's something you should know, so let's go through them all. The first is open. The default status when a pull request is created, it's open for discussion and review. Draft indicates the pull request is a work in progress and not ready for review. Closed. The pull request has been closed without being merged. This status is used when the proposed changes are no longer needed or if the branch has been rejected. Merged. The pull request changes has been merged into the target branch. The status indicates a successful conclusion of the pull request process. Changes requested. This status is used during the review process when a reviewer requests changes before the pull request can be merged. Review required indicates that the pull request requires a review before it can be merged. This status is common in repos where reviews are a mandatory part of the workflow. Approved. The pull request has been reviewed and approved for merging by the required number of reviewers. Conflict indicates that there are conflicts between the pull request branch and the target branch that needs to be resolved before merging. Ready for review. A pull request initially marked as draft can be changed to this status once it's ready for review. So that gives you an idea of the functionality of it. And you kind of figure this out as you are working with pull requests, but there you go. So the code owners file is a GitHub specific file that defines individuals or teams that are responsible for specific code in a repo. And so the idea is that they have the syntax that's similar to git ignore. And when a pull request is open that modifies any files matching a pattern in the code owner's file, GitHub automatically requests a review from the specified code owner. The code owner files go in either the root, project root.github folder or docs directory. And so, yeah, I think this is something that is a paid feature. It probably could be in free if we're talking about organizations, teams, or like free organizations that have to take a look. But yeah, it is a very powerful feature, okay? So when you're merging a pull request, there are a few options. So we have this drop down where we can either create a merge. This will bring all commits over into the repo. We have squash and merge, which will have one commit to be added. We have rebase and merge, which will be added and then do a rebase. The third one is a more complex one. So if you're not familiar with rebase, you're probably going to be looking towards squash, which is a good one. The use case depends on your team's workflow. They may prefer only a single commit added, and so that's why you'd want to have squash or rebase, but you do have a lot of options there for how you want to bring code in to your base there. Required reviewers is a way for you to explicitly say, hey, these people have to review this code, otherwise it won't be accepted. And so you can assign or allow multiple required reviewers before code gets into a repo. And a lot of times you can say it can't be the same person that submitted the code. And it's not uncommon to have like 4 or 5 people that can be required reviewers, and 2 or 3 have to look it over before it gets accepted. So here I would be assigning myself and saying, okay, Omen King, this user has to review the code. And then from there, as that user, I would have to approve the changes. And then from there, it would change it to saying, okay, Omen King or Andrew Brown, approve the changes. And so now you'll be able to press that merge button, okay? So there you go. Hey, this is Andrew Brown. In this video, I want to do a little bit more with pull requests in terms of code reviews, and maybe we can try to get that code owners file to work, or just things that we didn't get a chance to really get hands-on with, as we have made pull requests quite a bit, but not from a reviewing kind of code proper way. So what I want to do is I want to make my way over to our pretend organization, and we're going to go ahead and create ourselves a new repo. Unless we already have one, like the fun repo. Does that still exist? It does. So what we'll do is go ahead and use this one. And what I want to do before we do anything else is I want to add or make sure that the collaborator is added to this repo here. And so I'm going to go ahead and add Omen King. Okay. And there I am. And I'm going to go ahead and say this person can maintain this repo. All right. And now they're part of this repo. So they're there. And the reason I was able to add that very quickly was because they were already part of a team. They were already part of our organization. So I didn't have to send an invite and confirm. They're not external from that. So that was very easy. The next thing I want to do is I want to go through and create a pull request. It looks like we already have one here. So if we already have one, I'm not going to make a new one. If you have to, you make a new one. But here it says this pull request, oh, this is that draft one, right? So we can't do anything with this one right now. So I'm just going to close that pull request. I'm going to go over here to pull request. I'm going to try to make a new pull request because we still might have, yes, we do, from earlier. And I'm going to go ahead and create that pull request, okay? And so we'll create that one. And I want to say that this has to be reviewed by Omen King. As soon as I do that, notice we cannot proceed forward until that's ready. And there's another thing here that says ready for review. So this pull request is still a work in progress. So it's suggesting that this is a draft. I guess I didn't notice, but it probably was still set to draft. And so I'm ready for review, okay? And so now Omen King should know that they need to approve it for this to work, okay? Another thing that we could do is we could require other things for approval. So we could go ahead and add a rule, and rule sets allow us to do that. So there might be some things in here that we could set. Require status checks to pass. So that might be something that we might want to do. And right now we don't actually have any status checks. And so that's the reason why we can't add that there. So if I go back, okay, it would be nice to get some checks in here because that's the real value of pull requests, is having some kind of automation thing in here. But I suppose we'd have to have like GitHub Actions or something else. So maybe we'll leave that for when we get to GitHub Actions and integrate it there. And we'll just continue on with the reviewers here. So I'm going to switch to my other account. And I'm in this repo and it's saying, oh, I need to add a review. So I can go here And let's say I don't like this change. I'm going to go here and say request changes. I don't like it. Make it better. And so if I do this, okay, now it's saying in red, hey, you got to do something. Like it's not allowed to go through. And by the way, it still shows merge pull request. And I really don't want this to show up unless I've accepted it. So maybe there's a setting that we can do in here. I thought it would have been that rule set that we could do, that maybe there's something else that we can do to protect it. Always suggest updating the pull request branch. No. Moderation options. I might not be able to do it because I'm not the admin. So I'm going to go back and switch over to this. I'll go back to settings. And what I'm looking for is the option to say that it requires reviewers, or otherwise it cannot be merged. And so that's what I'm looking for right now. Maybe it's under rules. Could be branch protection as well. Let's take a look here. Require a pull request before merging. I really thought that there would have been a rule for this. The reason I think that is because I'm used to using Jira and Bitbucket, and they'll let you do that. So maybe I can't set that. I'm not sure. Restrict creation. Yeah, so I'm really surprised I can't find that. Maybe it's there, but I can't find it, and that's totally fine. But let's go ahead and pretend, we're going to go fix this issue. So we go here, and it says, I don't like it, make it better. So how can we submit that fix, right? And the way we're going to do that is we'll actually have to go to this branch and change something. So we'll go here and make sure we're in the correct branch. And in here, I'm just going to go ahead and change it again. Okay, commit the change, commit. And so now if we go back to the pull request, we should be able to update this pull request. So I'm trying to do that here. Files changed. Normally what happens, and again, it's because I'm thinking of Jira and Atlassian, is that you'd open another pull request and it would be the same one in the same spot. So I'm not sure if we can do that. If I go dev here, because it's the same branch, right? So if I do this, it says view pull request. How do I do this? And again, it's because I'm expecting it to act like another piece of software, and it's not doing what I think it's doing. Review changes. I mean, I can review my own. That makes no sense. Review in code space. So I guess the way it's going to work, I really thought there'd be a back and forth there, but I guess there's not. Is I suppose I would just have to go here and then approve it. Looks great. Okay, so yeah, I guess there's less process there than I thought. And now that I'm happy with it, I can go ahead and merge it. So the next question is, can we make a code owner file and see how that works? Because I think that would be kind of unique to do. Sorry. And so I believe that file is called code owners. And what I'm going to do is I'm going to go ahead and create myself a new file here. We'll say new file. I'm going to say code owners. And I'm just going to put an asterisk on here and just say Omen King. And so the idea is that anytime anything changes, it should assign it to Omen King. That's what I'm thinking anyway. So what we'll do is we'll go ahead and commit these changes. And we'll do this again. Okay. And the idea is that if anything changes from that other person, they send a pull request, I'm hoping that it's going to auto assign. Now this might not work because it might be only a paid feature. I don't know, but we're going to try anyway. So I'm going to go in the dev branch. And before I do anything, I'm actually going to merge it the other way. I'm going to do that by opening up code spaces on dev. And I'm just going to merge it back into the direction. Because I'm not going to make a pull request that goes in the opposite direction. I'm not going to do that. That doesn't make sense. Pull requests are supposed to go into your main branch, right? So I'm just giving this a moment here. And what I want to do is do git merge main. I'll do git pull. I'll do git checkout main, git pull, just in case. We'll say git checkout main, git merge main, git push. Saying it's all up to date. I'm not sure if I'm convinced, so I'm going to double check. It's not showing our tree here, so let's say git graph. I really wish it would persist changes, but hey, it's code spaces. And I'll go back over to here. Do I have this now? And it shows that main is ahead of dev, so it's totally lying to me. They're definitely not in sync. I knew this was not the case. Oh, you know what? I merged when I was in main, so that's probably why. Git checkout dev, git merge main. It's always great to have this open so we can see. And I'm gonna go sync those changes. Okay, just in case that didn't, I can just git push just in case. Great, that is in good shape. I wanna stop this environment. Stop, good, we're stopping it. Okay, I'll go ahead and close that tab out. So now I have confidence that this code owners is in both. I just had a feeling I need to do that for some reason. I'm gonna go ahead and just change this. And we'll do that. I'm gonna go ahead and create a new pull request. And I wanna see whether it auto assigns. We'll go here, dev, create a pull request. And look, it auto assigned it. So it says, awaiting request for review from Omen King. Omen King is a code owner. Omen King will be requested when this pull request is created. So that means the code owner file is working. I don't need to create this pull request to know that. And I think that's sufficient. The only last thing I would say is that, people can comment directly on specific lines. Just remember that because they might ask you on the exam. And that's about it. We'll see you in the next one, okay? Ciao. Hey everyone, this is Andrew Brown. In this follow along, I want to show you some of the more advanced options for pull requests in terms of the merge options and why you'd use one over the other. So what I'm going to do is I'm going to go into our GitHub examples. And in this case, we do need to open up some kind of editor. I think we could get away with using github.dev, and that's what I'm going to do. So I'm going to hit period on my keyboard, and that's going to open up the editor. We're still going to need the repo open, so I'm going to go here and wait for this to load and go to repo. And so I'm going to want to go over here for a moment. I'm going to get rid of this pull request so we're not getting mixed up. And I really want to be on development, and I actually don't even know if I'm on that. So I'm actually going to just close this stuff out. I might have mucked this up. And we'll close this out because I need to be on the correct branch for this to work. And I mean, we can do this in GitHub examples. I'm going to do this in our other repo. Sorry, I know I'm all over the place. But I want to go back to our home, and I want to go to our cool repo. So I'm going to drop down our option here. And I'm not sure why they don't ever show those on the right-hand side. They really should. But we'll go here, and I'm going to now open pull requests in a new tab here. And I'm going to go ahead and hit period. And the reason why, actually, you know what? We can't use GitHub Dev. Sorry. We're going to have to open up code spaces because what I need is that visualization tool so we can see what we're doing. So I'm going to go ahead and open up GitHub code spaces. And we're going to have to wait a little while for this to start up, unless it's already running. That'd be really nice. I'll be back here in just a second when it loads, okay? All right, so now that is ready, we want to make this a little bit easier to look at. So I'm going to switch my theme as per usual. We'll go to a darker theme. There we go. And the other thing that I want to do here is I want to switch out to the dev branch. So say git checkout dev. Okay, and another thing we're going to need is a tree. So I'm going to go ahead and go to extensions here. We'll say git graph because we need to make this really clear what's going on. So I'm going to go here and install this. Okay. And hopefully that installs nice and quick. Is it here? Not yet. Come on, git graph, install. You can do git graph. We want you, there we go. We want you here, git graph. So the idea is that I want to put a bunch of commits here, and then we're going to merge them and see what it looks like when we do that. and then we'll try a different merge option, and we'll see how much cleaner it is doing that another way. So what I want to do is I want to go ahead and modify this file, save it. I'm going to go git commit -m, change 1. And we can do MA to grab all of them in one go. And then I want to git push. Okay. And then we're going to do this again, save. And I'm going to just do semicolon so I can just get through this a lot quicker. So we'll do that again. We'll do that again. Okay, you're getting kind of the idea what's going on here. We're kind of crazy. People are not going to be happy with all of our commits. Okay, great. So now if we go back to our Git graph, here, we got a bunch of changes. I guess we should have incremented them. It just says 1111. We can amend those. Like, there's a way to rename them. I don't really want to deal with that. But let's just assume we didn't name it all dumb like that. We made 1, 2, 3, 4, 5, 6, 7. Or for the next one, we'll just name it 2. So the idea is that what will happen, the question is, what will happen when we merge this in? Will we end up with 1 over here or all of these over here? And that's what we're going to find out. So we'll create a pull request. We'll make a new pull request. We will merge dev to main. We'll create that pull request. I'm going to switch it back to normal. We'll create that pull request. We're going to ignore our reviewers. We're going to just review it ourselves. And notice we're on create and merge commit. So we do this. And what do we get? We go back over to Git graph. And I'm going to go git fetch, because that'll update the graph without pulling anything. And now notice that all of these commits is up here now. Okay, so that is there. It didn't squash them all into one. We still have all of the history of them, okay? So just to make this clear, I'm going to just go git checkout main, git pull, git checkout dev, git pull, because I want to show you that they're all still there. Okay, oh, sorry, git merge main, git pull, and refresh. Okay, and I'll just do a git push for our dev, sorry. But what I want to show you is that all of this history is still here. It's not gone, right? It's all still here. So hopefully that is clear. I know it's not the best visual, but I'm hoping that makes sense. What I want to do now is I want to do a squash, okay, for the branch. So I'm going to just make a new branch, git checkout dev2. And actually I'm going to do git checkout -b dev2, and then we'll do git, because we want to push this branch, git push u origin dev2. And so now it's being remotely tracked. And I want to do something really similar to what we were doing before. So I'm going to go here, and for each one, I'm going to remove a line. Okay, we'll save it. I'm looking for that one-liner. There we go, and this will just be 2 this time. 2, and we'll go here, save that, and this will be 2. And we'll go ahead and save this, and this will be 2. And we'll go ahead and save this, and this will be 2. And we'll go ahead and save this, and this will be 2. All right, let's go back to our Git graph. We have a bunch of this stuff here. Let's go over here and make a new pull request. This time, we're going to dev2, and we're going to create that pull request, and we're going to say create pull request, and this time, we're going to say merge pull request, squash and merge. Squash and merge. So it's bringing all those commits in, and now if we go back here and we refresh, okay, we're going to refresh here again. Oh, I got to go fetch, git fetch. That's why we don't see anything here. Git fetch, we'll refresh. And so notice now, it doesn't show like a merge line coming into here. What it's done is taken all of this stuff and it's squashed it into a new commit and has it over here. Okay, so it really depends on what you want. Do you want to keep all this history, or do you want to kind of have this like over here and this has a completely separated commit here? It's really up to you how you want to do it. I think this looks a lot cleaner, but this is totally an option as well. It's really what you want to do. And I will see you in the next one. So before I do that, I'm just going to stop my workspace. All right, and see you later. Ciao. Pull request templates are similar to issue templates. They will populate the pull request text area with the specified markdown template. So there it is. I need to point out that it's in .github/pull_request_template.md. That's what you want to use. Technically, there is a folder called pull request template that you can use, but I found that you really couldn't leverage it because there was no UI to select from it. And the only way that you could do that was via this URL you generated with a query string. So I would suggest that you use pull request template MD and not use the folder. And that's where it kind of feels like it's like where we have issue templates where they have that older version of it. Pull requests still feel like that old kind of version, if that makes sense. So there you go.
Hey, this is Andrew Brown from ExamPro, and in this section, we'll be covering authentication methods. Credentials are specific to a user's identity. For example, their individual username and password, PIN, or biometric information. Every user, including IT administrators, teachers, staff persons, and students has credentials. An authentication method is the way a user proves their identity to a system. For example, a user inputs their credentials in a sign-in screen or via the Microsoft Authenticator app in which they have set up their account. Authentication methods can also be broken down into categories or types such as sign-in authentication, password reset authentication, multi-factor authentication. Authentication types. Authentication methods vary widely from traditional to advanced. Common types include passwords and PINs, common but can be risky for security. Picture passwords and pattern locks offer memorability and simplicity. Biometric authentication, facial, fingerprint, retinal provides secure, unique user identification. Passwordless authentication emphasizes security and convenience by eliminating traditional passwords, removing the hassle of memorization, and mitigating threats like phishing. Some of Microsoft's methods include Windows Hello for Business uses biometrics, PIN for secure sign-ins and SSO. Microsoft Authenticator app enables phone verification with notifications and biometrics, PIN. FIDO2 security key allows password-free logins with internal keys. Password reset authentication, self-service password reset with Microsoft Entra ID lets users change their own passwords without help desk assistance, cutting down on support costs and improving security and efficiency. Some of the key features include self-service, users can change or reset their passwords without administrator or help desk assistance. Security enhancement, SSPR improves organizational security by allowing users to promptly address account lockouts or compromises. Compliance with password policies, SSPR enforces Microsoft Entra password policies regarding complexity, length, expiration, and character use, ensuring standardized security measures across the board. Multi-factor authentication, MFA is a security measure that requires more than one piece of evidence to confirm your identity when logging into an account, like a code from your phone in addition to your password. Some MFA methods include SMS text message, a code sent to the user's phone. Phone voice call, answering a call to confirm identity. Microsoft Authenticator app, a code or biometric verification through the app. An OAuth hardware token, using a physical token for authentication. Set up OAuth for external services. OAuth is a protocol for authorization that lets users give third-party services like GitHub or Jenkins permission to use their information without sharing their login details. It ensures secure connections, making authentication and permissions straightforward. Use personal access tokens. Personal access tokens provide a way for users to create special tokens to access DevOps tools. They are especially handy for command line interactions or scripts needing direct access to these services. Apply role-based access control. Role-based access control sets up detailed access rules based on users' roles and what they're allowed to do. It makes sure people have just the right access they need for their work, keeping sensitive information secure. So that's an overview of the authentication and credential strategies. The next topic we'll be covering is GitLFS, which stands for Git Large File Storage, and Git Fat. Developers sometimes struggle with handling big files in a Git repository because it can make the repository work slower and use up too much space. Microsoft has two tools to help with this, GitLFS and Git Fat. Git LFS is an open source extension for Git that helps handle large files more efficiently. It does this by using small text pointers in your Git repository to represent the large files while keeping the real file content stored elsewhere. This method keeps your repository from getting too large and slowing down. To get started with Git LFS, you'll need to follow some of these steps. Install Git LFS. Install, go to the Git LFS website, download, and install the version based on your operating system. Configure, use the command git lfs install to set up Git LFS on your system. Setting up Git LFS in your repository. Track large files, decide which file types to manage as large files. For example, use Git LFS track.mp4 for MP4 files. Add attributes file, add the .git attributes file to your repo with git add.git attributes. Commit and push, save the changes with git commit, -m configure Git LFS, and update the remote repository using git push. Managing large files. Add files, run git add dot, or git add file name to stage large files. Commit and push, use git commit, -m add large file, and git push to commit and send files to the remote repo. So that's an overview on how to get started with Git LFS. Gitfat is another tool for managing large files in Git repositories. It's a Python script that keeps large files separate from your Git repository while maintaining references to those files within the repository. Let's take a look at how to get started with Gitfat. Setting up Gitfat. Install Python. Make sure Python is installed on your system. Install Gitfat. Install Gitfat using pip with pip install Gitfat. Initializing Gitfat in your repository. Initialize Gitfat. Run Gitfat init in the root of your repository. Track files, define large file types in a .gitfat file. For example, to track MP4 files, you might add *.mp4 to the file. Commit .gitfat, add the .gitfat file to your repo with git add.gitfat, and then commit it using git commit -m initialize gitfat, and track large files. Managing large files with Gitfat. Add large files, use Gitfat, add file to stage large files for Gitfat. Commit and push, commit with git commit -m add large file, and upload with git push. Pull large files on a different machine. After cloning, run gitfat pull to download the large files. So that's an overview of how to get started with Gitfat. Gitscaler is an extension that helps Git efficiently manage large repositories, addressing the slowness and space issues associated with downloading a repository's entire history and files. Gitscaler solves this by allowing you to download only the files you need. It works well with Git LFS. To use Gitscaler, you'll first need to set up your repository with Git LFS, then enable Gitscaler for specific file paths you're interested in. Configure Gitscaler for a specific path. Install Git LFS. Install Git LFS by following the steps provided in its official documentation. Initialize Git LFS in your repository. In your repository's directory, run Git LFS install. Create and configure .git attributes file. In the root directory of your repository, create a .git attributes file. To enable Gitscaler for files under the my/large/files directory, add the following line to .git attributes. my/large/files/*, filter equal LFS, diff equal LFS, merge equal LFS -text. This configuration tells Git LFS to manage files in my large files using Gitscaler for efficient handling. Commit and push the .git attributes file. Commit the .git attributes file to your repository with git add.git attributes. Then git commit -m, configure Git LFS and Gitscaler for specific paths. Push the changes to your remote repository, git push. So that's an overview of how to get started with Gitscaler. Cross-repository sharing with Git. Sharing code across different repositories is common for reusing code, modularization, or separating components of an application. Git facilitates this with the following method: submodules. Git submodules let you integrate a separate Git repository within another repository's directory structure. It's especially handy for incorporating a particular version of an external library or for sharing common libraries across various projects. To add a submodule, you'll need to use the command git submodule add repository URL path. Repository URL, the Git URL of the repository you want to add. Path, the directory path within your main project where the submodule will be placed. Here's an example. Git submodule at https://github.com/example/lib.git externals/lib. Some of the advantages of submodules include: manage shared code by referencing specific commits and keeps the main project separate from external dependencies. Note that using Git submodules requires managing updates individually and maintaining consistency across projects that share them. Overall, by using submodules, you can efficiently manage cross-repository code sharing in Git while maintaining clear boundaries between different projects or components. The next tool we'll be covering is Git Subtree. Git Subtree is a tool that helps you include code from one repository into a specific folder of another repository. It's a simpler alternative to submodules, which is another way to incorporate external code but can be a bit complex to handle. With Git Subtree, you can both bring in external code and send updates back to the original code source if needed. To add a subtree, you use a command that looks like this. Git Subtree add prefix equals folder name, repository URL, commit or branch. Prefix equals folder name is where you specify the folder in your main project where you want to add the external code. Repository URL is the web address of the external code you're adding, and commit or branch is the specific version of the external code you want to use, which can be a commit ID or a branch name. Git Subtree streamlines project workflow by integrating external code directly, ensuring it's immediately accessible upon cloning without additional steps. Overall, Git Subtree makes it easy to work with code shared between different projects. While it simplifies some of the issues found with submodules, updating the code from the original repository into your project can require a few extra steps. The next topic we'll be covering is workflow hooks. Workflow hooks are essential tools in the Microsoft DevOps ecosystem designed to automate and refine development workflows, leading to better efficiency and productivity. Workflow hooks act as triggers for executing actions or scripts at specific points in a DevOps workflow, crucial for maintaining code quality, automated testing, deployment, and integrating external services into the process. In the context of build and release cycles, workflow hooks are particularly valuable. They enable developers to automate tasks like unit testing, documentation compilation, or deployment to testing environments with each new build or release, streamlining these processes. Azure DevOps stands out in offering comprehensive tools and services for managing the DevOps lifecycle, including implementing workflow hooks through service hooks. These service hooks allow for connecting your DevOps pipeline with external services or initiating custom actions in response to various events, such as new build completions, work item updates, or pull requests. Other tools and services for workflow hooks. Besides Azure DevOps, Microsoft offers other tools and services for implementing workflow hooks, including GitHub Actions, Azure Logic Apps, and Azure Functions. The key to leveraging workflow hooks effectively is to identify the crucial events and actions within your workflow and use the appropriate tools for implementation. Here's a simplified step-by-step guide to creating a service hook in Azure DevOps for automating actions such as notifications after a successful build. Access project settings. Open your project in Azure DevOps and navigate to project settings at the bottom of the project sidebar. Open service hooks. In the general section, find and click on service hooks. Create subscription. Initiate the creation process by clicking the +Create Subscription button. Select Notification Service. Pick the service for notifications, like Microsoft Teams or Slack, and set the event trigger to build completed. Set trigger filters. Customize the trigger filters by setting the build status to succeeded. Configure action details. Specify the notification message and destination, such as the recipient channel in Slack or an email address. Finalize and test. Save the service hook with the Finish button and conduct a test to confirm it operates as expected after a build is successful. So that's an overview of workflow hooks. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be covering the different types of branch strategies. Starting with trunk-based development, or TBD, TBD employs a single central branch known as the trunk or master, focusing on frequent, small updates for continuous integration and stability. Steps to implement TBD. 1. Establish the trunk. Define a single branch, also known as the trunk, as the central code path. 2. Direct commits. Encourage team members to commit small changes directly to the trunk frequently. 3. Continuous integration. Perform builds and tests on the trunk often to catch issues early. 4. Automate deployment. Set up automatic deployment to streamline updates. Here's an example of how you can create a trunk branch using Git. Git branch trunk. Git checkout trunk. Another branch strategy you can use is feature branches, which enable developers to work independently on new features or fixes, keeping changes separate from the main code until they're ready to merge. This approach allows for focused development and testing of specific functionalities without disruption. Steps to use feature branches. 1. Create feature branch. Initiate a new branch for each feature or fix. 2. Naming conventions. Assign descriptive names reflecting each branch's purpose. 3. Stay updated. Merge updates from the main branch periodically. 4. Thorough testing. Conduct extensive tests before merging back to the main branch. Here's an example of how you can create and switch to a feature branch using Git branch feature / new feature, Git checkout feature / new feature. The last branch strategy we'll be covering is release branches, which help prepare and stabilize a codebase for a new release, focusing on bug fixes and final adjustments. They are created from the main branch, enabling ongoing development while ensuring the upcoming release is thoroughly tested and polished. Steps for managing release branches. 1. Create a release branch. Start a branch from the main branch for new releases. 2. Focus adjustments. Make all necessary tweaks and bug fixes on this branch. 3. Ensure stability. Test thoroughly and maintain continuous integration. 4. Final merge. Merge the release branch back into the main branch once ready. Here's an example of how you can create a release branch using Git branch release / release - 1.0, Git checkout release / release - 1.0. So that's a brief summary of the key branching strategies that will be covered on the Azure DevOps exam. Policies are critical for maintaining code quality and ensuring that changes meet certain standards before they are merged. Branch policies in Microsoft DevOps solutions are rules that govern how code is contributed to a repository. They enforce certain conditions that must be met for pull requests to be merged, ensuring that code is reviewed, tested, and linked to relevant project tasks. Key branch policies to implement. Require approving reviews. Mandate that each pull request receives at least one approving review from designated reviewers before it can be completed. This guarantees that all code changes are scrutinized by another developer, promoting better code quality and reducing the risk of errors. Link work items. Ensure that every pull request is associated with a corresponding work item. This linkage provides traceability and accountability, making it easier to track why changes were made and ensuring they align with the project's goals. Build validation. Configure this policy to require that changes in a pull request successfully pass automated builds and tests. This helps to identify any compilation issues or test failures early, preventing problematic code from reaching the production environment. Additional branch policies for enhanced workflow. Enforce minimum review time. Set a minimum period that pull requests must remain open before they can be merged. This policy prevents rushed reviews and ensures thorough evaluation. Require task completion. Mandate the completion of specific tasks before merging, such as addressing all code comments or updating necessary documentation. This ensures that all critical aspects are handled before integration. Automate code formatting and style checks. Implement tools like linters to automatically enforce coding standards. This minimizes manual review efforts and maintains consistent code quality. Benefits of using branch policies. Improved code quality. Automated checks and enforced review standards significantly reduce the risk of introducing bugs and errors. Better team collaboration. Requiring reviews and linking work items promotes effective collaboration and keeps team members aligned with project goals. Efficient workflow management. Automating parts of the review process accelerates the development cycle while upholding high-quality standards. So that's an overview of branch policies. The next topic we'll be covering is branch protections in Azure DevOps. Branch protections provide an additional layer of security by enforcing rules on branch manipulation, preventing accidental modifications or unauthorized changes. Here are some of the key branch protections to implement. Require a minimum number of reviewers. Set branches to require a specific number of reviewers for all changes. This ensures multiple evaluations of the code, which facilitates collaboration and reduces the risk of defects. Restrict who can push to the branch. Limit direct push access to protected branches, allowing only authorized individuals or teams to make changes. This control helps prevent unauthorized modifications and maintains code integrity. Enforce merge checks. Specify criteria that must be met before merging a pull request. These include build validation, work item linking, and branch permissions compliance to ensure only approved changes merge. Pull request workflow with branch policies and protections. Here's how you can structure a typical pull request workflow using both branch policies and protections. Create a feature branch. Developers branch off the main branch to work on new features or fixes. Implement changes and create a pull request. Developers commit changes to their branch and open a pull request to merge them into the main branch. Assign reviewers and await feedback. Reviewers inspect the code, provide feedback, and approve. Branch policies ensure pull requests need the required approvals to proceed. Address feedback and iterate. Developers respond to feedback, update their code, and trigger the build validation process. Reviewers reassess the updated changes. Complete the pull request. After securing approvals and passing merge checks like work item linkage and build validation, the pull request is completed and changes are merged. So that's an overview of branch protection in Azure DevOps. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be covering Azure Pipelines. Azure Pipelines is a cloud service that automates the CI/CD pipeline for software development, offering support for multiple languages, platforms, and cloud environments, and integrating with a wide range of tools and services. Here are some of the key features of Azure Pipelines. Automation for CI/CD. Azure Pipelines provides a fully featured continuous integration and continuous delivery service for applications. Platform and language agnostic, supports any language, platform, and cloud, and integrates with Azure, Oz, and GCP. Extensibility offers integration with popular tools and services in the software development ecosystem. Supports open source and private projects, available for projects hosted on GitHub and other platforms. Rich integration, integrates with GitHub checks and offers extensive reporting capabilities. Parallel jobs and environments, allows running multiple jobs in parallel and deploying to multiple environments including Kubernetes, VMs, and Azure services. Next, we'll take a look at defining your pipeline. YAML syntax. Azure Pipelines uses YAML syntax to define build, test, and deployment tasks. Step-by-step process, the documentation guides through the process of setting up your first pipeline, including initiating builds, packaging applications, and deploying. Some of the key concepts include pipelines, a complete CI/CD pipeline defined by stages, jobs, steps, and tasks. Stages, a way to organize jobs, typically used to separate build, test, and deploy processes. Jobs and steps, jobs group steps, which are individual tasks like scripts or Azure Pipeline tasks. And tasks, prepackaged scripts that perform actions in your pipeline. Moving on to supported languages and framework. Wide language support works with any language including Net, Java, JavaScript, Node.js, Python, PHP, Ruby, C, C++, and more. Framework and platform support supports Windows, Linux, and MacOS builds. Can deploy to various platforms including Azure, Kubernetes, VMs, and on-premises servers. Extensibility, marketplace extensions, a rich marketplace of extensions to extend the functionality of Azure Pipelines. Custom tasks, developers can create custom tasks to meet unique requirements. Pricing, free tiers available, offers free CI/CD minutes to projects with additional minutes available for purchase. Pricing varies based on parallel job needs and cloud providers. So that's an overview of Azure Pipelines. The next topic we'll be covering is GitHub repos with Azure Pipelines. Integrating GitHub repositories with Azure Pipelines can significantly enhance the automation of build and release processes within a DevOps workflow. This integration facilitates continuous integration and delivery, promoting faster and more reliable application deployments. Here's how to structure the setup process. Step 1. Create a new project in Azure DevOps. Create project, click the New Project button. Provide the necessary details for your project, such as name and description, and then click on the Create button to finalize the project creation. Step 2. Connect your GitHub repository to Azure Pipelines. Access pipelines in your new Azure DevOps project. Navigate to the Pipelines section. Initialize pipeline, click on the New Pipeline button. Select source, choose GitHub as the source for your pipeline. You will need to authenticate and authorize Azure Pipelines to interact with your GitHub account. Configure pipeline, select the specific branch or repository to build and deploy. Customize the pipeline settings based on your application requirements. Activate. After configuring, click on the Save and Run button. This action saves your pipeline configuration and triggers the initial build. Step 3. Build and deploy your application. Build configuration. Azure Pipelines will execute the build of your application according to the directives specified in your pipeline configuration file, which is usually a YAML file. This may include tasks like compiling code, running tests, and packaging artifacts. Release tasks post-build. Configure the pipeline to deploy your application to various environments, such as staging or production. This can involve deploying to services like Azure App Service or Azure Kubernetes Service. Deployment customization. Utilize features like environment variables, secrets, and approvals to tailor and secure your deployment process. Benefits of integrating GitHub with Azure pipelines. Continuous integration ensures that any changes in the connected GitHub repository trigger automatic builds, keeping your application updated and validated after every commit. Code visibility enhances traceability by linking GitHub pull requests and commits directly to their respective build and release pipelines. Artifact management facilitates management and storage of build artifacts in Azure pipelines or with external services such as Azure Artifacts and Docker registries. Continuous delivery automates the deployment process across different environments, minimizing manual intervention and promoting consistent releases. Release approvals implements controls and checks through configurable approvals before promoting builds to production environments. So that's an overview of GitHub repos with Azure pipelines. The next thing we'll be covering is configuring the permissions in source control repo. Managing access and security through permissions is critical in a DevOps environment to ensure that team members have appropriate access for their roles. Configuring repository-level permissions. Wide access project. In Azure DevOps, navigate to your project and go to the Repos section. 2. Repository settings. Select your repository and click on the Settings tab, then Repositories in the submenu. 3. Modify security. Choose the repository you want to adjust and click on the Security tab on the right. 4. Manage access. Add users or groups to the predefined security groups or create new ones. 5. Set permissions. Use the Add button to grant the appropriate permissions like read, contribute, and administer to selected users or groups. Branch-level permissions configuration. Widen repository access. Open your repository in Azure DevOps. 2. Branches. Go to the Branches tab and choose the branch you need to configure. 3. Security settings. Click on Security to manage permissions for that branch. 4. Define permissions. Assign permissions to groups or users, overriding repository-level permissions if necessary. Configuring file-level permissions. Wide locate file. Within the repository, navigate to the specific file you want to manage. 2. File permissions. Click the three-dot icon next to the file and choose Manage Permissions. 3. Control access. Add groups or users and set the desired access levels just as you would at the repository or branch level. So that's an overview of configuring the permissions in source control repo. The next topic we'll be going over are tags in source control repos. Tags in Git serve as reference points to specific commits, making it easier to manage and track different versions of code in a repository. Step 1. Repository access. Log into Azure DevOps or another Microsoft DevOps solutions platform. Verify you have the required repository permissions. Step 2. Navigate to the repository. After logging in, locate the Repositories or Source Control tab on your dashboard. This section contains all the repositories you have access to within the platform. Step 3. Create a tag. Identify the commit in the repository that you wish to tag. Tags are useful for marking releases or important points in the project's history. Select the desired commit from the commit history. Look for an option labeled Create Tag or Add Tag, usually available in the Commits context menu. Step 4. Provide tag details. In the tag creation dialog, enter the tag name, a unique identifier for the tag. Provide a description, a brief note about what this tag represents. Add any annotations or other metadata if necessary. Step 5. Save the tag. Confirm the details and save the tag. This action attaches the tag to your specified commit, marking it for future reference. Step 6. View and manage tags. After creating a tag, you can view and manage it through the repository interface. Access the tags section where all configured tags are listed. Here, you can rename, delete, or reassign tags to different commits if required. So that's an overview of tags in source control repos. The next thing we'll be covering is recovering data using Git commands. Git is vital for version control and teamwork, but sometimes mistakes occur, leading to data loss or overwrites. It's important to know how to restore data using Git commands in these situations. Examining commit history. Check Git log. Use the command Git log to see a list of recent commits made in the repository. This log includes the commit hash, author, date, and the commit message. To find a specific commit or to filter the log by author, date, or content, you can use git log author equals username. Git log since equals 2023-0401. Git log grep equals keyword. This helps in locating the exact commit hash of the changes you wish to restore. Revert a specific commit. Use git revert commit _hash to undo the changes made in a specific commit while preserving the history of changes. This command creates a new commit that reverses the changes introduced by the specified commit. It's a safe way to undo changes, as it doesn't alter the existing history. For example, git revert 1a23c forward. Recovering deleted commits. Use reflog to recover lost commits. If you've accidentally deleted or lost commits, git reflog can be a lifesaver. It shows a log of where your head and branch references have been, which includes deleted or orphan commits. You can find the commit hash of a lost commit and recover it by creating a new branch from it. Git reflog. Git branch restore branch commit _hash. This restores the deleted commit in a new branch called restore branch, allowing you to access the previously lost changes. Restoring deleted files. Restore deleted files. If you've deleted a file and want to recover it from history, use git checkout commit _hash file _path. This command restores the file as it existed at the specified commit. It's useful for quickly recovering lost work without affecting other changes in the repository. So that's an overview of recovering data using git commands. The next topic we'll be going over is purging data from source control. To optimize your source control system within Microsoft DevOps environments, regular purging of unnecessary data is crucial. This helps in improving system performance and reducing clutter. Prerequisite checks. Communicate with team. Ensure all team members are informed of the purge to avoid any disruption. Backup data. Confirm that backups are in place for all critical data. Data replication check. Ensure essential data is replicated to alternative repositories or backup systems. Azure DevOps REST API for data purging. Automate with API. Use the Azure DevOps REST API for automated data deletion tasks. Delete files, folders, branches. Modify the delete API call as needed to target and remove specific items from the repository. Manual git garbage. Collection trigger garbage collection. Run git GC in your local repository to start manual garbage collection. Non-production timing. Perform this operation when it won't interfere with development activities. Git history compression. Access repository settings. In Azure DevOps, go to the repository settings to find Git configuration options. Enable compression. Check the option for compress Git history to optimize storage. Removing unnecessary branches. Local branch deletion. Use git branch d branch name to remove branches from your local machine. Azure DevOps branch removal. Use the Azure DevOps web interface to locate and delete old or unused branches. Implementing data retention policies. Define policies. Set up rules for how long data should be retained in Azure DevOps. Automate purging. Configure automatic removal of aged data to streamline repository maintenance. So that's a brief summary of purging data from source control. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be covering integrating pipelines with externals, starting with dependency scanning. Dependency scanning helps you track and manage the libraries and packages your codebase depends on. This ensures that your applications use the appropriate versions of these dependencies, minimizing the risk of compatibility problems. Select from various tools like OWASP Dependency Check or Retire.js, which help identify vulnerabilities and outdated libraries in your project's dependencies. Choose one that best fits your project's requirements. Configure the pipeline. Integrate your selected dependency scanning tool into Azure Pipelines by setting up a task to run the scan before the build or deployment phases to identify vulnerabilities at the earliest. Analyze the results. Post-scan. Analyze the results to identify and prioritize vulnerabilities or outdated dependencies highlighted in the scan report. Address these issues to maintain the health and security of your application. Detection process. Each change in the dependency graph or after code build initiates a new snapshot of your components. Vulnerable components are logged and displayed as alerts in the Advanced Security tab based on advisories from the GitHub Advisory Database. These logs detail the severity, component, vulnerability title, and CVE. Managing alerts. The Advanced Security tab serves as a central hub for viewing and managing dependency alerts. It allows filtering by branch, pipeline, and severity and provides remediation steps. Alerts for dependency scans on PR branches are shown, and any name changes to pipelines or branches might take up to a day to reflect in the results. So that's an overview of dependency scanning. The next topic we'll be covering is security scanning. Integrating security scanning tools into your pipelines is a critical step to identify and address security vulnerabilities in your code. There are many security scanning tools available, like SonarQuebec and Microsoft Defender for Cloud. These tools analyze your codebase for security flaws, coding standards violations, and potential vulnerabilities. Choose the tool that meets your project's requirements. SonarQuebec is an open-source platform for continuous inspection of code quality. It performs automatic reviews to detect bugs, vulnerabilities, and code smells in your code. Microsoft Defender for Cloud, formerly known as Microsoft Defender App, offers security management and advanced threat protection services across hybrid cloud workloads. Set up your pipeline. Incorporate the security scanning tool by adding the required tasks into your pipeline configuration. For example, in Azure Pipelines, you can add a task that triggers the security scan during the build phase, automating the security audit. Evaluate scan results. After the security scan is finished, review the tool's report. It will highlight security gaps and code quality concerns. Address these items promptly, giving priority to the most critical issues to fortify your codebase's security posture. So that's a quick overview of security scanning. The next topic we'll be going over is code coverage. Code coverage measures the percentage of your codebase tested by automated tests, revealing how much code is exercised during testing to ensure quality and detect uncovered areas. Select a code coverage tool. Select a tool like JACOCO for Java or Cobertura for .NET, ensuring it integrates well with your tech stack and test frameworks. Configure the pipeline. Incorporate your chosen tool into the pipeline to collect code coverage metrics during tests. For example, using Azure Pipelines, you can use a publish code coverage task to generate reports in popular formats like Cobertura or JACOCO. Analyze code coverage results. Review the coverage report post-analysis to identify and improve areas with low test coverage, enhancing your code's robustness. Accessing coverage artifacts. Published code coverage artifacts can be viewed in the pipeline run summary under the Summary tab, offering a snapshot of test coverage for each build. Quality metrics enforcement. Code quality assurance. Leverage code coverage metrics to continuously elevate your project's quality and verify the extent of testing for new code. Pull request integration. Implement coverage data within pull requests to ensure thorough testing and preemptively fill testing voids before integration. Setting code coverage policies. Full versus diff coverage. Full coverage measures the total codebase's test coverage, ensuring overall quality. Diff coverage focuses on the code changes in pull requests, ensuring new or altered lines are tested. So that's an overview of code coverage. The next topic we'll be covering are quality gates. A quality gate acts as a benchmark for code quality that must be met prior to release and ideally before the code is committed to source control. It ensures that only code that meets established standards progresses through the development pipeline. Features of quality gates. Automated code analysis. Tools like SonarQuebec are integrated into Azure pipelines to perform static code analysis, identifying potential issues such as code smells, vulnerabilities, and bugs. Performance metrics. Code quality metrics, including code coverage, complexity, and maintainability index, are assessed. Compliance checks. Gates ensure the code complies with security standards and governance policies before proceeding in the pipeline. Best practices for implementing quality gates. Customization. Customize gate criteria to align with project demands and application type. Threshold setting. Set clear thresholds for code coverage to define pass, fail conditions for the gate, such as minimum code coverage percentage. Feedback loop. Establish immediate feedback systems for developers upon gate failure for prompt issue resolution. Integrating quality gates with Azure pipelines. Pipeline configuration. Integrate quality checks in your CI/CD flow to control code progression using established metrics. Action on failure. Define actions for when code fails to meet the quality gates criteria, which may include halting the pipeline, triggering alerts, or creating tasks for remediation. Visibility and reporting. Increase transparency through dashboards or reports showing gate outcomes for ongoing codebase health monitoring. So that's an overview of quality gates. The next type of gates we'll be covering are security and governance gates. Security gates are established to verify that code complies with security protocols and is free of vulnerabilities before being pushed to production. Static application security testing. Integrate a SAST tool like SonarQuebec and White Source Bolt into the build process to scan for security flaws. This proactive approach detects issues early, reducing the risk of vulnerabilities reaching the production environment. Dynamic application security testing. Conduct DAST regularly on live applications to find security weaknesses. Use tools like Azure Web Application Firewall to guard against common threats like XSS and SQL injection. Governance gates are checkpoints to confirm that both code and deployment procedures are in line with company policies and industry regulations. Policy definition and enforcement. Identify and set governance policies required by your organization. Apply these policies using tools such as Azure Policy to automatically enforce them throughout the development cycle. Automated compliance verification. Build automated compliance checks into your CI/CD pipeline with Azure DevOps Compliance or similar tools. Automating these checks ensures ongoing adherence to governance standards without manual oversight. So that's an overview of security and governance gates. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be going over what are pipelines. In DevOps, a pipeline is a key framework that structures the software delivery process through automated steps. It ensures each phase of the software lifecycle, from integration to deployment, is optimized for quick development, reliable releases, and scalability. It encompasses several components and features. Components of DevOps pipelines. One, source code repository, the starting point where code is stored and version controlled. 2, build server automates the compilation, building, and preliminary testing of code. 3, test server runs various tests such as unit or integration to ensure code quality. 4, deployment server manages the deployment of code to various environments such as staging or production. 5, feedback and monitoring, tools that provide feedback on deployment success and monitor application performance in production. Features of DevOps pipelines. Automation, every stage from code commit to production is automated, minimizing manual tasks and errors. Continuous integration and deployment ensures that changes to software are automatically tested and deployed, improving speed and quality. Modularity, each component functions independently but collaboratively, allowing for easier troubleshooting and updates. Benefits of DevOps pipelines. Increased efficiency, automation reduces the delivery cycles, enabling faster releases. Improved reliability, continuous integration and testing diminish the chances of defects in production. Better scalability, pipelines support scalable operations and management practices as organizational needs grow. So that's an overview of pipelines. The next topic we'll be covering is integrating automated testing into pipelines. Automated testing plays a vital role in ensuring the quality and reliability of software products. By incorporating automated tests into the pipeline, you can detect issues early in the development cycle, streamline the release process, and achieve faster time to market. Key steps for integration. Define test strategy, outline what types of tests, such as unit, integration, UI, will be automated and set the coverage criteria. Create test infrastructure, use Azure DevOps for provisioning resources like VMs or containers, or utilize Azure Test Plans for executing tests. Choose a test framework. Depending on your tech stack, select an appropriate framework like MS Test, NUnit, or XUnit. Write automated tests. Develop tests that address various functional and integration aspects of your application. For example, in a shopping cart application, you could write a test to ensure items are added correctly. The example shows a unit test in C# using MS Test to verify that a product, when added to a shopping cart, is correctly included. This test checks the functionality of the Add to Cart feature essential for e-commerce applications by asserting that the cart contains the added product. Version control, manage your test scripts and codebase in a Git repository using Azure DevOps for integrations like pull requests and reviews. Configure CI pipeline. Set up a CI pipeline in Azure Pipelines to automatically run tests upon commits, helping identify issues early. Incorporate test reporting. Utilize Azure DevOps for detailed test reporting and tracking over time. Implement CD pipeline. After passing tests in CI, deploy your application across different environments using a CD pipeline. So that's an overview of automated tests into pipelines. The next topic we'll be covering are testing strategies. Local tests are written by developers to test individual components or modules before they are integrated into the larger system. They ensure that each piece of code functions correctly in isolation. There are various tools and frameworks available for writing local tests, such as MS Test, NUnit, or XUnit. For example, using MS Test, you might test a method in a class that calculates the sum of two numbers. The test checks whether the method returns the correct result when adding two integers. Unit tests focus on validating the functionality of individual methods or classes in isolation, identifying bugs, and ensuring code behaves as intended. Microsoft DevOps Solutions supports MS Test, NUnit, and XUnit for these tests. Unit tests are narrowly focused, while local tests can be broader or refer to the environment in which a variety of tests are performed. Using NUnit, consider a test for a service that retrieves a list of items. The test verifies that the list is not empty and contains the expected number of items. Integration tests assess the interaction between two or more components of the application to ensure they work together as expected. These are important for catching issues that unit tests might miss. Using NUnit, an integration test could check the interaction between two services where one service uses data provided by another. Load tests evaluate the performance of the system under a significant load, which could be simulated users or transactions. They help to identify the capacity limits and scalability of the application. In a load test scenario in Azure DevOps, you could simulate multiple users accessing a service to test its performance and capacity. So that's an overview of the main types of testing strategies. Another type of testing is the UI testing. UI testing is critical in Microsoft DevOps for ensuring that the user interface of applications functions correctly and meets desired requirements. This testing confirms the UI's functionality and behavior, identifying early issues with user interactions, layout, responsiveness, and data management. Bug detection: regular UI testing identifies bugs and errors early, improving user experience quality. Verification: this testing confirms that the UI meets functional requirements and performs as expected under various conditions. Microsoft offers several tools that streamline UI testing in DevOps environments. First, let's go over Microsoft Test Manager. Microsoft Test Manager supports extensive UI testing with capabilities tailored for managing test cases and tracking their execution. Setting up: begin by creating a new test plan and suite in MTM. Test cases: add UI test cases to your suite. Execution and analysis: use MTM's test runner to perform the tests and review results, including screenshots and videos. Another one is Visual Studio Coded UI tests. Visual Studio Coded UI tests provide a code-centric approach to UI testing, suitable for automation using C# or Visual Basic.NET. Create a test project, start a new project, and add a coded UI test. Record and enhance: interact with your application's UI to record actions, then add validation statements. Execution: run your tests locally or integrate them into your DevOps pipeline for continuous testing. Selenium WebDriver with C#. Selenium WebDriver is an open-source framework ideal for automating web browsers and conducting cross-platform UI tests. Setup: install Selenium WebDriver via the NuGet package in your Visual Studio solution. Create and configure: start a new C# test project and set up Selenium WebDriver. Develop and run tests: write test methods to interact with the UI and execute them locally or within your DevOps pipeline. So that's an overview of UI testing.
Well, let's take a look at GitHub Actions, which is a CI/CD pipeline directly integrated with GitHub Repos. And GitHub Actions allows you to automate running test suites, building images, specifically Docker images, compiling static sites, deploying code to servers, and more. And we can access this all through the Actions tab in your GitHub repo. When you first use GitHub Actions, there are some templates that you can utilize. And all these files are stored in your workflow directory in your .github folder. As you can see, there's this kind of YAML file that we're going to utilize. It's going to be important that we remember some of the structure. So I remember on the exam, they wanted you to know that there was jobs, on, and steps. You can have multiple workflows in a repo triggered by different events. So when you run GitHub Actions, you'll get a history of workflow runs where it will indicate if it was successful or a failure, how long it took to run. So this is for something, probably for one of the boot camps that we ran as we used GitHub Actions to build the site. If you want to find the example repos, because there are those little getting started, but it's the same repo here at the starter workflows, and you can get the YAML files and get started really quickly. There are different types of triggers that you can use with GitHub Actions. That's going to go into that on area. And GitHub, there's about 35 GitHub Actions. I say plus because in case there are more that I'm not aware of, I'm covering my bases there. Examples of common GitHub Actions could be pushes, pull requests, issues, releases, schedule events, and manual triggers. The exam wants you to know that you can trigger based on these things. So make sure you remember this short little list here, okay? Hey, this is Andrew Brown, and in this follow along, let's take a look at GitHub Actions. So what I want to do is go over to our organization. I'm going to go to our fund repo, and here we have a tab called Actions where we can set up some GitHub Actions. Now, I don't use GitHub Actions a whole lot. Maybe I will if I go ahead and do that GitHub Actions certification course, but we'll just have to kind of work our way through it, and it shouldn't be too hard. So there's a lot of different things that we can utilize here. I can set up Terraform, which is kind of cool. We have deployment to AWS, to Azure, to Alibaba Cloud. We have some security things that we can do here. We have continuous integration, automation, a whole host of stuff. And you can even do static compilation, which is pretty cool as well. So we're going to have to make a decision in terms of something that we want to use. I don't think it's going to be deployment because that seems like a lot of work. So I'm trying to make a decision here, what we could utilize. Build, lint, and test a Rails application. That seems pretty small or easy for me to do, but maybe we should try to use one of these things down below. Labels, pull requests based on files changed. Let's go ahead and see if we can utilize that. So I hit the configure button, and it's going to bring us into this action. And I guess there's the marketplace where we can get more stuff. I didn't even realize there was a marketplace for this. Looks like we got some documentation here. So customizing when workflows run based on trigger. So here it says on push branch. So when we push to specific ones, we can trigger different stuff. Okay, so that's kind of cool. Let's take a look here and see if we can expand this and see what we're looking at. So we have name, labeler, on, pull request target, jobs, and then we have labels. So run as Ubuntu, so it'll probably start a container as an Ubuntu with permissions of contents to read, and it can write pull requests. And the step that we're going to have here, it's going to use the Actions labeler version 4, and with the repo token, it's going to bring in that token so it has authorization to do so. And we know about GitHub tokens, and I think we showed this for GitHub Actions, but not 100% sure. So carefully reading here, the whole point of this is to apply labelers. And basically the way it's going to do that is through these steps. And so I'm assuming that this is kind of like a built-in step. And if we go here and just type it in, maybe we'll go find it. Yeah, and so they're talking about actions here. Hold on here. I guess it's just a repo. So we get documentation. And, oh, okay, it's called actions. All right, and so this whole repo contains actions. All right, and so it's coming from this one. And so I'm just going to go into here and take a look at what this looks like. So just zoom out for a second. And it kind of explains maybe how it works. Automatically labels new pull requests based on the paths of the files being changed on the branch. The ability to apply labels based on names of branches and things like that. The bug related to the issue. So create a .github labeler.yaml file. This will list a list of labels and config options to match and apply the label. All right. The match object allows control over the matching options. You can specify the label to be applied based on the files that have been changed and etc. like that. And sounds a little bit complicated. But at least down here, it's like showing us the flow. It's interesting that this one is showing version 4, when clearly there is a version 5. There might have been a warning up here saying that we should use, it doesn't say that we have to use version 5 or 4, or we're first to use 5. But let's see if we can figure this out. So I'm going to go ahead and go down below and just look at the workflow a little bit more here, and it looks pretty much the same. The only difference is that this one's using version 5, and it's not passing the width for the repo token. So I'm not 100% sure if we actually really need to do that, but I'm going to go ahead and go commit changes, and we'll commit that there. Okay, so now we have that here, and if we go to actions, we can see that we have labeler, and it's only going to run what's going to trigger it. Let's go take a look here. If we want to know how it triggers, we should just take a look at the code and, whoops, go back here and take a quick look. So it says pull request target. So we pull request target. What does that mean? We'll go search it here. Pull request target. So activity types: assigned, labeled. Runs your workflow when activity on a pull request in the workflows repository occurs. When activity on a pull request in the workflow activity occurs. So it's going to check on based on a lot of stuff. So that's pretty broad, but that seems fine. It looks like we could even narrow it down to very specific types. Okay, so I mean, that's how we could play with triggers. And so basically when that triggers, it's going to go ahead and then start up Ubuntu for some reason. Maybe that's what it has to use to run this code that we saw from over here. Okay, and this looks like it's JavaScript or something. And then we need that labelers file. So we need to make sense of what this is. So the base match object is defined as this: any glob to any file. Okay. The key, okay, so what does this thing do? Automatically label new pull requests based on the path of the files being changed or the branch name. Okay, well, I'd rather just do that on the branch name. So let's see if we can find that. So it says change files. Give me a moment just to try to make sense of this, and then I'll just save you the trouble of me struggling through it, okay? Okay, scrolling on down, we're getting better examples. So this is starting to make more sense. It says, add an any change label to any changes within the entire repository. Okay, add documentation label to any changes within the docs folder. So maybe what we can do is give this one a go. And we need to create a file. What's this file need to be called? .github labeler YAML. So we'll go here and I'm going to add a new file. Okay. Add a file. This will be labeler.yaml. We'll double check, make sure that is correct. I've been known to make mistakes often. And I'm going to paste that on in here and we're going to commit that change. And so now we have our labeler YAML. I'm going to go take a look here and see if the action got triggered. It did. It failed. I mean, there's nothing for it to check right now. So no event triggers defined is on. So not exactly sure what it's saying there, but that's totally fine for now. And what I need to do is I need to create a pull request. I mean, it shouldn't trigger unless we have a pull request, right? But it did just happen now. So I'm curious what would happen if I went ahead and just made any kind of change, because it shouldn't really trigger unless it's a pull request. We'll go here and go back to actions, and it ran again. So I'm really confused. Why is this running when it should only happen on a pull request target? We'll open it up again here. So no event trigger defined is on. Okay. Maybe there's something wrong with our workflow file. Let's see what they say. You can trigger all branches just by using remove the hyphen. Your workflow file seems fine. Have you checked all indentation? So, I mean, we didn't make that file, right? It was generated for us. But let's go take a look and see what we can do about that. We have label and labeler. Okay, so this was the one that we wrote. I mean, everything looks fine here. I'm going to open this up in Codespaces, or not Codespaces, we'll open this up in github.dev just to see if we can rule out any kind of formatting issues. YAML files are very sensitive to any kind of indentation or things that go wrong. And so I just want to rule that out. So looking here, this all looks fine. I know that this is an array, so we could technically bring this down on this line like this and do that. I don't know if we need this. So I'm just going to take that out because the other one didn't have it. Okay. Can expand this. Yeah, it still has this here. And I'm not sure why this little red line is here. Maybe it's just superficial and it's confused. But this seems fine. I'm going to go ahead and update this and say update action. The other question is, do I have this in the right folder? Because Yeah, it is. It's in Actions. But labeler YAML isn't supposed to be in the Actions folder. So I think what's happening here is that it thinks, I think I know what happened here. If we go back to our repo, I think it thinks labeler is an action. Yeah, so I think it's just we put that in the wrong folder. So I'm going to go back and open up github.dev again. And we're just going to move that back into the correct location. Okay, so we're going to expand that. And this labeler is going to go into the GitHub folder. There we go. Going to go ahead and add this all and fix. And we will commit. And we will let that push. And I'm going to go back over to here. All right, and if we go back over to Actions, this is not the repo. We'll go back over to our organization into Fun Repo. It might have triggered one more time, I don't know. It has not, so we are in good shape. Can we delete this run? Yep, we can. Let's just delete this up to clean up so we can see what we're doing. And what I want to do is I want to trigger that pull request to get automatically labeled. So we're going to need a label called documentation for this to work. So we're going to go here to labels and we'll make a new label. There actually already is one called documentation. I don't know if this is case sensitive, so I'm just going to change it to capital D so it just works for us. And we're going to go over here to code and I need a new branch. So I'm going to go to dev. And in here, I'm going to create myself a docs directory. So I'm going to make a new folder here. And what I'll do is I'll make a new folder. We'll call this docs. And I'll say readme.md. Readme. Okay, we'll save that. We'll go ahead and commit this. And we're in a branch, right? Yeah, we're in a branch. So commit, we're like new docs directory. And I know I spelled that wrong. It's okay. Nobody's watching here today. There's no grading going on. If I ever grade you, I'll poke you for that. But right now it doesn't matter. And I think that we made that in the dev branch. So we'll go over here. And I want to go ahead and create a new pull request. So I want to make sure that folder is there. Pull requests, new pull request. We'll drop down dev. We'll compare that over. We'll say create pull request. And the idea is that when we create this, it should label it if this worked as expected. And so what I want to do is go over to Actions and see if it triggered. And it's running, so it's queued. It's going to think what to do. It has to spin up compute. So this isn't instantaneous. In progress, good, we're watching it. Label, complete, success. We'll go to our pull request. There we go, look at that. And now we have a check that passed. And we go to our checks and it shows that it passes. So, you know, before we talked about like branch rules, we could maybe just tell it that it has to pass that before it could proceed. Not a really good example for this, but we could try it. And it's just an opportunity to show off this branch protection rule stuff. So I'm just looking here carefully for where that was. It was like checks. Okay, and I'm just gonna drop that down. And still doesn't show up here. So maybe that doesn't work as expected, but I was hoping that maybe I could just choose that from there. Because it's not like an upfront check. It's like something that happens after you do that. But anyway, that's GitHub Actions in a nutshell. It is very important that we understand how those files work. So before I go, I just want to pull up a link because there was something that really explained the structure of these files really well. It was understanding GitHub Actions. Okay, so it's this here, learn GitHub Actions, understanding GitHub Actions. I think it was this one. Yeah, and so this one really helps explain this workflow file. So let's go through it really quickly and make sure we understand it. So first thing is the name. So we're gonna name it, that's optional. We have run name. So the workflow runs the generated from the workflow. I guess it's gonna be like the run name we have on. So specify the trigger of this workflow. So on triggers events, jobs, groups together all the jobs that run. Then we have steps, groups together all the steps that run in the checkbats version. Notice we didn't have these before. Runs on, configures the run on the latest version of Ubuntu Linux Runner. I imagine you could change this to other things. Uses, the uses keyword specifies the step that will run here. And of course, we found out those are remote repos, so that makes sense. And that's pretty much it. So steps, jobs, on. Remember those three: on, jobs, and steps, okay? And that's pretty much it. So I'll see you in the next one, okay? Ciao.
Hey, this is Andrew Brown from ExamPro, and in this section, we'll be going over package management. Package management refers to a systematic approach to handling the installation, upgrade, configuration, and removal of software packages within a computer system. It simplifies the process of managing software applications and their dependencies, ensuring consistency and efficiency across the development lifecycle and system maintenance. Core functions and benefits. Automated handling automates the management of software applications, reducing time and effort for installation, upgrades, and removal. Consistency across environments ensures uniform software management across various environments, boosting efficiency and reliability. Dependency and configuration management automates management of dependencies and configurations, ensuring compatibility and availability for stable performance. Scalability facilitates software management across multiple systems, easing updates and rollbacks. Key components. Package, a bundle containing software or libraries, along with metadata that includes information like version, dependencies, and configuration details. Repository, a centralized storage location where packages are hosted, allowing users to search, download, and install packages. Package Manager, the tool that interfaces with repositories to manage the installation, upgrading, and removal of packages based on dependencies and version requirements. Some tools and examples include Linux package managers, DPKG such as Debian and Ubuntu, RPM such as Red Hat and Fedora, language-specific managers, NPM for JavaScript, Tip for Python, and Maven for Java. So that's an overview of package management. The next topic we'll be covering are package feeds. A package feed is a repository hosting software packages such as libraries, frameworks, modules, along with associated metadata. It supports dependency management and various application scenarios through package versioning and organization. Types of package feeds. Public feeds, hosted by third-party providers like NuGet.org and PMJS.com and accessible to the broader development community. Private feeds, internal repositories managed by organizations to store proprietary packages and control team access. Designing a package feed. Key considerations. Storage, select from local file systems, network-attached storage, or cloud-based services. Organizational structure, categorize packages by type, purpose, or technology. Versioning, implement a versioning strategy, typically semantic versioning. Access control, set up authentication and authorization mechanisms for private feed security. Implementing a package feed. Tools and platforms. Azure Artifacts, a fully managed Microsoft Azure service supporting NuGet, NPM, Maven, and Python packages. It simplifies the creation, publication, and management of package feeds. GitHub Packages supports various package formats, integrates with GitHub repositories, and allows direct package publishing, ideal for open source projects. Package management tools like NuGet, NPM, and Maven that offer capabilities to create and host feeds with command line or IDE integration. Using upstream sources. Functionality. Upstream sources extend the range of available packages by linking additional feeds, whether public, private, or both. In Azure Artifacts, upstream sources can include other Azure feeds, package registries, or public feeds. This ensures that the latest package versions are always available. Configuration. Configurable via the Azure DevOps portal or Azure CLI, allowing Azure Artifacts to search upstream sources for packages not present locally. So that's an overview of package feeds. Let's take a look at dependency management. Dependency management automates the handling of software dependencies to ensure projects run smoothly with all necessary external libraries, frameworks, and modules. Key components. Dependencies, required external software components. Version specification defines compatible dependency versions. Dependency graph shows relationships among dependencies. Package repository, central hub for dependencies. Dependency resolver automates dependency resolution. Benefits: streamlined development automates environment setup by managing dependencies. Consistent builds ensures uniform dependency versions across all development stages. Reduce conflicts manages compatibility to prevent software component conflicts. Efficient upgrades manages dependency versions for easy updates. Implementation: configuration files specify dependencies using files like package.json or pom.xml. Version locking uses lock files to maintain consistent dependency versions. Automated tooling tools like npm, maven, and pip automate dependency management tasks. Let's take a look at a comparison between dependency versus package management. Purpose: dependency management ensures compatibility and resolves dependencies, while package management handles package lifecycle. Focus: dependency management targets component compatibility, package management manages package storage and lifecycle. Main function: dependency management automates resolution, package management oversees handling and distribution. Tools: both use npm and maven. Dependency management also uses pip, while package management incorporates NuGet and others. Outcome: dependency management maintains functionality, package management streamlines processes. Usage scenario: dependency management is essential for external library reliance, package management is crucial for consistent management. So that's an overview of dependency management. The next thing we'll be covering is an overview of Azure Artifact. Azure Artifacts is a component of Azure DevOps services focused on package management and collaboration. It supports sharing, versioning, and integrating packages into CI/CD workflows. Some of the features that Azure Artifacts provide are: package management, supports multiple package formats, manages NuGet, npm, maven, Python, and universal packages all in one place. Version control offers tools for managing package versions and dependencies effectively. Integration and collaboration. CI/CD integration integrates with Azure DevOps pipelines for streamlined package creation and deployment. Shared feeds allows package sharing within teams or the entire organization. Access control and security. Access control offers settings to control package access, maintaining security within projects. Secure hosting provides a secure environment for hosting and accessing packages. Getting started with Azure Artifacts. An Azure subscription is required to use Azure Artifacts. Creating a feed. Navigate to your Azure DevOps organization or project. Select artifacts from the top right menu, then create feed. Enter the required information, such as name and visibility options, and create the feed. After creating a feed, you can publish packages like NuGet, npm, and maven, but we'll need to do a few things before that. So first, we'll need to ensure you have the latest version of the Azure Artifacts credential provider installed. From the Get the Tools menu, NuGet configuration file, you need to add a NuGet config file to your project in the same folder as your csproj or sln file. The configuration should specify the package source for Azure Artifacts like the code shown here. This will be provided for you depending on the package you pick. Publishing command: to publish a package, provide the package path, an API key, and the feed URL. NuGet.exe push-source ExamPro feed-API key AZ package path. Replace package path with the actual path to the package you intend to publish. So that's an overview of Azure Artifacts. The next topic we'll be covering is NuGet and npm. NuGet is a popular package manager for net applications. It allows you to easily manage dependencies and distribute packages within your projects. Creating a NuGet package. Use the NuGet.exe or .NET command line tool. Example using .NET, navigate to your project directory and run .NET pack -- configuration release. This generates a NuGet package from your project in the release configuration. Publishing NuGet packages. You can publish to Azure Artifacts, GitHub packages, or host your own NuGet feed using platforms like Azure DevOps Server, MyGet, or ProGet for private distribution. npm is the default package manager for Node.js and JavaScript applications. It provides a vast ecosystem of packages that developers can use within their projects. Creating an npm package. Initialize a new project with npm init. Follow the prompts to generate a package.json file that includes your package's metadata. Publishing npm packages. To publish to the npm registry, ensuring your package is available globally, run npm publish. This command uploads your package to the npm registry for public access. So that's a short and simplified overview of NuGet and NPM. The next thing we'll be covering are the main types of versioning. Versioning in DevOps refers to the practice of assigning unique versions to code or artifacts to track changes and maintain historical records. Versioning strategy options. Semantic versioning, detailed structure indicating the nature of changes. Date-based versioning uses dates offering a chronological timeline of updates. Sequential versioning, simple incrementation, providing clear change order. Semantic versioning is a widely used method that helps manage changes in software libraries through 3 version components: major, minor, and patch. Major version increases indicate backward incompatible changes. Minor version increases are for backward compatible additions. Patch version increases apply to backward compatible bug fixes. Guidelines for semantic versioning. Initial release, start with 1.0.0 for stable software. Major changes, increment major version for breaking changes. Minor additions, increment minor version for new features that maintain compatibility. Bug fixes, increment patch version for stability improvements without new features or breaking changes. Date-based versioning uses the format YYYYMMDD to reflect release dates, offering a clear timeline of updates. Consistency, maintain a standardized date format. Major changes, mark significant updates in the version name, e.g. 2022-0114 alpha. Combination with semver, enhance detail by combining with semantic versioning, e.g. 2022-0114 alpha 1, 2, 3. Sequential versioning assigns a unique sequential number to each version of a pipeline artifact, starting with version 1. Each update increments the version number progressively. It's straightforward and clearly indicates the chronological order of changes. So that's an overview of the main types of versioning. Hey, this is Andrew Brown from ExamPro, and in this section we'll be covering the key considerations when implementing an agency infrastructure. Designing and implementing an agent infrastructure is crucial for a successful DevOps solution. Key considerations include cost, tool selection, licenses, connectivity, and maintainability. Cost considerations. Azure Pipelines agents, hosted by Microsoft, cost-effective, built based on parallel pipelines. Self-hosted agents, more control but additional costs for hardware, maintenance, and scalability. Tool selection. Azure Pipelines automates build, test, and deployment across platforms, supports various languages, containerization with Docker. Visual Studio Team Services, predecessor of Azure DevOps, integrates with Azure Pipelines, features source control, work item management, and project planning. Licenses. Azure Pipelines, free tier with limited concurrent pipelines and duration, paid tier for more scalability. Self-hosted agents requires licenses for the underlying operating system, such as Windows Server or Azure VMs. Connectivity. Azure Pipelines agents secure internet communication using HTTPS, fetches source code, executes tasks, and reports results. Self-hosted agents network access to resources like source control repositories, artifact feeds, and target environments within your infrastructure. Maintainability. Azure Pipelines agents automatically updated by Microsoft, no manual effort required. Self-hosted agents, regular updates needed for compatibility with guidance provided by Microsoft. So that's an overview of implementing an agency infrastructure. The next thing we'll be going through are pipeline trigger rules. Pipeline trigger rules define conditions under which a pipeline is automatically triggered, optimizing resource usage and reducing unnecessary builds and deployments. Microsoft DevOps solutions offer flexibility in designing custom trigger rules. Here are key scenarios. Branch-based trigger a pipeline only when changes are made to a specific branch. This triggers the pipeline for changes in the main branch. Path-based trigger a pipeline when changes occur within specific file paths. This triggers the pipeline for changes in the SRC directory. Schedule-based trigger run pipelines at scheduled intervals, regardless of code changes. This triggers the pipeline every day at midnight. Implementing pipeline trigger rules. Navigate to your project in Azure DevOps. Open the YAML file that defines your pipeline. Locate the trigger section within the YAML file. Define the desired trigger rules based on the scenarios above or any custom rule. Save the YAML file. Benefits of pipeline trigger rules. Reduce resource consumption, minimizes unnecessary usage, leading to cost savings and efficient resource utilization. Improved efficiency ensures actions are performed at the right time, streamlining development and deployment processes. Enhanced control provides developers with control over pipeline execution, improving management and coordination of development efforts. So that's an overview of pipeline trigger rules. The next topic we'll be covering are the types of pipelines. Classic pipelines provide a graphical interface for creating and configuring pipelines using a drag-and-drop approach. This simplifies defining the stages of your pipeline, such as build, test, and deployment. Steps to create a classic pipeline. 1. Select pipelines from the left side menu. 2. Click New Pipeline to start. 3. Choose the repository where your source code is located. 4. Select a pipeline template based on your application type, such as ASP.NET, Node.js, and Java. 5. Customize the pipeline stages, tasks, and configurations. Add tasks like building the code, running tests, and deploying the application. 6. Save and run the pipeline. YAML pipelines offer a flexible, code-centric approach to defining pipelines. Pipeline configurations are defined as code in YAML files, which can be version controlled along with your source code for easier collaboration and consistency across environments. Creating a YAML pipeline. 1. Select the Pipelines option from the left side menu. 2. Click on the New Pipeline button. 3. Choose the repository where your source code is located. 4. Select the YAML option when prompted to choose the pipeline configuration style. 5. Create a YAML file in your repository to define your pipeline configuration. The YAML file should contain stages, jobs, and tasks as per your requirements. For example, as shown on the image on the right. 6. Save the YAML file in your repository and commit the changes. 7. Azure DevOps will automatically detect the YAML file and create the pipeline based on the configuration defined in the YAML file. 8. Save and run the pipeline to see it in action. So that's an overview of the types of pipelines. The failure rate of your pipeline indicates the number of failed builds or deployments over a specific period. Monitoring the failure rate helps you identify potential bottlenecks or issues in your pipeline. Azure Monitor can be used for this purpose. Azure Monitor provides comprehensive monitoring for Azure resources, including pipelines. It collects data on pipeline failures and allows you to set up alerts based on specific failure thresholds. These alerts help you address issues proactively, maintaining pipeline health. Configuration. Enable metrics and diagnostic logs. Metrics include success rate, average duration, and failure rate. Diagnostic logs capture detailed information about pipeline runs, including errors and warnings. Here's an example of how you can enable Azure Monitor for a pipeline. Duration monitoring. Monitoring the duration of your pipeline is crucial. Longer durations indicate performance issues that can impact overall efficiency. Azure DevOps provides built-in capabilities for this. Azure Pipelines allows tracking the duration of individual pipeline runs, identifying outliers, and analyzing performance trends over time. Use the Azure Pipelines REST API to retrieve the duration of pipeline runs. Custom scripts or PowerShell can automate monitoring and reporting. Here's an example of how you can retrieve the duration of pipeline runs using the Azure Pipelines REST API. Flaky tests monitoring. Flaky tests produce inconsistent results, leading to false positives or false negatives. Monitoring and addressing flaky tests is essential for pipeline reliability. Azure DevOps supports various test frameworks and provides tools to detect and monitor flaky tests. Azure Test Plans can manage test cases, track executions, and identify flaky tests. Group test cases and test suites. Schedule test runs and capture results. Analyze results to identify and mark flaky tests. Built-in reporting visualizes trends and tracks improvements over time. Here's an example of how you can mark a test case as flaky using Azure Test Plans. So that's an overview of monitoring pipeline health using various methods. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be covering Azure Container Instances. Azure Container Instances allow you to launch containers without the need to worry about configuring or managing the underlying virtual machine. Azure Container Instances is designed for isolated containers. They are tailored for simple applications, task automation, and tasks like build jobs. Containers can be provisioned within seconds, whereas VMs can take several minutes. Containers are built per second, whereas VMs are built per hour, providing potential cost savings. Containers have granular and custom sizing of vCPUs, memory, and GPUs, whereas VM sizes are predetermined. ACI can deploy both Windows and Linux containers. You can persist storage with Azure Files for your ACI containers. Once deployed, ACIs are accessible via a fully qualified domain name like custom label .azureregion.azurecontainer.io. Azure provides quick start images to start launching example applications, but you can also source containers from Azure Container Registry, Docker Hub, or even privately hosted container registry. Container groups are a collection of containers that get scheduled on the same host machine. The containers in a container group share lifecycle resources, local network, and storage volumes. Container groups are similar to a Kubernetes pod. Multi-container groups currently support only Linux containers. There are two ways to deploy a multi-container group. To deploy a multi-container group, you can use either a resource manager template if deploying additional Azure service resources, or a YAML file for deployments involving only container instances. Overall, Azure Container Instances simplify container deployment and scaling, removing the complexities of infrastructure management. The next topic we'll be going over are container restart policies. A container restart policy specifies what a container should do when their process has completed. These policies ensure that the container instances can handle different scenarios effectively based on the specific requirements of the application or task. Azure Container Instances has 3 restart policy options. Always, this policy ensures that the containers restart continuously regardless of whether they exit successfully or not. It's useful for applications that need to be constantly available, such as web servers. Never. With this policy, containers do not restart once they've completed their execution. This is ideal for tasks that are designed to run once and then terminate, such as batch jobs or scheduled tasks. On failure, containers will only restart if they stop due to an error or unexpected termination. This ensures that if a container crashes or faces an unexpected error, it will try to restart and continue its operations. Overall, choosing the appropriate restart policy is vital for the stability and responsiveness of your applications. The next topic we'll be covering are container environment variables. Environment variables are key value pairs that can be used to configure and manage the behavior of applications running inside containers. Environment variables allow you to pass configuration details to your containers, which can be critical in guiding applications on how to connect to databases, where to find certain resources, or how to adjust their behavior based on the environment they're running in. In Azure, you can easily set up these environment variables for your containers using the Azure Portal, CLI, or PowerShell. Secured environment variables. By default, environment variables are stored in plain text. To address this, Azure offers the option to secure your environment variables. Instead of storing them in plain text, which could expose sensitive information if breached, you can leverage the Secure Environment Variables flag. So that's a quick overview of container environment variables. The next topic we'll be covering is container troubleshooting. Troubleshooting containers in Azure involves a series of commands that help diagnose and resolve issues. As container logs, this command lets you fetch logs from your container. These logs can provide insights into application behavior and possible errors. As container attach, if you need diagnostic data during container startup, use this command. It helps in understanding issues that might arise during the initialization phase of a container. As container exec, for a deeper dive into the container, this command starts an interactive session. This is useful for live debugging and to inspect the container's current state. As monitor metrics list, this command gives you metrics related to your container, such as CPU usage, which can be essential for performance tuning or identifying bottlenecks. So these are the commonly used commands for container troubleshooting. Hey, this is Andrew Brown from ExamPro, and we're going to take a look at Azure Container Instances. So here it is. So all we got to do is go to Container Instances, we'll hit Add. And the nice thing is that Azure provides us with a Hello World one, so it's very easy for us to get started. It's a Linux machine, and it looks like it's pretty inexpensive there, so we'll stick with that. I'm going to create a new group here. We're going to call it Banana, and we'll name the container instance Banana. And East US 2 seems fine to me. You'll notice we're on a quick start image. If we wanted, we could use something from the Docker Hub and provide our own link, but we'll just stick with the quick start image for today. We're going to go ahead and hit next to networking just to see what we have as options. You can make it public or private. We'll go to advanced. Hold on here. Yep, those are just the ports you can expose. We'll go to advanced, and for the restart policy, we can set on failure, always or never. We can pass in environment variables, and I've covered this a lot more in detail in the lecture content, so we don't need to really dive deep into this. And we'll go ahead and create this instance. And so we'll have to wait a little while here, and I'll see you back in a moment. Okay, and so after a short wait, our container instance is ready. We'll go to that resource there and take a look around. So on the left-hand side, we can go to our containers, and there we can see it running. We can see the events down below of what's going on. So you can see that it's pulled the image, it successfully pulled it, and then it started the container. Some properties, nothing interesting there. The logs if we wanted to see stuff. And if we wanted to connect to the instance, we could also go here and hit connect, which is kind of nice. I don't have any purpose to do that right now. And it's also not going to work the way we're doing it, but I just wanted to show you, you had those opportunities. You can do identity, so that means manage it with role-based access controls. But what I want to see is actually this hello world working. I'm assuming that must be a hello page. I've never looked at it before. So we're going to go here, grab the public IP address and paste it on in the top. And there we go. So we have deployed a instance onto Azure container instances, or a container, I should say. So nothing super exciting to talk about here, but we do need to know the basics there. If we wanted to deploy other containers, it's just the one there, so that's all you really need to do. But yeah, so yeah, hopefully that gives you an idea there. I'll just go back to the list here so we can see it, and we'll go ahead and just delete that. Probably do it via the resources on the left-hand side, like I always like to do. And we will go into Banana here, and we will delete Banana, and there you go. Self-hosted agents in Azure DevOps allow you to customize the agent environment to meet specific needs. Unlike Microsoft hosted agents, self-hosted agents run on your infrastructure, giving you more control over the environment and the tools installed on the agents. Use cases: custom environments for specialized software or configurations not available in Microsoft hosted agents. Sensitive data suitable for projects with stringent data security requirements, keeping data within your network. Resource-intensive builds, useful when builds require significant computational resources or specific hardware setups. Benefits: customization, tailor the environment to specific project needs. Cost efficiency, reduce costs by utilizing existing infrastructure. Consistent configurations, ensure consistent setups across agents through templates or containerization. Scalability, scale based on workload by provisioning new agents. Configuring self-hosted agents with VM templates. Create a virtual machine with the necessary agent software, save it as a template, and use the template to provision additional agents for consistent and simplified scaling. Create and configure a VM, set up a virtual machine with the necessary operating system and dependencies, install and configure the Azure DevOps agent software. Create a VM template, capture the VM as a template, including the agent software and its configuration. Provision new agents, use the template to quickly provision new agents, ensuring each new VM has the same configuration and is ready to connect to Azure DevOps. Managing self-hosted agents with containerization. Containerization involves creating Docker images that include the necessary agent software and dependencies, offering a flexible and scalable solution for managing self-hosted agents. Create a container image, develop a Docker image with the required agent software and dependencies, including configuration details. Push to a container registry, store the container image in a registry like Azure Container Registry or Docker Hub. Deploy and scale containers, use container orchestration tools to deploy and manage agent containers, scaling up or down based on workload demands. So that's an overview of self-hosted agents. Hey, this is Andrew Brown from ExamPro, and in this section we'll be covering the types of deployment strategies. A successful deployment strategy is crucial for efficient software delivery and minimizing user impact. Microsoft DevOps Solutions offers various deployment patterns and strategies for continuous delivery and high availability. Blue-green deployment is a technique that reduces risk and downtime by running two identical environments. These environments are called blue and green. Only one of the environments is live, with the live environment serving all production traffic. In blue-green deployment, blue is live and green is set up for the new release. Deploy and test the new version in green without affecting blue. After testing, switch traffic to green, making it live. This minimizes downtime and allows for quick rollback to blue if issues arise, enhancing reliability and user experience. So that's an overview of blue-green deployment. A canary release is a strategy where a new version is deployed to a small subset of users or infrastructure first. This helps identify unforeseen issues under real conditions with limited impact. By monitoring the initial deployment's performance, teams can decide whether to expand, halt, or roll back the update based on real-world feedback. This phased approach ensures a safer and more controlled rollout, minimizing risks associated with new releases. To execute a canary release, feature toggles, selective feature activation, traffic routing, manage user access to the new version, deployment slots, version management. These techniques enable a gradual and monitored rollout, allowing for adjustments based on user feedback and system performance. This method enhances application stability and user experience by addressing potential issues before a full-scale deployment. So that's an overview of canary release. Ring deployment is a strategy where users or infrastructure components are divided into multiple groups called rings. Each ring receives updates sequentially, starting with the smallest group and gradually expanding to the entire user base. This allows for iterative releases, starting with an internal ring and progressively reaching a wider audience. This controlled rollout facilitates early feedback from different user groups or components. For example, in a 3-group production setup, canaries voluntarily test new features as soon as they are available. Early adopters voluntarily preview releases, which are more refined than canary versions. Users receive the final product after it has passed through canaries and early adopters. This approach ensures a safer, step-by-step rollout of new features or updates. So that's the ring deployment strategy. Progressive exposure is a deployment technique that gradually increases the number of users exposed to a new release. Initially, a small percentage of user traffic is directed to the new release while its performance and behavior are monitored. If the new release performs well without issues, the traffic is gradually increased. This approach helps identify potential issues early and minimizes user impact if problems arise. Continuous integration, code check-in, developers check in code. Auto trigger, CI pipeline triggers automatically. Build artifact, code is built, generating an artifact. Continuous deployment. Build version 1 approved and deployed to ring 1 for initial testing. Build version 2 approved and deployed to ring 2 for early adopters. Build version 3 approved and deployed to ring 3. Production environment. Ring 1 canaries test new features. Ring 2 early adopters preview refined releases. Ring 3 all users receive the final product. So that's the progressive exposure deployment strategy. Feature flags are conditional statements that let you control which features or functions are visible and available in your application. Using feature flags, you can enable or disable features dynamically without redeploying the application. This allows for testing new features, gradual rollouts, or quick deactivation if issues arise. Feature flags also offer the flexibility to target specific user groups for testing or rolling out features. A new feature is introduced. Feature flags toggle switches control the visibility of the feature. Enabled, the feature is enabled for specific customer groups. Disabled, the feature remains off for other customer groups. Different customer groups experience the feature based on the feature flag settings. This allows controlled, targeted rollouts and quick adjustments of feature availability without redeployment. So that's an overview of the feature flag deployment strategy. A/B testing is a method to compare two versions of a feature or user interface to see which one performs better. Users are divided into 2 or more groups, each group experiencing a different version. Data on user behavior, engagement, and other metrics are collected. This approach helps make data-driven decisions and optimize feature usability before a full rollout to all users. User groups. Users are divided into 2 groups. Version A and Version B, each group is shown a different version of a feature or user interface. Performance comparison, user behavior and performance metrics are collected and compared. Results, the graph shows which version performs better based on the collected data. This helps in making informed decisions about which version to implement for all users. So that's an overview of A/B testing. Azure Traffic Manager operates at the DNS layer to quickly and efficiently direct incoming DNS requests based on the routing method of your choice. Routing methods. Performance, route traffic to nearby servers to reduce latency. Weighted, distribute traffic based on predefined weights. Priority, route to a primary endpoint with failover to backups if needed. Geographic, route traffic based on the user's location. Multi-value, return multiple healthy endpoints and DNS responses. Subnet, route based on the user's IP address. Uses. Latency reduction, route to nearby servers to minimize latency. Failover, switch traffic to backups if the primary system fails. A/B testing, route traffic to random VMs for testing. In this scenario, we have an example of weighted routing where traffic is split 80% to production and 20% to beta environments. So that's a quick overview of Azure Traffic Manager. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be covering Azure App Service. Azure App Service is an HTTP-based platform for web apps, RESTful APIs, and mobile backend services. You can choose your programming language in Python, Java, or any other language and run it in either a Windows or Linux environment. It is a platform as service, so it's the Heroku equivalent for Azure. Azure App Service takes care of the following underlying infrastructure, OS and language security patches, load balancing, auto-scaling, and infrastructure management. Azure App Service makes it easy to implement common integrations and features, such as Azure DevOps for deployments, GitHub and Docker Hub, package management systems, easy to set up staging environments, custom domains, and attaching TLS or SSL certificates. You pay based on an Azure App Service plan. Shared tier includes free and shared options. Linux isn't supported here. Dedicated tier includes basic, standard, premium, premium 2, premium 3, and there's isolated tier. Azure App Service is versatile. You can deploy single or multi-container Docker applications. When you create your app, you have to choose a unique name since it becomes a fully qualified domain. Overall, Azure App Service simplifies your web hosting needs, ensuring you can focus on coding and let Azure do the heavy lifting. Let's delve into runtimes in Azure App Service. So, what is a runtime environment? A runtime environment refers to the software and settings needed for a program to run in a defined way at runtime. A runtime generally means what programming language and libraries and framework you are using. A runtime for Azure App Services will be a predefined container that has your programming language and commonly used library for that language installed. With Azure App Services, you're presented with a range of runtimes to choose from, including .NET, .NET Core, Java, Ruby, Node.js, PHP, and Python. Moreover, Azure App Services generally supports multiple versions of each programming language. For example, for Ruby, you might find versions 2.6 and 2.7. It's worth noting that cloud providers, including Azure, may phase out support for older versions over time. This not only ensures that they're offering the latest and most efficient tools, but also promotes better security practices among users, pushing them to keep up with the latest patches. So that's an overview of runtimes in Azure App Service. The next thing we'll be covering are custom containers in Azure App Service. Azure App Service gives you the flexibility to use custom containers for both Windows and Linux. The primary reason you might opt for a custom container is to use a distinct runtime that isn't natively supported or to incorporate specific packages and software. Here's a straightforward process to get started with custom containers in Azure App Service. Design your container. Begin by creating a Docker container tailored to your needs on your local machine. Push to Azure. Once your container is ready, push it to the Azure Container Registry. This centralized repository ensures that your container is easily accessible within Azure. Deploy and go live. Finally, deploy your container image directly to the Azure App Service. Once deployed, Azure takes care of scaling, maintenance, and updates. Another advantage of custom containers in Azure App Service is that they offer more granular control over your environment. You can fine-tune performance, security, and other aspects of your application environment to suit your needs. The next topic we'll be covering are deployment slots in Azure App Service. Deployment slots allow you to create different environments of your web application associated to a different host name. This is useful when you require a testing, staging, or QA environment alongside your production setup. Deployment slots let you swiftly replicate your production setting for various purposes, ensuring consistent testing environments. You could also swap environments. This is useful for executing blue-green deployments. By using swap, you can promote your staging environment to production with ease. You can promote our staging to production by swapping. If something goes wrong, you could swap them back. This capability ensures minimal downtime and enhances the user experience since you can introduce changes in a controlled manner, rolling them back if necessary. In addition, Azure ensures that when swapping, the instances are warmed up before traffic is rerouted, resulting in zero downtime. So that's a quick overview of deployment slots. The next topic we'll be covering is the App Service environment in Azure App Service. App Service environment is an Azure App Service feature that provides a fully isolated and dedicated environment for securely running App Service apps at high scale. This allows you to host Windows and Linux web apps, Docker containers, mobile apps, and functions. App Service environments are appropriate for application workloads that require very high-scale isolation and secure network access and high memory utilization. Customers can create multiple ASEs within a single Azure region or across multiple Azure regions, making ASEs ideal for horizontally scaling stateless application tiers in support of high requests per second workloads. ASEs comes with its own pricing tier called the isolated tier. ASEs can be used to configure security architecture. Apps running on ASEs can have their access gated by upstream devices, such as web application firewalls. App Service environments can be deployed into availability zones using zone pinning. There are two deployment types for an App Service environment, External AS and ILBS. External AS exposes the AS-hosted apps on an internet-accessible IP address. If the VNet is connected to your on-premises network, apps in your AS also have access to resources there without additional configuration. Because the AS is within the VNet, it can also access resources within the VNet without any additional configuration. ILBS exposes the AS-hosted apps on an IP address inside your VNet. The internal endpoint is an internal load balancer. So that's an overview of App Service environment in Azure App Service. The next thing we'll be going over is deployment in Azure App Service. So what is deployment? Well, it's the action of pushing changes or updates from a local environment or repository into a remote environment. Azure App Services provides many ways to deploy your applications, including run from package, deploy zip or WAR, deploy via FTP, deploy via cloud sync such as Dropbox or OneDrive, deploy continuously with GitHub, Bitbucket, and Azure Repos, which using Kudu and Azure pipelines, deploy using a custom container CI/CD pipeline, deploy from local Git, deploy using GitHub Actions, deploy using GitHub Actions containers, and deploy with template. Run from a package is when the files in the package are not copied to the www root directory. Instead, the zip package itself gets mounted directly as the read-only www root directory. All other deployment methods in App Service have deployed to the following directory. For Windows, we use backslashes, home, site, www root. For Linux, we use // home, site, www root. Since the same directory is used by your app at runtime, it's possible for deployment to fail because of file lock conflicts, and for the app to behave unpredictably because some of the files are not yet updated. Zip and WAR file deployment uses the same Kudu service that powers continuous integration-based deployments. Kudu is the engine behind Git deployments in Azure App Service. It's an open-source project that can also run outside of Azure. Kudu supports the following functionality for zip file deployment: deletion of files left over from a previous deployment, option to turn on the default build process, which includes package restore, deployment customization, including running deployment scripts, deployment logs, and a file size limit of 2048 megabytes. You can deploy using Azure CLI, Azure API via REST, and Azure Portal. You can use File Transfer Protocol to upload files. You will need your own FTP client. You just drag and upload your files. Go to the Deployment Center. Get the FTP credentials for your FTP client. You can use Dropbox or OneDrive to deploy using a cloud sync. Dropbox is a third-party cloud storage service. OneDrive is Microsoft's cloud storage service. You go to Deployment Center, configure for Dropbox or OneDrive. When you turn on sync, it will create a folder in your Dropbox cloud drive. OneDrive apps, Azure Web Apps. Dropbox apps, Azure. This will sync with your home site, www root, so you just update files in that folder. In summary, Azure App Service offers a range of deployment methods, ensuring flexibility and ease for developers. The next thing we'll be covering is the Azure App Service Plan. Azure App Service Plan determines the region of the physical server where your web application will be hosted and defines the amount of storage, RAM, and CPU your application will use. It offers several pricing tiers. Shared tiers. There are two shared tiers, free and shared. Free tier this tier offers 1 GB of disk space, supports up to 10 apps on a single shared instance, provides no availability SLA, and allows each app a compute quota of 60 minutes per day. Shared tier provides hosting multiple apps up to 100 on a single shared instance. No availability SLA is offered, and each app gets a compute quota of 240 minutes per day. It's worth noting that Linux-based instances aren't supported in this tier. Dedicated tiers: Basic, Standard, Premium, Premium 2, Premium 3. Basic offers more disk space, unlimited apps. 3 levels in this tier that offer varying amounts of compute power, memory, and disk storage. Standard allows scaling out to 3 dedicated instances, guarantees 99.95% availability, and also has 3 levels with varying resources. Premium provides the ability to scale up to 10 dedicated instances and ensures 99.95% availability, and it includes multiple hardware level options. Isolated tier: dedicated Azure Virtual Network, full network and compute isolation, scale out to 100 instances, and availability SLA of 99.95%. So the Azure App Service plan lets you tailor your hosting environment and budget to fit your application needs. Hey, this is Andrew Brown from ExamPro, and we are going to be learning about Azure App Services in this follow-along, and it's a service that's supposed to make it easy for you to deploy web applications. I say supposed to because it really depends on your stack. Azure has more synergies with other stacks than others, so like if you're like me and you like Ruby on Rails, you're going to find a lot of friction with Rails and Linux, but if you're using something like Windows servers or Python or .NET, you're going to have a much easier time. Still a really great service, just wish they'd make it a bit more broad there, but let's hop into it. So before we can go use that service, let's make sure that it's activated. And so we'll go over here and we'll go to Azure subscription. And then down below, we're going to go to resource provider. Now you'd think what you could do is just type in app services, and you'd be wrong because the service is under a particular provider. So if you want to figure out what provider it is, we can go Azure resource providers. And they have a page on documentation here that lists them all. So if I search for Azure App Services, it's under web and domain registration. So we're going to make sure this is registered. If we're using a custom domain, which we are not today, we need this one activated. So going back here, I will type in web and you can see it's registered. So if yours is not registered, go ahead and hit that. I believe this by default is generally registered with new Azure accounts. So I don't think that is an issue for you, but we'll go back up here, close these additional tabs, and we will type in Azure App Services. And we will look for that service. So there it is. And we'll go ahead and hit add. And so I'm going to give it a new name. I just made it a moment ago, but I'm going to try again and try to use the same name. So we're going to call this Voyager. Great. And then I'm going to go ahead and name this Voyager. And I already know that that is taken. So I'm going to type in Delta Flyer. And these are fully qualified domains, so they are unique. With Azure App Services, you can run a Docker container. We're doing code this time around. And what I like to use is Ruby. But again, if I want to use the CI/CD, I'm not going to be able to use the deployment center with Ruby, so that is not possible. And so we're going to go with Python and run either a Flask or a Django app. I haven't decided yet. I am in Canada, so let's go to Canada East. And down below here, we have the plans. Generally, the plans will tell you the cost underneath. You'll notice that it's loading, but I just want to show you that there are some discrepancies in terms of pricing. So if I was to go to Azure App Services pricing, and we were to pull this up here, we can kind of see the pricing here. Okay, and if we scroll on down, right now we're looking at a premium V2, and oh no, I don't need help, I'm okay. You'll notice that it's 20 cents per hour. So if I go here and do that times 730, because there's 730 hours in the year, that's $146. I believe this is showing me in USD dollars. Yeah. And here it's showing me 103 Canadian, which is lower. So it could be that because I'm running in a Canada East region, the price is different, but you could imagine that if I had this at this cost at, what did we say here? At 146 USD, to CAD, I'd actually be paying $182. So you got to watch out for that kind of stuff, but I'm pretty sure this is what the cost is. So just be aware that if you look stuff up in here, it's not necessarily reflective. So you got to do a little bit more work to figure that out. If we wanted to go here, we cannot choose the free tier when we're using Linux. If we're using Windows, I believe we can use it. We're working with Linux today, so that's just how it's going to be. For the B1, this is totally fine, but we want to utilize deployment slots. Deployment slots is an advanced feature of the production version, and that's the only way we're going to be able to use it here. This is 20 cents per hour again, so I don't want to be doing this for too long, but I think what we'll do is before we do that, we can just do an upgrade to dev to prod so we can experience that. I'm going to go and just choose B1, okay? So we'll go next. We do not need any application insights for the time being, and it will not let us, so it's okay. We'll go next, review and create. And we'll go ahead and create this resource here. And I will see you back when this is done. So our resource is now set up. We'll go to resource. And now that we're in here, you'll notice if we hit browse, we're not going to see anything because we do not have anything deployed, which makes sense, right? So we're going to actually have to go ahead and deploy something. So we are going to make our way over to the deployment center. And it's just going to tell us that we have yet to configure anything, and that's totally fine. We're going to go to settings. It'll give it a moment. And so the thing is that we're going to need something to deploy. I did not create an app, but the great thing is in the Azure documentation, they have a bunch of quick starts here. All right, and apparently they have one for Ruby as well, but today we are looking at Python. And so they actually have an example repository for us here, which is github.com, Azure samples, Python docs, hello world. And I mean, I could go make a repo for you, but we might as well just use the one that is already provided to us. So I'm just going to pull this up to show you what's in it. It's a very, very simple application. Even if you don't know anything about building web apps, I'm going to walk you through it really easily here, okay? So we're going to open up app.py. So we are using Flask. If you've never heard of Flask, it is a very minimal Python framework for creating web apps. Very uninspiring homepage here, but it gets the job done. It's going to create a default route for us, which we have there. We're going to call hello here, and we're going to have hello world. So that's all that's going on here. Very, very simple. And we have our requirements. This is our package manager. I don't know why Python uses txt files. It's very outdated to me, but that's what they use. And here we have Flask. All right. So we're going to use that repo. It's a public repo, so it should be very easy for us to connect. So we'll drop down, go to GitHub, and the next thing we need to do is authorize GitHub. All right, so I ran into a bit of trouble there because I could not authenticate my GitHub account, but you know what? I just made another GitHub account, so that made it a lot easier. I'm going to go ahead here, hit GitHub, and we're going to try to authorize it. And so now I'm logged into this new one called ExamPro Dev, and we'll go ahead and authorize this application. And we're now in good shape. This repository doesn't have anything in it, so if I want to clone something, I guess I'll probably have to fork that repo. So we'll give it a moment to authorize, and while that's going, I think that's what I'm going to do. I'm going to go and fork the example repo, if I can find the link again here myself. I believe it is... That's still authorizing over there. I'm still looking for it. So it was like examples or something. Samples or examples. All right, so I found a way around the problem. I just made a new GitHub account. So that's all I had to do. And I just won't be using my primary account until I get my phone back. But so what we'll do is go hit connect. I'll hit authorize. And it didn't prompt me because it already connected to this new one called ExamPro Dev. You might have to put your credentials in here. And it's going to ask me to select some things. It's a new account, so there are no organizations, there are no repositories, there are no branches, totally brand new. So what I'm going to need to do is get a repo in there. So we'll just go ahead and fork the Azure samples one. So that is Azure samples, Python, docs, hello world. And if I type that right, we're in good shape. I'm going to go ahead and fork this repository. I'll say got it. And then I'll move this off screen here. This is now cloned. You should see it cloned here. And we'll go back here. And this probably isn't live, so there's no refresh button here. So we'll have to hit discard. And we will give this another go here. And we will select our organization, which is our name. There's the repository. Should be main branch. It's kind of outdated. I'm sorry, but it's called master. That's what it is. Not my fault. That's Azure's fault, okay? And I think that's it. I don't know if we need a workflow configuration file. I don't think so. Just going to double check here. No, I don't think so. And what we'll do is we'll just go ahead and save that. And so now we are set up for deployment. All right, so now that that's all hooked up, if we were to go to browse, we're actually still seeing the default page. A deployment hasn't been triggered just yet. So the way it works is it's using GitHub Actions. So if we click into our, I'm going to call it main branch. I know they got the wrong name, but we're going to click into our GitHub workflows. And then below here, we can see we have a YAML file. And this is for GitHub Actions integration here. And so what it's doing is it's specifying the branch, how it's going to build. It's going to run on Ubuntu latest. The steps it's going to do, it's going to check it out. It's going to set up the Python version. It's going to build it. It's going to do that stuff. And so in order for this to take action, we'd actually have to go ahead and make some kind of manual change, which we have yet to do so, eh? So what we'll do is we'll go back to our main here. And it should be as simple as just changing something here. So it's not, I'm not sure how it's supposed to know that it's supposed to be doing the hello. And I guess, yeah, sorry. So this means it's going to route over to here. So I'm just going to make any kind of change here. Doesn't matter what it is, just one space. We'll go ahead and give it a commit. And if I go back to my latest commits, we should see that I made that change. There it is. We'll go back over here, and this should be deploying. So if we go over to logs, here you can see one's in progress right now, okay? And so that's what we're waiting. We're just going to see that finish there. We could probably open the logs and get some more information there. And so it just brings you back over to GitHub Actions. And so here's GitHub Actions, and it's performing the stuff here. So we're just going to give it time here, and I'll see you back in a moment. So we didn't have to wait too long. It only took 1 minute and 29 seconds. If we go back over here, we might need to do a refresh. And so we can see this is reflected over here. And so if we go back to, it doesn't really matter if we go to settings or logs here, but I'm going to hit browse and see if my page is deployed. It still is not. So we do have a small little problem here, and it's really going to just have to do with how the app is served. So that's what we need to figure out next. All right, so our app is not currently working, and there's a few approaches we can take. And the thing I can think right away is we should go and SSH into that instance. If you scroll on down here from Developer Tools, you can go to SSH and click this button, and that's going to SSH you right into that machine right away. You can also access SSH via the CLI command. So I believe it's like AZ web app SSH. It'll do the exact same thing. You do that from the Cloud Shell, but that's not what we're doing today. If I give this an ls in here and we're in Linux, we can see we have our app here. And what I would do is I would see what's running. So I would do a Puma, PS aux grep Python. And you can notice that we have GUnicorn that's running. So that is where our Python instances are running. So you're not looking for Flask, you're looking for Python here. And if we wanted to make sure that was working, we just type in curl localhost. And so that is going to return port 80. So that tells me that, because like curl just means like, let's go look at that page. It should return some HTML, like print out the HTML to us. So that means the app is not running. So what you could do is run flask run, and it's going to start on port 5000, right? So what I can do is I can go up back to my deployment center here, and I'm going to go get that link here, and just ignore the fact that it's working. It's not working right now. I know for certain it's not. But if we do 5000, that won't resolve because port 5000 isn't open. So we can't really just put 5000 in there, and the default server here would be 5000. So if I stop this and I specify port 80, right? Then this will start up the app on port 80. And so now when you go here, okay, it will work. This is not a great way because, of course, as soon as you kill it here, technically the site should stop running. And so you'll run into that step. So what we need to do is provide a configuration to GUnicorn, which is a Python thing. Again, it's not so important that you know how, like, what these things are, but the idea is that you understand as an administrator, you want to make sure you have an app that runs after you do a deploy. And so in this particular one, we need a startup.txt. And interestingly enough, there is a example code by the same author of the other one we were looking at here. I believe it's the same person, or it might not be, but they have a startup.txt, right? And so in here, you can see that it binds on port 000. It starts up 4 workers, starts up the app. All right. And so that's something that we can go ahead and do. So what I will do is I will go back to my GitHub repository that we have here. And I can just go ahead and add a new file. So I'm going to say add a file, create a new file here. We'll call it startup.txt. I'm going to copy this command here and paste it in there. So GUnicorn will bind the workers and startup on the app. Startup app is being ran by something here. So if I go back here, I think they have a startup pie here. And that's all that it is doing. I think I want to, I could do it this way, I suppose. Let me just see here. Theirs is just slightly different, eh? So they actually have like a full app going on here. And I just want a very simple Flask app. So I think what I can do is put Flask run here. Port 80. And that should start up the app there. I'm going to go ahead and commit that file. Okay. And as soon as I commit that, if I go back to my actions, it created that startup file there. So it should trigger a build. It's queued up. And I'll just put this tab up here. So we'll be back here in 2 seconds. And if I give this a nice refresh, yeah, you can see it deploys in progress. So this doesn't take too long. We'll just wait, close that there. We'll just wait a few minutes. If we click logs, it just opens it back up here, and we'll see how that goes. All right, so your deploy may have finished there, but the thing is that we're not going to really know if a change has taken effect unless we actually go ahead and update our code. So what I want you to do is go to your code tab, go to your app.py, we'll hit edit, and I'm going to go ahead and change this to Vulkan. And then we'll scroll on down, hit commit changes, and we'll make our way back over to our deployment center, and we'll give it a refresh here. And we're just going to wait until this one is complete, and we will double check to make sure that that is changed. If it is not, we will take action to fix that, okay? All right, so we just waited a little while there for that deploy to happen. And if we go to our website here, it is taking effect. So that's all we had to do to get it working. So that's pretty good. So that is deployment. So now let's talk about deployment slots. In order to utilize this feature, we're going to actually have to upgrade our account because we cannot utilize them at this the basic plan here. We got to go to standard or premium. So let's go ahead and give that an upgrade. So here's the B1. We're going to go to production here. And I think, yeah, we're going to have to choose this one here. Very expensive. So the thing is, we're going to just upgrade it temporarily, unless there's more options down below that are cheaper. Yeah, these are the standard tiers. Let's go with this one here because it's only $80. Again, we're not going to be doing this for long, but I want to show you how to do staging slots and auto scaling, okay? So we'll go ahead and apply that there. And now it says that it's applied. So if I go back to our app here and we click on deployment slots, sometimes it doesn't show up right away. If it doesn't, that's not a big deal. You just wait a bit, but today it's super fast. So we're going to go ahead and add a new slot. We're going to call it staging. We're going to deploy from our production branch here, and I'm going to go ahead and create that there. And we'll just wait until that's done, okay? Great, so we waited a little bit there, and our slot is created, so I'm going to just hit close there. And so now let's go take a look and see if we can actually see the application here. So I just clicked into it, I click browse, and we're getting the default page. So nothing is actually really deployed to it. So how are we going to do that? That's the main question here. So what I'm going to do is I'm going to make my way over to the deployment center. And you can see that it's not configured for this slot. So We are going to have to set it up all over again, even though it copied over configuration settings. It didn't copy over the code. So we go to GitHub. We'll choose our organization again. I'm going to choose the repository. We're going to choose that main branch again there. We're going to let it add a workflow. And notice that this time it's going to call it staging.yaml. So there'll be a separate workflow that gets created. We're going to go ahead and save that there. And what we can do is, again, click onto our branch name there. And if we click into our workflows, we'll now notice that we have a staging example. It's the same thing, but it should be able to now deploy. So the whole purpose of these deployment branches is that it helps us, we can deploy different versions of our apps, but it also, it's just a place where we can view things before we actually roll them out. So we want to make sure 100% that they are working correctly. I don't think this will automatically push out. Let me just go to my actions to see if this is deploying. Notice that we have two workflows now. We have staging here. And yeah, it looks like it's going to deploy here. So we'll just wait a little bit. But maybe what we can do is try to have a slightly different version for each one here, okay? But we'll just let that finish and I'll see you back in a moment. All right, so our deploy finished there. So now if we go back to our website here, we go browse, we should see that application. It says Hello Vulkan. And if we go and take out this, we still have Hello Vulkan. So how can we have a variant of this so that we can push out to that? So what I'm going to do is I'm going to go back to my application here. I'm going to go to code, and I'm just going to make a minor change. I don't say also, is that spelled right? Startup? Doesn't look correct to me. So maybe I'll go ahead and adjust that file, but it doesn't seem to be affecting anything, which is, I'm a bit surprised there. So what I'll do is I'm going to go and edit that file and give it the proper name. Can I rename this file? Yes, I can. So we'll call that startup file. I thought we needed that for deploying. I guess it just works without it, which is nice. If we go back here, I'm going to go and I actually just want to edit my app here again. And I'm going to go and edit this. And we'll say, hello, Andoria. Or hello, Andorians, maybe. And so if I go back to my actions, the question, what is it deploying? Is it going to deploy the production or the staging? And it looks like it's going to do both. Looks like it's doing both here. The one way we could tell is we can go to our logs here. And we can see that, so we did two deploys. So there's one change here. If we go back to our main application and our deployment center here, and we go over to our logs, you can see that they're both deploying. So it doesn't seem like it's a great thing that that's how it works. So the question is then how would we facilitate that deploy, right? How could we do that? I suppose what we could do is just make a separate staging branch. So if I go over to code here, I don't think we can just make branches through here. So what I'm going to have to do is go ahead and, I can create a branch right here. So we'll just type in staging and we'll go create ourselves a new branch. And now we are in this branch. And what I'm going to do is go ahead and modify this. And we're just going to call this Hello Klingons. Okay. We'll go ahead and update that. And so this should be a separate branch. So you think what we could do is go in and just change our settings so that it deploys from that one. We'll go back to our deployment slots. We'll click into staging here. And we need to change our configuration settings. I think we could just do it from here. Hold on here. I could have swore it specified the branch. If we go to deployment center here, I think it's set up on that other branch there. I think we just adjust it here. So yeah, I think we could just adjust these settings. We can't discard them, but maybe what we can do is just go in and modify that file. So we will go into our code here and we will go ahead and click into here, go into staging, and we'll just change what the branch is called. So we'll just say staging. And we'll hit start commit and we will save that. And we'll see if it actually reflects those changes there. So we will go here and hit refresh. We'll see if it picks up staging now if we go to settings. It's not picking it up. So I'm not sure. I don't think perform a redeploy operation. We don't want to redeploy. So maybe what we'll do is we'll have to do a disconnect here because it has the wrong one here. So save workflow file. Okay, we'll just go ahead and delete it. It's not a big deal. We'll just have to make a new one here. We'll go to GitHub. We'll choose our organization again, our repository, our staging branch this time around. We'll let it add one. See, it says we can use an available workflow. So we could have kept it there and added it there. And we'll go ahead and save that. So now we'll have two separate branches there. And we'll give that some time to deploy because that will now trigger a deploy off the bat. And so I'll see you back here in a moment. All right, so after a short little wait here, it looks like our app is done deploying. So we'll go over here. We'll make sure that this is our staging server. It is good. And we want to see that our production is different. Perfect. So we now have a way to deploy to each one. But imagine that we want to swap our traffic. So we're happy with our staging server and we want to roll that out to production. And that's where we can do some swapping. So what we'll do is click the swap button. And we're going to say the source is the staging. And this is our target production. And we're going to perform that swap. Right now, we can't do a preview because we don't have a particular setting set. That's okay. And it's kind of showing if there are any changes. So set of configuration changes, we don't have any. So that's totally fine as well. We'll go ahead and hit swap. And that's going to swap those two. I believe it's has 0 downtime. So we'll be in good shape if that happens there. And we'll just give it a moment to do that. Great, and so after a short little wait there, the swap is complete. And so if we remember clearly, this was our production, right? And so if I was to hit refresh, it's to now say Klingons. And if I go to my staging server, it should be the other way around, right? Good. So now imagine that I want to just split the traffic. That's something else that we can do. So notice over here, we have these percentages here. I'm not sure why it won't let me change those. So maybe I'll have to look into that. So I'll be back in two. So I'm not sure why it's not showing us that traffic slot there, but what I'm going to do is just maybe try to trigger a deploy back into our staging, and maybe that's what it wants to see. So what I'm going to do is go back to my code here. We would be in our staging branch here. I'm going to go ahead and edit this file here, and we will just change this to Bajorans. And we will hit update. And we will let that go ahead and deploy. So if we go to actions here, we can see that it is deploying. And we'll just give it some time, okay? So I'll see you back here in a bit. I mean, the other reason could be that we're just not at the main level. Hold on here. If we go back here to deployment slots. You know what? I think it's just because I was clicked into here and then I was clicked into deployment slots that they're both grayed out. Yeah, it is. So we can actually do it that top level there. Doesn't hurt to do another deploy though. So we'll just I'll wait for that deploy to finish, and then we'll come here and adjust that there, okay? All right, so let's take a look at doing some traffic switching here. So right now, if we were to go to our production, we have Klingons. And if we were to go to our staging, we have Bajorans. So imagine that we only want 50% of that traffic to show up. So what we can do is put in 50%. And what I'm going to do is, do I hit enter here or, oh, sorry, save up here. There we go. And so what's going to happen is this should take effect, I think, right away. Yep. And so now we have 50% chance of getting something else here. So I'm just going to keep on hitting enter here. If that doesn't work, we can try an incognito tab. And there we go, we got the opposite there. And so this is serving up staging, right? And this is serving up production, but they're both on the production URL. So that's a way you can split the traffic. So that's pretty much all I wanted to show you for deployment slots. Let's now talk about scaling. All right, so let's take a look into how we can do some scaling with our app service. This is only available if you have beyond standard or standard and beyond, so standard and premium and etc. So if we just search for scale, we have two options here. We have scale up and scale out. So scale up is pretty straightforward. That just means to make our instance larger. And so we already did that when we upgraded from our standard our B1 over to our S1 here, right? So if I was to go here, and I'm not going to do that, but if I was to do that and upgrade, that would be scaling up, right? And notice that we're talking about scaling. So right now we're limited to 10 instances, which is totally fine. But now let's take a look at scaling out. So if we go to scale out here and go to custom auto scale, what we can do is we can scale based on a metric. So we can add or remove servers based on the demand of the current web applications traffic. So we're only paying for servers when we need them. And so we have a minimum of 1, a maximum of 2. That seems fine to me. But we're going to add a rule here. And I want to scale this on the maximum time. We're going to do it on CPU percentage. I just want to have a very easy way to trigger this so we can see a scaling event in action. Here it has a maximum of 16%. I might just lower that down even further. Will it let me type in there? No. So 16% is what it's going to have to be. It's not a big deal. But I am going to reduce it down to, actually, I think, sorry, I don't know why I was going here. The metric threshold to scale an action, I'm going to put it at 10%. Sorry. Okay. So here's that line. And so we have and I like how you can drag it, but you can kind of have an idea that we have a high chance of having this triggered. I just want to do this so that we have a good chance. So if I was to put it here, you can notice that it's very easy for us to spike our traffic and cause a scaling event. Now I'm going to set the duration to 1 minute, so we have a much higher chance of triggering that there. Okay. Set a duration less than 5 minutes may generate transient spikes. Yeah, that's fair, but I mean, I just want to show you a trigger happen. And we need a cooldown time probably, and it's set to 5 minutes, so that's totally fine. We're going to add 1, and that looks fine to me. I'm going to set this to maximum. Okay, and so now we're very likely to trigger that there. We'll go ahead and hit add that instance there. And so now that we have that, we're going to go ahead and save that. And so now that that's there, what we want to do is actually trigger a scaling event. And so where we're going to see that is under the monitoring tab. So if we go to monitoring, and what we're going to do is go over to, it should be in, sorry, I forgot. The place where we need to go take a look here is actually in the run history here. So if we go here and check 1 hour, we can see how many instances are running. And I think if I dial it back here, it should show me over time as it changes. We do have a scale up event that has happened, which happened, I guess, 4 minutes ago. So I guess it gives you kind of an idea of how many instances are running, which right now are 2. So maybe our maybe our scaling event is not in the best use case there because it's happening too frequently. So what I'm going to do is go ahead and modify that scaling rule. And so I'm just going to go back and click here. And maybe we'll just make it so it is less aggressive. So what I'm going to do is just change it so it's over the duration of 5 minutes. And I'm going to just put it right above here so that it goes back to 1. Okay. And we'll go ahead and save that. And so now if we go back to our run history here, it still shows that it has 2, as you can see here, but I want to see this drop back down to 1. So it's going to check every 5 minutes or within the span of 5 minutes. So what I'm going to do is just wait here, and I'll see you back in a bit until we see a scaling action happens here, okay? Yeah, I'm just sitting here waiting for it to scale down, and I don't see it going. So it makes me think that I need to go ahead and set a scale down action. Let's take a look at the one that we currently have. So this one is set, oh, you can see it's still spiked. We don't even have anything going on here. But what I'm going to do is just be really aggressive here. And I'm going to say when it's 50%, okay? And so here, we'll go back here and I'll save that. And I just wanted to see if it scales down. I shouldn't have to set a scale down action, it should just go. And what I'm actually going to do is be a little bit more aggressive. I know I'm setting a lot of stuff here, but I'm going to just set it to duration of 1 minute so we can see this a lot sooner. And we will go back to our run history here and we'll see if we observe a scale down. All right, so it's not scaling down here, but I think it's probably because I need a scale out action. So what we'll do is go ahead and add a new rule. This thing, if we go here and we just look at it It's not going to decrease it unless we have a scale out action. So I don't think it's necessary for us to set one here. I think you get the idea. But that's for scaling. So we're all done here with Azure App Services. All we got to do is go ahead and delete it. So let's go ahead and delete our app here. Okay. So there's a few different ways we can do it. I'm going to do it via resource groups. I believe we called it Voyager here. So we'll click into that. And I'm going to go ahead and delete the resource group. And here is all the related services. And so I will type in Voyager. And there we go. Great. And so, yeah, there we go. Hey, this is Andrew Brown from ExamPro, and we are looking at what is infrastructure as code. And before we talk about that, we need to talk about the problem with manual configuration. So manually configuring your cloud infrastructure allows you to easily start using new cloud service offerings to quickly prototype architectures. However, it comes with a few downsides. So it's easy to misconfigure a service through human error. It's hard to manage the expected state of the configuration for compliance. It's hard to transfer configuration knowledge to other team members. And so this is why infrastructure code is going to really help us out. So infrastructure as code, commonly abbreviated to IAC, and you'll see that a lot in this course, allows you to write a configuration script to automate creating, updating, or destroying cloud infrastructure. Notice I gave great emphasis on automate or automation because that is really key to infrastructure as code. IAC can also be thought of as a blueprint of your infrastructure. IAC allows you to easily share, version, or inventory your cloud infrastructure. And just to kind of give you a visualization, imagine you write a script, and that's going to provision and launch a bunch of cloud services that are all interconnected, okay? Hey, this is Andrew Brown from ExamPro, and we'll be going over Azure Automation State Configuration. Azure Automation State Configuration lets you define and enforce the desired state of your Azure VMs, ensuring consistency across multiple machines. You can specify configuration details such as installed software, Windows features, registry settings, and file contents. So let's take a look at the example we have on the right. Configuration definition. Simple config, the configuration name targeting the node MYVM. File creation ensures a file named hello.txt with the content hello Azure exists in the C drive, ensure is equal to present. By applying this configuration, you ensure that any VM assigned to the MYVM node will have the hello.txt file with the specified content. This helps maintain a consistent and desired state across your Azure VMs. So that's a quick overview of Azure Automation State Configuration. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be covering Azure Resource Manager. Azure Resource Manager is a service that allows you to manage Azure resources. Azure Resource Manager is a collection of services in the Azure portal, so you can't simply type in Azure Resource Manager in the Search tab. It is a management layer that allows you to create, update, or delete resources, apply management features such as access controls, locks, or tags, and write infrastructure as code using JSON templates. We will be examining the following key components that form the Azure Resource Manager layer. We have subscriptions, management groups, resource providers, resource locks, Azure blueprints, as well as resource tags, access control, role-based access controls, Azure policies, and ARM templates. You can think of Azure Resource Manager as a gatekeeper. All of the requests flow through ARM, and it decides whether that request can be performed on a resource, such as the creation, updating, and deletion of a virtual machine, and it's ARM's responsibility to authenticate and authorize these requests. ARM uses Azure's role-based access control to determine whether a user has the necessary permissions to carry out a request. When a request is made, ARM checks the user's assigned roles and the permissions associated with those roles. If the user has the necessary permissions, the request is allowed, otherwise it is denied. The next concept we'll go over is the scope for Azure Resource Manager. We've briefly covered scope in Azure Policy and Azure RBAC, but we'll go into more detail with them in the following sections for ARM. So, scope is a boundary of control for Azure resources. It is a way to govern your resource by placing resources within a logical grouping and applying logical restrictions in the form of rules. Management groups are a logical grouping of multiple subscriptions. Subscriptions grant you access to Azure services based on a billing and support agreement. Resource groups are a logical grouping of multiple resources. And resources can be a specific Azure service such as Azure VMs. So that's an overview of Azure Resource Manager. Hey, this is Andrew Brown from ExamPro, and in this segment, we'll be diving into ARM templates. So what exactly is infrastructure as code? Infrastructure as code is the process of managing and provisioning computer data centers, such as those in Azure, using machine-readable definition files, like JSON files, rather than depending on physical hardware configuration or interactive configuration tools. You write a script that will set up cloud services for you. There are two main approaches to IAC. Declarative, here you describe your desired outcome, and the system figures out how to achieve it. Imperative, here you provide specific instructions detailing exactly how to reach the desired state. ARM templates are JSON files that define Azure resources you want to provision and Azure services you want to configure. With ARM templates, you can ensure a declarative approach, meaning you merely define your intended setup and the system handles the rest. Build, remove, or share entire architectures in minutes. Reduce configuration mistakes. And know exactly what you have defined for a stack to establish an architecture baseline for compliance. Moreover, ARM templates empower you to establish an architecture baseline for compliance, achieve modularity, break up your architecture in multiple files and reuse them, ensure extensibility, add PowerShell and Bash scripts to your templates, test using the ARM template toolkit, preview changes before you create infrastructure via template, see what it will create. Built-in validation will only deploy your template if it passes. Track deployments, keep track of changes to architecture over time. Policy as code, apply Azure policies to ensure you remain compliant. Use Microsoft blueprints which forge a connection between a resource and its template. Integrate with CI/CD pipelines. Utilize exportable code, letting you capture the current state of resource groups and individual resources. And benefit from advanced authoring tools. For instance, Visual Studio Code offers sophisticated features tailored for crafting ARM templates. So, as you can see, ARM templates has quite a lot of uses. Okay, so now what I want to do is cover infrastructure as code for Azure. So there are two primary ways of doing infrastructure as code. We have ARM templates. The ARM stands for Azure Resource Manager. And the other one is Azure Biceps. We're going to focus on the first one. Infrastructure as a code is the concept of defining all your infrastructure as code. And that might be confusing because that might sound like the SDK or the CLI. And it is confusing until you start working with it. But the key difference is that when you use the CLI or the SDK to programmatically create resources, they don't keep track of the state. And so that is the key difference between that. Whereas if you ran a CLI command to create, let's say, a virtual machine, and you ran it again with the same parameters and the same name, it would attempt to create a second virtual machine. Whereas with infrastructure as code, if it's already there, it's going to either update it or say, hey, you can't update it. There's already one that exists. So the idea is that it's different in that process or in that sense. There is a word for it. I believe the word is idempotent. I always have a hard time saying it, but that is the key difference between those programming methods and IAC. So what I want to show you is ARM templates. And ARM, again, stands for Azure Resource Manager. It's part of resource groups. So if we type in ARM here, we're not going to really get a service or anything like that. We say Azure or Azure Resource Manager. Okay, you're just not going to exactly get that because it is something that's there, but it really is talking about resource groups. So when you deploy a resource group, it will always create an ARM template for you. No matter if you do ClickOps, you'll always get an ARM template. And this is something that is very different from other providers. So like when you use AWS or GCP, when you launch a resource, it doesn't necessarily will produce a template for you, but Azure is very unique in that sense that they will do that. So what I want to do is I want to go ahead and explore some things with ARM templates so you're very aware of how they work. And I believe that there is a way to deploy. If we type in template here, there should be something like deploy a custom template. Whoops. And that's how you would go about deploying a custom template. And they actually already have some common templates here. So maybe we can take a look at one as a quick start and try to understand what these templates look like. Another key difference between other cloud service providers is that it's not very common to write ARM templates by hand. In fact, it's very tedious and you would not necessarily want to do it, as opposed to AWS where you have CloudFormation. It's totally normal to do. And that's why having a layer on top of ARM makes it so much easier, like using, again, Azure Bicep or Terraform. But let's go ahead and create a Linux virtual machine here. And notice that I select the template and it has some options here. So what I want to show you here, this looks like the usual process for setting up a virtual machine. But if we go here, we can edit the template, and then it's going to allow us to see what this template looks like. So ARM templates, this is what it looks like. And I believe that they're only JSON. I kind of forget. Let's go ask ChatGPT. So are ARM templates in Azure only JSON, or can they also be YAML? The reason why I don't remember is because I work with a lot of cloud service providers. Usually they'll provide both options. But generally, I always remember that ARM templates are only JSON. So there is no YAML support for it. But of course, you could use YAML locally and then convert it over back to JSON. But anyway, so if we look at this here, we have some things. We have the schema that describes what the format of this JSON should be. We have some metadata, which probably gets auto-generated or is additional information to attach to the template. We have parameters, so these are going to be values that we're inputting that allow us to make our template reusable. And if we scroll on down, yeah, we got variables, which is probably the modification of parameters. And then we have our resources down below here. And, you know, again, if you've seen CloudFormation templates or Deployment Manager, GCP deployment scripts, these are going to look very, very similar. So we define the type for the resource. We have a name for it. Then it has its properties. And then it can depend on other resources to say what order they're performed in. But anyway, my point is that this is a template. And we can go ahead and actually deploy this template, but I'm not that interested in that part of it because this is not that exciting. What's more exciting is what happens when you do ClickOps. So I'm going to go over here and deploy a virtual machine. Yeah, I mean, we could do a virtual machine. I'm just trying to think what's easier. Maybe we'll go ahead and actually do, I've changed my mind. We're going to actually go ahead and do storage accounts. Again, I'm still in the free tier, and I'm just trying to make things easy for you as well. And virtual machines will spin up a lot of resources, so maybe I don't want something that complicated for this example. But what I want to do is I want to launch a storage account, and then I want to see how we can look at the template, and maybe we'll attempt to re-import the template and then delete the storage account and recreate it. So I'll go here, and I'm going to hit create, and we're going to create ourselves a new resource group. I'm going to call this resource group my ARM RG, so ARM for Azure Resource Manager. And today it's really thinking. I don't know if I'm having internet issues here or if it's just really complaining or if Azure's slow. Azure's sometimes their UI is not always responsive. And we have to give this a name, of course. We have to make sure this is very unique. So I'm going to say my storage account, and a bunch of numbers, and then my initials. And it probably has too many letters, so it's complaining. There we go. And I'll just let it choose whatever region it wants. We'll have it on standard. That's totally fine. I'm going to go ahead and go to review, where we can see all of our options. Looks fine to me. We'll go down the bottom, hit create, and we'll give it a moment here to create. So I'll be back in just a second. All right, so that deployment is complete. And what I'm interested in is checking out the resource group. But notice that when we've deployed this, we have our inputs. It shows us what we've inputted. And we looked at the parameters of a template before. So it is creating literally an ARM template and then inputting the parameters. It's showing us the outputs of that ARM template. And then here's the template itself. So every time you deploy Azure resources, it is creating these IAC code for you. And that is one of the greatest advantages of Azure. As much as I complain about Azure, this is one of their really, really good features. And there's a few things you could do. Like, it looks like we can add this to our library. We can download this. We can deploy it again. Let's go ahead. I usually don't fiddle with these too much, but we can import this template. And I can say my resource group. But just remember, you could have a lot of resources and really make that retemplated. I'm going to choose the same area here. And This will just be version 1.0.0 down here. I'm going to go to next. It shows me the template. Next. We can do some tagging. I'm going to ignore that for now. Review and create. And so now we have our own template. So that's kind of cool. If we go back to here, I'm not exactly sure where they, we have to hit create maybe first. It's not super clear, but so that is now, template has been saved, but where did it save to? It just says it's a template spec. It is really taking its time to load here. Okay, and so we have our template here. I'm not sure if we typed in templates here, if they'd show up here. I guess they show up under template specs. We'll refresh this. Not sure why it doesn't show up. We know that we created it. And, you know, I've said this in other videos where Azure doesn't always propagate things right away and you have to wait. So you have to have confidence in waiting for things to show up in Azure. So even though it's not here, I know I created one. Okay, so we go over here. It says template spec succeeded. So it really, I think it would show up here. And I really want to prove that it will show up here eventually. So what I'm going to do is just take a break. And I'm going to give it like 10, 15 minutes. I'm going to give it a good chunk of time here. And we'll come back and see if it appears. Just to give you validation and confidence that patience always pays off here in Azure, okay? All right, so I've waited a good chunk of time. I was just talking to Bako. And so I'm back. And let's see if it is here. We're going to give it a refresh. And look, it's here. So I told you, you got to be really patient with Azure. It is really known for being slow for some particular resources. And when I say some, I mean a lot. So, you know, just have that patience there. But anyway, what I want to do is I'm going to open up another tab. We're going to go back over every time I open that new tab and wants me to log in. That's great. But what I want to do is go over to our resource groups and we're going to go into that new one that we created. And what I want to do is I just want to delete this resource here. And I want to see what happens if we attempt to redeploy our template there. I assume we're going to have to... I mean, we don't have to delete this one, but I just want to remove it completely and just try utilizing an ARM template. So we'll give it a moment there. And, oh, notice we have an upgrade button. This is definitely new. We might be going through our... I'm not sure why it's appearing all of a sudden. I've actually never seen that button before, so it's really interesting. And, nope, I guess it's just maybe after a while they just kind of poke you. And over here, we're getting our prompt. So... it looks like we're starting to get some spend. And, you know, I said earlier that Azure is really good about telling us about alerts and things like that, much better than other providers. And so, you know, here it's showing in Canadian dollars that we've already consumed half our spend. Not sure how I did that because I haven't really done a whole lot. But what we'll do is we'll try to figure out where that free spend has been going. Still, again, that's a lot. So maybe it's overestimating that, or I left something running. Maybe that Kubernetes cluster is still running. I don't think so. Let's go double check. But anyway, I wanted that to happen so I could go back and show a video of that kind of stuff. Because all we created is a couple of virtual machines and some other things. Yeah, we don't have anything else running that should be costing us spend, but we'll go take a look there and see what we can figure out. So anyway, I'm going to go back here, give this a refresh. And... that resource is gone. What's interesting is it also got rid of the template. Why did it get rid of the template? that was something we created separately. And so I guess it was linked to the resource group, and so that kind of defeats the purpose of us uploading our ARM template. So that's a shame. I guess what we could do is we could go and... I don't know. We could go and use the custom provider and launch a template, but there's not much interest in that, so I'm not really interested in doing that. Yeah, I think we're pretty much done here. I think we've proved the point that Azure is really good at producing these ARM templates. You're not going to want to write them by hand. You can ask ChatGPT to do it, but I would probably not do that myself. But I think that satisfies this video for ARM templates. So we'll see you in the next one, okay? All right, so we looked at utilizing ARM templates, and I think it'd also be really great to look at Azure Bicep because that is a more productive way to write infrastructure as code. And honestly, I really like Azure Bicep. I think it's really cool. So what I want to do is I want to go ahead and go over back to GitHub. We looked at creating a GitHub or creating a repo in GitHub back in our SDK video. that was a really messy video. I'm really hoping that it's not as crazy as that one, but I don't like editing out any of the challenges here because I want to give you the full idea of what it looks like when trying to work through these things. But what I'm going to do is go over to GitHub, and you should, of course, go ahead and create yourself a GitHub account. It has a free tier. And once you have your GitHub account, we'll make a new repo. I'm going to drop down here and go to ExamPro. And of course, you'll just have one name here if I have multiple accounts. So there's a lot for me to create stuff in. And what I'm going to do is make a new repo called Azure Bicep Example. You can call yours whatever you like. I'm going to make this public so that you can see the code. You can make yours private if private is available to you there. But I'm going to make it public because if you want to go find this repo at ExamPro Co. here and copy it and work with it, you can. So we're going to go ahead and use CodeSpaces, and CodeSpaces does have free credit usage. You could do this locally on your local computer, but you'd have to install a bunch of stuff. I like using cloud developer environments, and Azure does not have one built into their portal. Most other ones do, but I think the reason why Azure doesn't is because Microsoft owns GitHub, and so you could just go over here and use CodeSpaces instead. So this, to me, is like using Azure, okay? So we're going to go ahead and create a CodeSpaces on main here. And understand, as long as the CodeSpace is running, we are consuming. So if you want to stop it, you could always go up to the command palette here, and we can just say stop, or it's CodeSpaces. There should be something here called stop, shut down. I did this the other day when we did that. Yeah, it is CodeSpaces. Whoops, it's loading, so it's bumping things out here. But if we go CodeSpaces, there's an option to stop the current CodeSpace. So I'm not doing that right now. I want my theme to be dark, so I'm going to go to this cog down here, go to themes, go to color, and we'll switch to GitHub Dark. And we'll give it a moment to think because it's a bit slower loading. I greatly prefer Gitpod. The reason I'm using CodeSpaces is because the extensions are going to use the official ones with Microsoft, and it's just going to be easier to show you this here. In most other courses, I use Gitpod. So anyway, once that is loaded and we changed our theme, if that matters to you, we're going to want to do some Azure Bicep stuff. So on the left-hand side, I want you to go to extensions, and we're going to search Azure Bicep. I don't use Azure Bicep a lot, but I definitely know how to use it when we need to. So I know they have a really good extension for it, and it's like it writes code for you. It's the nicest experience I've ever had with an IAC tool. And this is the thing, because Microsoft built Visual Studio Code, and they own GitHub, they can have really amazing synergies for developers. So a lot of times I find it easier to work in VS Code and use their extensions to interact with Azure than it is to use Azure portal itself. And there are specific services like Azure Functions where you really have to use Visual Studio Code. So it's essential that you get used to using Visual Studio Code, whether it's local or in a cloud developer environment. So I'm installing this Azure Bicep extension, and this thing will help us write a lot of code. And it has like templates and other stuff like that. So that's what I want to take advantage of it. I don't remember the extension for Azure Bicep file, so we'll just go to the Azure Bicep website. I'm sure they'll have like a quick start, and we'll work through it here together. So I want to go here, and I just want to know what the extension is. It's .bicep, so that's what it is. So we're going to go here and make a new file. We're going to call it main.bicep. And something we didn't do before, and this is what I wanted to do in the SDK one, but we didn't actually have a use for it, is there's probably like an Azure kit, Azure tools. There we go. And this is something you might want to install. A lot of these down below here, see how there's like one for databases, resources, functions. If you install tools, it installs all these other ones. You even have one for CLI tools. And it's possible that, see, like this one will autocomplete Azure commands. It'll do all sorts of fun stuff. Even for Azure storage and everything, there's something. But the reason we want Azure tools is because we can install Azure accounts. And this will allow us to quickly log in to our Azure account. Remember before we typed in AZ login, and then we had to get a device code and plug that in? Well, if we have this installed, we can just use the command palette and log in very quickly. And that's what I want to do here. So I'm going to go to the bottom left corner. I'm going to pull up command palette, and we'll try to do Azure sign in. Now, to be fair, I mean, this is not going to do much difference down here, but I think it installed the CLI for us. Because before we had to manually install it, right? So we'll go here, and we're going to have to choose device code. We have to sign into Azure Cloud. Let's try this one first, see if that works. And then we're going to say, just so you know, Azure has different ones. There's like Azure China, Azure Germany, Azure US Government. So generally, we always want to choose Azure unless you live in one of these other regions, and you have to use that one. And this is going to open up, and we will sign in. We can now close this window. And I believe we are now logged into Azure. Also notice on the left-hand side, we have this little Azure icon here on the left-hand side. It will allow us to see our resources. We could also sign in from here. We should be signed in. Maybe it didn't work. I'll try this one more time. The extension Azure Resources wants to sign in. We'll say allow. Maybe it has to sign in separately. I don't know. We'll close this. There we are. So now we see our subscription. We are in here, which is great. And we can see a bunch of our services. So, you know, if we had storage accounts, and we do have some storage accounts, we can see them here. This one, I think, is for our Cloud Shell. That's why it starts with CS and it has a random number afterwards. If we had virtual machines and other things, we could see them here. But yeah, working with functions, you often use them here. We could also probably right-click this and create a resource. And so here, there's a lot of ways to create some stuff. We create a resource group and some other particular things. But yeah, that's interesting. I also wonder if like these are obviously things that were installed. There could be other extensions that we didn't install, like Azure Machine Learning Service or other stuff that could end up showing up there on the left-hand side. So I'm just kind of scrolling through here and seeing what might not be installed. So Azure Container Apps was not installed. Or maybe it was, and it's these other ones that have these little install words on here. But anyway, enough about that. Let's stay on track here, and let's write some Azure Biceps. So now that we have that installed, we want to start writing it. So I just need to see a little bit of code to get a reminder here. So yeah, if we start typing, it should start suggesting, and that's just what we want to do is make a storage account. So let's go ahead and start typing that in. So I'm going to type in resource. And so already notice that it is auto-completing. And then let's just go to check here. So the next thing is going to be storage account. And it should autocomplete. So yeah, I remember this being really good at autocompleting. Just give me 2 seconds and let's go figure that out. 1 second. Yeah, so I'm looking at it here and it's supposed to just start autocompleting when we type. So I'm not sure why it's not exactly doing that. We'll go back here. Sometimes Visual Studio Code doesn't do what we want it to do, which is totally fine. Storage account. And it's not really auto-completing. So I'm going to go ahead and save this for a second. Well, there it's auto-completing. So resource, storage. Am I typing it wrong? Is it supposed to be with resources? No, it's this. So it's really interesting that it's not auto-completing, but we could just copy this in here. Okay. I just wanted to show you how powerful it was because I was so impressed the first time I saw it writing all the code for me, which is not what the other ones do, that's for sure. So we'll just paste this in here. And I put a period here. Yeah, I guess I was expecting a little bit more from it, but whatever. I guess we'd have to work with it a bit more to find out. Again, I don't work with it every single day, but I am always very excited to use it. But, you know, the thing that I want to take a look at is let's look at where the actual reference documentation is. And so we'll go to resource reference here on the left-hand side. And I'm really interested to see where everything is. So if you know the resource type, you can just type it here in the left-hand side. That's fine. So we have all our resources here on the left. And so we are trying to create a storage account. So we can go over here and look for storage account. So that'd be storage and storage accounts. And so here it says to create a resource, add the following to your Azure Bicep. So just kind of getting familiar with it. It looks like this is going to be its logical name, and then this is actually going to define the resource itself, and these are all its properties. And it looks like there are some that are required and some that are not. So it looks like, I think, that if we can find this tab back, I think we can name this whatever we want here. This doesn't actually have to be called storage account. So we can go here. It's just a logical name that we reference within this resource. So I can go here and say like storage account AB, and it shouldn't matter. What's really interesting up here is that it's going to, looks like it's going to grab the resource group ID, and then what does it do here? It creates a deterministic hash based on the string. So it uses the resource ID to make a random string, and then it's going to say toy launch in the front of it. So I don't want toy launch. I'm just going to put in here bicep. And so I think we can do hyphens. Actually, I don't think we can. And so we should get an Azure storage account that's going to be bicep and some random value after this. And then up here, this is going to pull in the resource group. Now, what's interesting is we haven't created a resource group. It says return the current resource group scope. So I'm not sure how this is going to work if we don't have an existing resource group. But anyway, we've written our Azure bicep, and we probably want to go ahead and deploy this now. So we could probably just type in bicep down below. That's probably what the command is. Nope, that's not what it is. Maybe it's, what is it? I don't know. So let's go over to, back over here for a second, and let's see what the CLI commands are. Oh boy, we'll say bicep CLI. What is the commands? Just tell me what the commands are, please. We could use the command palette because they're probably all there. Like if we're to go into the command palette and type in bicep, like we get all those commands, but I really want to know what the CLI commands are. I really thought it would be bicep. It is AZ bicep, of course. So it looks like we can do AZ bicep and then just specify the template. Probably main is the default, so if we do nothing, it probably will pick that up. But I'm going to go ahead and type in that. And so it's interesting. We installed the extension and we were able to log in, but we still don't actually have the CLI. So it looks like we do actually have to install the Azure CLI in here, which is fine. It's always great to get more practice. So we'll go ahead and type in Azure CLI install. We'll go to the Microsoft Learn website. We will scroll to Linux. We'll go to Ubuntu Debian. Because that's generally what Gitpod or Codespaces or what have you will be using. We'll go down, look for that one-liner, and we'll copy it. We'll go back over to Codespaces. We'll paste this in, hit enter, and that'll go ahead and install the Azure CLI. Now, we are logged in this in Visual Studio Code, and it could be storing the same credential files wherever on the local machine. So maybe we don't have to necessarily log in twice. It might be also interesting to see where that that file is. So maybe we can go ask ChatGPT, okay, so when you log into the Azure CLI, where does it store the credentials? What folder and file on the Linux machine? That's what we want to know. And the only thing I don't like about ChatGPT is that you can't go away from this tab while it's generating. And then sometimes it just gets a bit slow, but it goes out to the internet. So I think that's the reason why it's been slower than previous. I like previous models where it wasn't out on the internet because it could generate out faster. But yeah, this one's hanging on me. So let's go to 3.5. Let's just ask this one. I want it fast. Okay, so it's saying it's in the Azure folder. So that's something that we might want to take a quick look at. The Azure CLI is installed. I'm going to just type in AZ account list and see if we can list our accounts. Okay, so we are not logged in. So us logging in here, wherever it's storing, it's definitely not storing in the same place. But let's go take a look at that Azure profile directory. So I'm going to bump up the font a bit. I realize it's really small. And I'm going to go ahead and say cd and then make a tilde. That is above your tab key, and you have to press shift to make it. It's called a tilde. It's like a little squiggly. We'll do a /. I'm going to do period for a hidden folder, and we're start typing Azure. And so that folder is there. We'll hit enter. I'm going to do ls to list out the contents, and we have stuff here. I can do ls-la to list it in a nice, beautiful list. And if we don't want, no, that looks fine. And so I'm kind of interested where it's storing that configuration, probably in the config directory. So I'm going to just cd into config. Oh, maybe it's not a folder. I thought that was a folder. It is not a folder. Okay, so let's do cat to print out the contents. Cat stands for concatenate, I think. And so that doesn't store it. Does the AZ JSON file have it? Nope, that doesn't have it. But to be fair, we haven't logged in yet, so maybe the file will appear after we log in. So that's okay. What I'm going to do is go ahead and type in AZ login, and we'll say use device code, because I believe that's the flag we have to use. And we'll go ahead and copy this link. We'll go to the top here and paste it in to one of our available tabs. We have to go back and provide this code. And we'll go click next, and we'll click on our account. We'll say continue. We'll go back over to here, and we'll give it a moment to think. There we go. We are logged in. So now what I want to do is type in ls, and it looks like there's more stuff there. It looks like there is. And did we have this before? Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, there's definitely more stuff here. The new thing that's here is clouds config, so I'm just going to cat that. Let's see what's in there. So it at least tells us this is our default subscription, so we at least know where that's coming from. Let's cat the config. Let's see if anything's changed in there. That's the same. Let's cat AZ JSON. There's still nothing in there. So it'd be really nice to know exactly where it is. Normally, other ones will tell you exactly where they are, and you can literally open them up and see the information there. I guess we could also just cat out the session. No, nothing. So anyway, it is stored somewhere. Where it is, I don't know. Does it really matter? No, but it's nice to know exactly where it is so that, let's say you wanted to delete it off your computer or something, but it's stored somewhere. Anyway, we should now be logged into Azure, so we'll go ahead and type in Azure AZ bicep. I still feel like it should have told us the commands even if we weren't logged in. And I was hoping that it would print us out the subcommands. Let's try to do help and see if it actually does that. Okay, so it does. You just have to give it the help flag. And so we have a few options. We can do build a bicep file, build the bicep param file, decompile. So if we already had an ARM template, we could turn it back into a bicep file. That sounds really cool. I like that idea. Format a bicep file. You know, if there's something wrong with it, it could tell us if the format's correct. Install the bicep CLI, which I thought it already was installed. Let's go ahead and try that first, because maybe that's why I couldn't just type in bicep. Okay, so now what happens if I type in bicep? No. So why did I install it if it was already like that? Bicep. I'm hitting tab to autocomplete to see if anything's there. Bicep CLI. Well, whatever. I mean, we kind of still already have it, so that's totally fine. So we'll go ahead and type in bicep AZ bicep build. And it wants a file, totally fine. So we're going to give it a file. Build the file, and print all of its outputs to SDOut. I don't think it matters if we print them out. So before we do that, I just did Control C to break that. We need to get back to our main folder. So I'm doing cd ... and I'm doing ls. Where is this folder? cd */ I'm so used to using Gitpod, I can't remember where this directory is. I'm just going to scroll up here and take a look. It is workspaces. Okay, so to get back to this folder, okay, we're going to go to cd / workspaces. I'm hitting tab to autocomplete. And then this one's called Azure Bicep. It is really not autocompleting here today. Oh, I spelled Azure wrong. Okay, that explains that. I'll go fix that in the Gitpod. I'll just rename it. But now we're back into here. So typing clear. So we're going to go Azure Bicep file, and we're going to provide it main TF, or I'm thinking Terraform bicep. We'll hit enter. And so that's going to go ahead and build it. Is misspelled or is not recognized by the system. Okay, we'll type in ls. I mean, it's right there. let's go back and take a look at the documentation and see what it wants. Sometimes it might want like the file information, but I don't think so. It just shows main bicep. I'll copy this command. Oh, I forgot the word build up here. That's why. So it looks like it's now built. And so we now have a main JSON. We'll take a look here. And it's generated us an ARM template. At least that's what it looks like. Yep, that's what it is. So that looks pretty good. I'm noticing that, yeah, we have parameters up here. So now we can go ahead and deploy this. So it builds it. See here, we can build param file. Not interested in that. Generate params. And install the commands to your CLI. Oh, publish. Maybe that's it. The publish command adds a module to the registry. The Azure container registry exists. I'm not sure if that's useful. I think that's if we want to reuse a template for later. Kind of like how we had those template specs, I think. Okay, so if Azure Bicep just generates out the files, I'd imagine that we just probably deploy it the regular way using ARM templates. So I'll be back in just a moment. Most other IAC tools, like they'll let you build and deploy, but maybe Azure Bicep just compiles out templates. Just give me a moment. Yeah, so I just quickly asked ChatGPT, and yes, it did confirm it. My suspicions were correct. Azure Bicep is just generating out the resource template, and it looks like we're going to have to deploy it the regular or old-fashioned way here. So now here's a question. Could we actually use Visual Studio Code to deploy this? So if I right-click this, could we deploy somewhere with this? So that's what I'm really curious about. Let me go find. All right, so I believe there's a few ways we can do this. Of course, we could go and just deploy it the old-fashioned way by using this AZ deployment group. I was looking around myself, and I just typed in bicep here. And I also noticed that they had a deploy step. So maybe it can do a direct deploy, maybe not through the CLI, but maybe it can do it through Visual Studio Code. There should be one for ARM templates in here. It's not showing up. I mean, ChatGPT seems to think that it can, but maybe there is another extension we're missing. So let's type in Azure. So we have Azure Tools. Is there one for developer? Let's go back here and take a look. So there's one here. It says Azure Resource Manager. Oh, it's an extension. Well, I thought that'd be installed already. Then that would be a really useful one to have here. So we'll say Azure Resource Manager. I thought it was there, but I didn't see it on the side. So this seems like a really good plugin. This is probably something I'd want to have. Let's go ahead and install this one. 1.5 million views. Yeah, I believe so. It's by Microsoft. I'm surprised it doesn't get installed with the tools. Oh, it's in preview. Okay. So I imagine when this is out of preview, I bet when you install Azure Tools, it will be installed there. Now, I've said previously, if there's a preview tool, you should try to avoid it because it might not be there in the future. This one, I think we can kind of get away with utilizing it. It might be the future and it's no longer in preview. So we'll go back over to here. And do we have any changes here? No, but if we go into our command palette, let's type in ARM deploy now. It was saying that that's something that we could do. Azure Resource Manager. Install this extension. Type in ARM deploy in our command palette. We did that. Yeah, so it doesn't show up. So, preview feature. ChatGPT might be telling us something else. We are using 3.5, so it might not be telling us the full truth there. And I don't really see any changes on here, so I guess we're not going to worry about that. But I would like to try the bicep deploy. So we'll type in just deploy here. And scroll on down. We have deploy bicep file. Let's see what happens if we do that. And so please enter the name of the deployment. Sure, we have to name the deployment. Good. create a resource group, because remember that we didn't specify a resource group, so we'll have to create one on the fly here. So let's do that. We'll call this my bicep RG, RG for resource group. It's now going to go ahead and deploy that. It says deploy failed. Provider's description does not have the resource type resource groups. Okay. That is something I was not expecting. Let's go ask ChatGPT and try to save us some time. So it says check your bicep template file, ensure that you have defined the resources correctly. That is not useful. Maybe it's because it's not registered. So maybe when we use the UI, it will automatically register things when we use it, but we create resource groups all the time, so it's kind of surprising if that wouldn't be registered. So we'll go over to our subscription, and I'm just going to double check this here, but I'm not sure if it's going to make a difference. We'll go over to our, we're in our subscription. I'm looking for providers. There it is, resource providers. Sometimes there's like another extra blade. They call these blades over here, by the way. And so I was getting a bit confused. And so ChatGPT is suggesting maybe resources is not registered, which to me seems crazy. Oh, it is. It's right there. So I'm not exactly sure what it's complaining about. The other thing is that maybe Azure Bicep isn't logged in. So, I mean, that seems like a possible option. So maybe we'll just go stick with the usual way, which is using the Azure, this Azure deploy method. So I'm going to scroll back up here, and we have this command. Now, we did install in here in extensions, or I think it came installed, was the Azure CLI. And what that will do is when we write out Azure CLI commands, I believe it will autocomplete for us. So here's scrapbooks for developing and running commands with Azure CLI. Create an Azure CLI files and use the following features. Oh, okay, so there's actually a thing called an Azure CLI file. That's new to me. But what we'll do is we'll go ahead and we'll just say new file. So we'll just say commands, and I'll just put that there. Rename that like that. That's what it's saying to do. And so we'll say deploy an ARM template, and we'll go back over here, and we'll see if it starts to autocomplete. So we have AZ deploy. It's not really completing correctly. It's just demonstrated. We'll go back over here and take a look at that again. So yeah, this one says demo.azcli. They're making a comment. So IntelliSense for commands and their arguments, snippets and commands. Scrapbooks for developing and running commands in the Azure CLI. Okay, then work properly, please. Maybe it's not installed. Oh, we have to install it. Sorry. I thought we already had it installed. That's why. So we'll go back over here. And so now our comment is showing up. So we'll type AZ deployment. I mean, we probably want to create, right? It will have to have a name. So we'll just say my RG, my bicep deployment. We'll probably have to have a location. So let's just say, probably should place it in the same place as this one. This does not have a particular location, so probably default to wherever the resource group is. Yep. So let's say it's East US. There we go. There's probably something else we need. I'm not really sure. Let's go back and see what ChatGPT was asking for. The template, of course. We'll say template, and it technically is a file. So we'll go here and say main JSON. And by the way, we could bring these down onto new lines with this backslash. That allows us to have multiple lines in our bash terminal. Okay. And it also probably wants the resource group. So we'll go here and type in resource. It can't do multi-line. It is not auto-completing anymore. Resource group. Maybe we just hit the limit of it there. So I assume that it could handle multi-line, but I guess when we're doing multi-line, then the IntelliSense, the auto-completion, it can't handle it. So we'll go back over to here, and I just forgot what we called that resource group. We actually did create one, but Azure Bicep did fail the deploy because of some kind of permissions or settings. So I just want to go quickly find that name. Again, notice that sometimes in Azure, you have to be patient. Super, super, super common to wait around for Azure because of propagations in their UI. Super common. My internet's totally fine. It's Azure. And it's back here. It says, an error occurred when trying to fetch resources. Additional details from the underlying API might be helpful. Are we having an issue with service? So sometimes that happens. So we could be like Microsoft status page. Sometimes that happens and I got to walk away, come back to my computer. But maybe it's not because my internet seems to be funny. So, but if that's the case, then, oh yeah, it's me. I'll be back in a moment. Okay. All right, so my internet should be back here. I'm just reopening my connection here to my code spaces. And I'm gonna go back over to here and we'll give it a refresh. And so I guess that resource group did not create. So we do definitely have to create a resource group first. Otherwise, it's not gonna know what to deploy into. And I'm hoping that this reconnects or it's still running. So, but what I'll do here while we're waiting is I'm going to create a new resource group. I'm going to call this one my bicep RG. And we'll go ahead and review and create. And we'll go ahead and create that. We'll go back over to our other tab here. I would really like it to reopen here. I'm not sure what it's doing to figure this out. I'm going to go at the top and just type in github.dev. That's the primary site for these developer environments. So I'm hoping that it'll list the other ones. That's what Gitpod normally does. It seems real mucked up here. So I'm gonna have to go back and we'll just have to type in bicep here. It's under ExamPro, so I'll drop that down. Of course, you'll only have one. So we'll go into here and let's see if I can find that, that previously working code space environment. So it's here, it is active. I'm gonna go back and say open in the browser. Notice you can launch this in Visual Studio Code locally, or if you want to use Jupyter Labs, let's say you're doing something with AI or something, or machine learning, you could do that. So this should open back up our environment. There we go, that's great. And so we created that new resource group that's called this here. So I'm gonna go ahead and copy that. And I'm gonna paste it into here. Sometimes it's good to put double quotations around these things. I'm not doing that unless that gives us problems. So I think this is everything we need. We need to know the resource group. It's probably recommended to provide it a name. We'll have our location and our template file. So I'm gonna go ahead and copy this and fingers crossed this works. Of course, we didn't really look anything up. Oh, this one says AZ deployment group create. So maybe we should make sure that's correct. But it did autocomplete create, so maybe that's okay. Well, wait, why is one deployment group? Wouldn't that create, hold on, we can hover over here and get some stuff. Manage the Azure resource template deployment at the resource group. Okay. Oh, that's really cool. If you hover over, it tells you everything there. Well, what happens if I take this name out then? Does this still complete? Starts a deployment at the subscription scope. So maybe both works. Let's just see what happens. It's really nice that it shows everything like that. I really like that. We'll go ahead and paste that in. We'll hit enter. And it's showing we're missing an argument. Resource group arguments. It doesn't like that one. Starts a deployment, creates a deployment, the resource group. Okay, so here we have a create, and then we have starts a deployment, the subscription scope, creates a deployment at the resource group from a local file template. So it looks like if we already have one, maybe this one would have created a resource group for us. So what I'm gonna do is take this one out, because I really thought we needed to have it, but I'm gonna go and see what happens if we do this. The template resource location at line 12, line 17 is invalid. The template function resource group is not expected at this location. Okay, it's not there. I didn't
put it in the template. So, okay. Well, what I'm going to do is undo and type in group. So I guess you got to be really careful when entering stuff in because it's going to give you some trouble. And this one looks a little bit more normal with the group create. So we have template file, resource group. I don't know if it needs a name. So maybe I'll just take the name out and then we'll try this one. And we'll hit enter. And unrecognized arguments, no location. Well, I mean, this one has it and this one doesn't. Okay, we'll take the location out. We'll try this. Well, I guess we don't have to specify a location because we've already created the resource group. That's why. So we'll try this again. Making a lot of trouble here. But it's a good way to learn. This is how you should learn, and this is what cloud's like, just goofing around till we get it to work, and then hopefully it's the right way. So this is going to go ahead and run, and we'll wait here. I'm not going to make you watch it here. I'll be back here in a moment, okay? All right, after a little bit of waiting, our terminal has produced some stuff for us, so it's suggesting it probably created the resource, so we're in good shape. Let's go back over to Azure, and we're going to go into our bicep RG, and we now have our resource. So we've successfully used Azure Bicep. So let's go ahead and delete this resource group. We are all done here. We're going to go ahead and commit what we have so that any future folks that are trying to do the same thing as us can just go get that code base. Good stuff here. We'll go ahead and hit commit, sync the changes. We'll say OK. That will push the changes. Excellent. And I'm going to want to stop this workspace. So we'll open up the command palette. We'll say stop. So say code spaces stop, code spaces stop current workspace. There we go. And that will stop the current workspace. So that is all good right there. And I'm going to fix the name here because it really should be named correctly so that you can easily find it in the future. Just be more patient and make sure you don't make mistakes and try to fix them the best you can. But yeah, that is Azure Bicep, and we'll see you in the next one. Okay?
Hey, this is Andrew Brown from ExamPro. In this segment, we'll delve deep into Azure Key Vault, a pivotal tool to ensure the security of your cloud applications and services. Azure Key Vault helps you safeguard cryptographic keys and other secrets used by cloud apps and services. Azure Key Vault focuses on three things. Certificate management. This feature allows for easy provision, management, and deployment of both public and private SSL certificates. These certificates can be used with Azure and internally connected resources. Key management. This enables the creation and control of encryption keys used to encrypt your data. Secrets management. Here, you have a secure space to store and tightly control access to tokens, passwords, certificates, API keys, and other secrets. Note that certificates contain a key pair, which is a combination of a key and a secret. This should not be confused with key management and secrets management, which are distinct functionalities. Moving forward, let's talk about HSMs, or hardware security modules. These are dedicated hardware devices specifically designed to securely store encryption keys. When it comes to adhering to standards, we reference the Federal Information Processing Standard, or FIPS. This is a guideline recognized by the US and Canadian governments that specifies the security requirements for cryptographic modules that protect sensitive information. In line with FIPS, we have two levels of compliance for HSMs. FIPS 140-2 Level 2 compliant. This compliance level is for multi-tenant HSMs where multiple customers are virtually isolated on a single HSM. FIPS 140-2 Level 3 compliant. This level, on the other hand, pertains to single-tenant HSMs where one customer utilizes a dedicated HSM. In essence, Azure Key Vault is an indispensable tool for ensuring that your cloud data remains both accessible and secure. Whether you're working with certificates, encryption keys, or various secrets, Azure Key Vault has you covered. All right, let's dive into the core of Azure Key Vault, the vault itself. A vault is where your secrets and keys reside, safeguarded either by software or by HSMs validated to the standards of FIPS 140-2 Level 2. Azure Key Vaults provides two types of containers. Vaults. These containers support both software and HSM-backed keys. HSM pools. These are specialized containers solely for HSM-backed keys. To activate your HSM, you will need to provide a minimum of 3 RSA key pairs up to a maximum of 10. and specify the minimum number of keys required to decrypt the security domain, called a quorum. You do not choose the container on creation, you just choose between standard and premium. When you choose premium and create enough RSA key pairs, you will begin to use HSM pools. Diving a bit into technicalities, Azure Key Vault REST API is used for programmatically managing Azure Key Vault resources, allowing you to perform operations such as create a key or secret, import a key or secret, revoke a key or secret, delete a key or secret, authorize user or apps to access its keys or secrets, and monitor and manage key usage. Azure Key Vault REST API supports 3 different types of authentication: managed identities, and identity managed by Azure AD, recommended as best practice. Service principal and certificate. This method uses a certificate for authentication. Service principal and secret, a combination of a user identity and a secret key. One feature to note is the soft delete functionality. Soft delete allows you to recover or permanently delete a key vault and secrets for the duration of the retention period. This feature is enabled by default on creation. Mandatory retention period prevents the permanent deletion of key vaults or secrets prior to the retention period elapsing. Furthermore, enabling purge protection safeguards your secrets from being prematurely purged, either by users or by Microsoft, bolstering the security of your vault. Next up on our agenda is breaking down the pricing of Azure Key Vault. Knowing how you're billed for this service can help you make informed decisions and optimize your costs. Azure Key Vault offers 2 pricing tiers, standard and premium. The notable distinction between the two is that while both tiers support software-protected keys, only the premium tier allows for HSM-protected keys. Here's a closer look at the pricing tiers. First 250 keys, regardless of whether you're on the standard or premium tier, you'll be billed $5 per key every month. 251-1500 keys, the price drops to $2.50 per key monthly, again consistent across both tiers. 1501 to 4000 keys, the cost further reduces to 90 cents for each key every month. 4001 plus keys, for larger key volumes beyond this point, you'll be charged at a rate of 40 cents per key per month. Secrets operations, both tiers are priced at 3 cents for every 10,000 transactions involving secrets. Certificate operations, exclusive to the premium tier, each certificate renewal request is billed at $3. Managed Azure Storage Account Key Rotation, this service, only available in the premium tier, is priced at $1 per renewal. HSM Protected Keys, specifically for HSM Protected Keys, the pricing is further broken down based on the key types. For RSA 2048-bit keys, the cost is $1 per key per month, along with an additional charge of 3 cents per 10,000 transactions. For RSA 3072-bit and 4096-bit keys, as well as ECC keys, the first 250 keys are priced at $5 per key per month. So that's an overview of the pricing model for Azure Key Vault. The next topic we'll be covering is double encryption for Azure Key Vault. Before we dive in, let's quickly recap infrastructure encryption for storage accounts. By default, Azure ensures that your storage account data is encrypted when it's at rest. Infrastructure encryption adds a second layer of encryption to your storage account's data. Now, let's jump into Azure Disk's double encryption. Double encryption is precisely what it sounds like. It's where 2 or more independent layers of encryption are enabled to protect against compromises of any one layer of encryption. This strategy ensures that even if one encryption layer is compromised, the data remains protected by the other. Microsoft has a 2-layered approach, both for data at rest and data in transit. For data at rest disk encryption, this is achieved using customer-managed keys. And infrastructure encryption, this uses platform-managed keys, strengthening the base layer. And for data in transit encryption using transport layer security 1.2 to safeguard data as it travels through networks. And an additional layer of encryption provided at the infrastructure layer. So that's a quick overview of double encryption for Azure Key Vault. In this section, we'll go into detail on the keys in Azure Key Vault. When it comes to creating a key in Azure, you have 3 primary choices. Generate, Azure will generate the key for you. Import an existing RSA key that you already possess. And restore backup, restore a key from backup. For keys generated by Azure, you can use either RSA or EC. RSA or Rivest, Shamir, Adelman, this supports key sizes of 2048, 3072, and 4096 bits. EC or elliptic curve cryptography, here you can select from P256, P384, P521, or P256K. For keys generated by Azure, you can set an activation and expiration date. Additionally, you're not bound to a static version of a key. You can create new versions of keys. You can also download backups of keys, but remember that backups can only be restored within the same Azure subscription and within Azure Key Vault. When you have a premium vault, you'll key options for HSM. You can generate either an RSA or EC specifically for HSM, or import an RSA key for HSM as shown in the example. Now, let's talk about key management types. Microsoft Managed Key are keys managed by Microsoft. They do not appear in your vault, and in most cases are used by default for many Azure services. Customer Managed Key are keys you create in Azure Key Vault. You need to select a key from a vault for various services. Sometimes customer managed means that the customer has imported cryptographic material, and any generated or imported keys are considered CMK in Azure. In order to use a key, an Azure service needs an identity established within Azure AD for permission to access the key from the vault. Additionally, you have the option to implement infrastructure encryption. While Azure already encrypts storage account data at rest by default, opting for infrastructure encryption adds a second layer of security, fortifying your storage account's data even further. The next topic we'll be covering are secrets in Azure Key Vault. Azure Key Vault Secrets provides secure storage of generic secrets, such as passwords and database connection strings. Key Vault APIs accept and return secret values as strings. Internally, Key Vault stores and manages secrets as sequences of octets, with each secret having a maximum size of 25K bytes. The Key Vault service doesn't provide semantics for secrets. It accepts the data, encrypts it, stores it, and returns a secret identifier. For highly sensitive data, clients should consider additional layers of protection for data. For example, encrypting your data using a separate protection key before storing it in the Key Vault. Key Vault also supports a content type field for secrets, allowing clients to specify the content type of a secret to assist in interpreting the secret data when it's retrieved. Note that the maximum length of this field is 255 characters. Every secret stored in your Key Vault is encrypted. Key Vault encrypts secrets at rest with a hierarchy of encryption keys. All keys in that hierarchy are protected by modules that are FIPS 140-2 compliant. The encryption leaf key is unique to each Key Vault, while the root key is unique to the entire security world. The protection level may vary between regions. For example, China uses FIPS 140-2 level 1, and all other regions use level 2 or higher. Diving into secret attributes, we have EXP. This is the expiration time after which the secret data should not be retrieved. NBF, not before, default value is now. This defines the time before which the secret data should not be retrieved. Enable, this tells us whether the secret data can be retrieved or not, with its default set to true. Additionally, there are read-only attributes for created and update. In order to access secrets within your application code, you would use the Azure SDK for example. We have a .NET example in this image here. Another option is to use tools like Azure CLI. So that about covers the important details of secrets in Azure Key Vault.
Hey, this is Andrew Brown from ExamPro, and in this fall long, we're going to be learning all about Azure Vault. So let's get to it. So what I want you to do is go in the top here and type in Key Vault, and here we'll have to go ahead and create ourselves a new vault. And so from there, we're going to create a new resource group. I'm going to call this resource group My Example Vault, and then we will make a vault key here. So I'll just say My Vault Example, which is kind of funny because this one's slightly different. So you've seen I've done this before, so I'm going to do My Example Vault as the name here. And for the region, US East is fine. For pricing, we'll keep it at standard. Soft delete is enabled. And then there's the option for purge protection. So we are going to enable purge protection. And this is going to play into other follow-alongs. We'll explain that as it goes. But purge protection does not allow you to purge things easily once it's enabled. So what we'll do is go ahead and review and create. And we'll go ahead and go review create. And we'll give it a moment here. And we'll just wait till it's done deploying, okay? All right, so after a short little wait, our vault is created. And so what I want you to do is go to the resource, and we're going to be using this vault a little bit in some of the follow-alongs, and in some cases, not so much, okay?
this is Andrew Brown, and this fall long we're going to be doing some things with keys with an Azure Key Vault. So what I want you to do is make your way over to the keys blade on the left-hand side here. We're going to generate or /import a new key. We're going to choose the generate option. In terms of naming, we're going to call this my disk key. And we are going to choose RSA 2048. That seems totally fine to me. Everything else seems okay, so we'll go ahead and create that key. So we'll give it a moment to create, doesn't take too long. And then what we're going to do is go on the left-hand side to IAM access controls. And what we're going to want to do is add a new role assignment so we can go ahead and start using this key. So what I want you to do is go and look for Key Vault Administrator, which is here. And we'll go ahead and hit next. And then for our user, we will choose ourselves. So under user, I'm going to select the members. I'm looking for the account I'm using. There I am, Andrew Brown. Go ahead and select that there. And so that is all we need to assign it so that we can actually work with that key. So I think a good idea is to use a key to encrypt a disk. So what we'll do is make our way over to disk encryption sets, because before you can encrypt a disk, you need to have an encryption set. So we'll go ahead and create ourselves a new encryption set. We'll use the same resource group, so it's very easy cleanup afterwards. We'll call this my disk encrypt set here. And in terms of the encryption type, we're going to use double encryption because that's much better. You have two keys that encrypt it, so that's a lot better. We are going to choose our vault. So we have my example vault. There's only one option here. And in terms of the key, we'll select my disk key. In terms of the version, we'll select the current version. We'll go ahead and hit review create. And then we will go and create that. And we'll give it a moment to create that encryption set. Shouldn't take too long here. And after a short little wait, our resource should be deployed. It only took about a minute for me. And if we go here, it's going to have this message up here. It's very small, but it says to associate disk image snapshot this disk encryption set, you must grant permissions to Key Vault. So all we have to do is click that alert, and we'll grant permissions. And so now we are able to use that key, we're going to have the permissions issues is solved. So what we'll do is go to type and create a new disk. And so we can apply this key to that encryption. So we'll go ahead and create. We're going to choose the same resource group here. I'm going to call this my example vault and, my example disk, because that's a little bit more clear than that. And for the availability zone, doesn't matter. For the source type, it doesn't matter as well. In terms of the size, we want this to be cheap. We're not really using this for real, so we'll use standard HDD, and we'll say OK. In terms of encryption, this is where things get fun. We go to double encryption. We choose our key here. We'll go ahead, review, and create. And we'll just give it a moment for that to, we'll hit create, and we'll have to wait a little while here for the create that resource. So we'll just wait until that is created, okay? And after a very short while, the disk is ready. So we'll go to that resource. We'll go to the encryption tab to see that encryption is applied. So that's all it takes to use a key to encrypt a disk. So we are going to still use some of these accounts. There's no cleanup yet. I'll go back here and I'll see you in the next one. Hey, this is Andrew Brown, and in this follow along, we're going to learn about backup and restore keys. So what I want you to do is go back into the resource group that we just recently created, and we're going to make our way over to keys. So we got to get into the vault first. Then we'll go over to keys, and the idea is that we have this key here, and so you can see that we have this current version, so you can add additional versions. But what's going to happen if we try to back this up? So when you back this up, you're going to get this file here. And if you open up this file, it's going to look like a bunch of gobbledygook. So I'm just going to try to open it here. I have it up off screen here. So I'm just trying to open it up within Visual Studio Code. So I'm just going to open up Visual Studio Code. Again, doing this off screen here. Just give me a moment. All right. And so this is the file that we encrypted. And you take a look here, and it doesn't look like anything, but the idea is that it is our backup of our key so that we can re-import that. And just taking a look at the key name, this is what it looks like. So this is my example vault, my disk key. Then there's this date, and that's key backup. So just recognize that's the format, and the date is very useful to indicate when you backed it up. So let's go ahead and delete this key, because the idea is we want to restore that backup. And so we have deleted that key there. And what we're going to do is we're going to attempt a restore. So I'm going to go ahead and go occurred while restoring the key. The key you're trying to restore already exists. Why would it throw that error? We've clearly deleted it. And the reason why is that we have purge protection on. We did that in the first part when we set up this actual vault here. I'm going to just see if we can find the settings wherever that purge protection is. I'm trying to remember where it is. Purge protection is enabled, so we can go here. And once you enable it, you cannot turn it off. It's going to retain it for a certain amount of days. And so all you can do is soft delete keys. So this key is not actually deleted yet. If you go to manage deleted keys, you can see the key is over here. And if you try to click on purge, it is disabled because we cannot remove the key because we have purge protection on. But we can recover the key, so we'll go ahead and recover. And so that will allow us to recover the key. And if we refresh here, it's going to take a little bit of time for that key to restore. So we'll just have to wait a little bit, and then it will show up. There's one other thing I wanted to show you was under policies, because, you know, if you go under, where's policies here, or access policies, if you look under our user here and we look at the key permissions, there is an option to purge, and we don't actually have that turned on right now. But if we were to save this and we were to still go to that purge option, it would still say the same thing. So even if you have purge permissions, it does not matter if purge protection is turned on. It still will not let you purge, but you would need a combination of those in order to be able to do things there. So to really show you how to do that recovery, I think what we should do, I'm just going to delete our old key here because we don't care about it. But we are going to, well, I guess we could try to import it into the other ones. I'm just going to undo that for a second. But we are going to go ahead and create ourselves another vault. So I'm going to go and type in vault at the top here. And we're going to be a little bit more careful when we create this vault. So we'll go here and we will choose my example vault. I'm going to say my vault no protect. And the pricing tier will be standard. 1 day, we're going to leave it, or well, 7 is the lowest, and we'll say disable purge protection because we don't want to have that enabled. And we'll see if we can import the key into another vault. I'm not sure if we can do that. Worst case, we'll make a new key, download the key, re-upload it. But I'm just curious what would happen if we tried to upload the same key as it's still in another vault. I'm not exactly sure. All right, so this deployment is successful. I'm going to go to this resource. I'm going to go ahead to go to create, and we're going to restore from backup. And we're going to take this key and see if we can actually import it here. So it looks like we can take a key and it can exist in multiple vaults. I'm going to go ahead and delete this key. And we're going to say, are you sure you want to delete this key? I'm going to say yes. And if we go to manage keys, and we refresh, it takes a little bit of time here. So we'll just wait a moment for this to persist. And after a short little wait, like about 2 minutes, I refresh and the key is here. So if I go here, you'll notice the purge option is still not available. We can obviously recover, but we don't have purge protection on. So if we go to access policies over here and we'll go ahead and scroll down and select purge and save our changes, we can then go back to keys. We'll give it a moment to save. We go back to keys, we'll refresh it, we'll manage our keys, and we'll go ahead and purge it, and that will permanently purge it there. So that's all it takes to do that. So there you go.
Hey, it's Andrew Brown, and we are talking about encrypted secrets. So encrypted secrets are variables that allow you to pass sensitive information to your GitHub Action workflows. Secrets are accessed via the secrets context. So that's secrets dot, and then whatever you want your secret is. And it has a few different levels. We have the organizational level, the repo level, and the environment level. What you need to understand is that the lower the level, the more it overrides the ones from the top level. So if you have a secret called hello at the organization level and one at the environment level called hello, the one at the environment level value will overtake. Secret names can only contain alphanumeric characters, underscores, no spaces. So that example there would be the case. You can't prefix it with GitHub in all caps with an underscore. Names must start with numbers. Sorry, I felt like a rumble in my office, and that's why I paused. I think there was just a big train that went by. Anyway, sorry about that. There we go. Names are case insensitive. Names must be unique at the level they are created at. People don't know I live right beside a train station, and my office is in a shed behind my house. And the idea is that I have multiple layers to avoid from the train, but sometimes there's nothing you can do about it. But anyway, so we have passing secrets as inputs. So you can pass secrets as inputs by using secrets context. So that is an example there. But I mean, like, the point is that, you know, you could interpolate whatever you want there to pass it into a custom action. And we'll talk about custom actions in another video. You can pass secrets as envars. So that is another way that you could do that. And why would you do inputs versus envars? It just really depends on your use case. So maybe you have something that is a program you're using and it can only use envars. Whereas with secrets, it's okay to do that on the left-hand side because of the way it works. But I just want to point out here, we did this in another video, but if you want to make that an envar, you'd have to map it like that. I think we did that for something earlier, but hopefully you know what that is. So about how you set a secret. So you can use the GitHub CLI. So we have a GH secret set, which is probably how we're going to do it. Then we have GH secret set for a specific environment or at the org level. So depending on how you do a flag, it's going to be different. The default apparently is repository. And you can also specify the repo, which we have here. You could do that up here as well if you want to. But there you go. Hey, this is Andrew Brown. We are taking a look at the GitHub token secret. So at the start of each workflow job, GitHub automatically creates a unique GitHub token secret to use in your workflow. You can use the GitHub token to authenticate in the workflow job. Sounds a bit repetitive there, but let's take a look here and see what we're talking about. So I'm gonna get my pen tool out so it's very clear. And what I want you to see is that we can say secrets.GitHub token and we can get that GitHub token. I also believe that we can do $ GitHub token for environment variables and it will show up as well. If not, we can just map it over as we are doing here. If you notice here, we're doing that. When you enable GitHub Actions, GitHub installs a GitHub app on your repository. The GitHub token secret is a GitHub app installation access token. So hopefully that is clear. You can also use it with the REST API. So here's another example. And notice we are calling secrets GitHub token with this way of interpolating that. So there you go.
Hey, this is Andrew Brown from ExamPro, and in this section, we'll be covering Azure Monitor. So Azure Monitor is a comprehensive solution for collecting, analyzing, and acting on telemetry from your cloud and on-premises environments. It serves as the backbone for gaining insight into the performance and health of your applications, infrastructure, and even the network. Key features: visual dashboards, a visual representation of your data, smart alerts, intelligent notifications based on specific conditions, automated actions, set automation based on certain triggers, log monitoring, track and analyze event logs. Many Azure services, by default, are already sending telemetry data to Azure Monitor. What is observability? It's the ability to measure and understand how internal systems work in order to answer questions regarding performance, tolerance, security, and faults with a system or application. To obtain observability, you need to use metrics, logs, and traces. You have to use them together. Using them in isolation does not gain you observability. Metrics, a number that is measured over a period of time. For example, if we measured the CPU usage and aggregated it over a period of time, we could have an average CPU metric. Logs, a text file where each line contains event data about what happened at a certain time. Traces, a history of requests that travels through multiple apps or services so we can pinpoint performance or failure. Looks like they should have called it the Triforce of observability. The sources of common monitoring data to populate data stores, order by highest to lowest. Application, operating system, Azure resources, Azure subscription, Azure tenant, custom sources. The two fundamental data stores are metrics and logs. Azure Monitor functionalities. Insights, this can be for applications, containers, VMs, or other monitoring solutions. Visualize, using dashboards, views, Power BI, and workbooks, you can create rich visual presentations of your data. Analyze. This involves delving deep into metrics analytics and log analytics. Respond. Based on data, Azure Monitor can alert you or even autoscale resources. Integrate. Extend the capabilities by using logic apps or export APIs for more flexibility. Overall, Azure Monitor is a comprehensive solution vital for ensuring that your applications and services run optimally and any issues are detected and dealt with promptly. The next topic we'll be covering are the various sources from which Azure Monitor collects data. Application code. Azure Monitor's Application Insights offers robust metrics about the performance and functionality of your applications and code. You'll get performance traces, application logs, and even user telemetry. You'll need to install instrumentation package in your application to collect data for application insights. Availability tests. Measure your application's responsiveness from different locations on the public internet. This helps in assessing the reliability and uptime of your services. Metrics. Descriptive data regarding your application's performance, operation, and custom metrics. Logs store operational data about your application, including page views, application requests, exceptions, and traces. You can send application data to Azure Storage for archiving. View the details of availability tests stored. And debug snapshot data that is captured for a subset of exceptions is stored in Azure Storage. Log Analytics Agent is installed for comprehensive monitoring. Dependency Agent collects discovered data about processes running on the virtual machine and external process dependencies. Agents can be installed on the OS for VMs running in Azure on-premises or other cloud providers. Diagnostics Extension collect performance counters and store them in metrics. Application Insights logs collect logs and performance counters from the compute resources supporting your application, allowing them to be analyzed alongside other application data. The Azure Diagnostics extension always writes to an Azure Storage account, while Azure Monitor for VMs uses the Log Analytics agent to store health state information in a custom location. The Diagnostics extension can also stream data to other locations using event hubs. Resource logs provide insights into the internal operation of an Azure resource and are automatically created. However, you must create a diagnostic setting to specify a destination for each resource. Platform metrics will write to the Azure Monitor metrics database with no configuration. You can access platform metrics from Metrics Explorer. For trending and other analyses, use Log Analytics. Copy platform metrics to logs. Send resource logs to Azure Storage for archiving. Stream metrics to other locations using event hubs. Azure subscription. This includes telemetry related to the health and operation of your Azure subscription. Azure Service Health provides information about the health of the Azure services in your subscription that your application and resources rely on. Telemetry related to your Azure tenant is collected from tenant-wide services such as Azure Active Directory. Azure Active Directory reporting contains the history of sign-in activity and audit trail of changes made within a particular tenant. For resources that cannot be monitored using the other data sources, write this data to either metrics or logs using an Azure Monitor API. This will allow you to collect log data from any REST client and store it in Log Analytics in the Azure Monitor metrics database. Azure Monitor is integral to maintaining the health and performance of your applications and resources, collecting two fundamental types of data, logs and metrics. Azure Monitor logs collects and organizes log and performance data from a variety of monitored resources. Data consolidation. Logs can be pulled from diverse sources such as platform logs from Azure services, log and performance data from agents on virtual machines, and usage and performance data from applications. Workspaces. All these logs are organized into workspaces, providing a centralized repository for in-depth analysis. Query language. Azure Monitor Logs offers a sophisticated query language, which can quickly analyze millions of records, making it an ideal choice for complex data analytics. Log Analytics. You can interactively work with log queries and their results using Azure's Log Analytics tool. In contrast, Azure Monitor Metrics collects numeric data and organizes it into a time series database. Here's why that's important. Numeric data. Metrics are numerical values captured at regular intervals. They are a snapshot that describes a particular aspect of a system at a specific moment in time. Lightweight. Metrics are designed to be lightweight, allowing for near real-time data analysis. This makes them particularly useful for alerting and the rapid detection of issues. Metrics Explorer. The Metrics Explorer tool allows for interactive analysis of metric data, providing a more immediate understanding of your system's performance and health. The next topic we'll cover are the data retention and archive policies of Azure Monitor Logs. This is an important aspect of your monitoring strategy as it allows you to control how long your data remains stored and accessible. By default, in the Azure portal, you can set this retention time anywhere from 30 to 730 days for the whole workspace. If you want, you can also specify different storage durations for certain tables within your workspace, letting you manage different types of data as needed. This gives you the flexibility to meet any business or regulatory rules about data storage. However, note that to tweak these retention settings, you have to be on the paid tier of Azure Monitor Logs. To set retention and archive policy by table, navigate to the Azure portal and go to the Log Analytics workspace where the data is stored. 2. Under the Settings section, select Usage and Estimated Cost. 3. Then select Data Retention. 4. In the Data Retention blade, you can modify the retention period for each table. By default, it is set to 31 days, but you can extend it up to 730 days. 5. For archiving data, you can use Azure Data Explorer, which lets you retain data beyond the 2-year limit and gives you a highly scalable analytics service. So that's an overview of the data retention and archive policies of Azure Monitor Logs. You'll most likely encounter a question related to this on the exam, so be sure to know this. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be covering Azure Log Analytics. So, Log Analytics is a tool in the Azure portal used to edit and run log queries with data in Azure Monitor Logs. Log Analytics processes data from various sources and transforms it into actionable insights. It ingests data from Azure Monitor, Windows, and Linux agents, Azure services, and other sources. Once the data is collected, you can use Log Analytics query language to retrieve, consolidate, and analyze the data. Log Analytics uses a query language called KQL. Now, we'll go over some of the benefits of Log Analytics. Centralized log management, collect and analyze data from multiple sources, both on-premises and in the cloud, in a centralized location. Powerful analytics, utilize the custom query language to run advanced analytics on large amounts of fast streaming data in real time. Custom dashboards, create custom dashboards and visualizations to display real-time data and trends. Integration, seamless integration with other Azure services and Microsoft solutions, such as Power BI and Azure Automation. And alerting, set up alerts based on specific criteria to proactively identify and respond to potential issues before they affect your users. Log Analytics Workspace is a unique environment for Azure Monitor Log data. Each workspace has its own data repository and configuration, and data sources and solutions are configured to store their data in a particular workspace. So that's an overview of Azure Log Analytics. The Log Analytics agent is a lightweight agent that can be installed on Windows and Linux machines to collect and send log data to Azure Monitor. It provides a way to centralize logs from various sources and enables the analysis of the data using tools like Azure Monitor Logs, Azure Dashboards, and Azure Monitor Workbooks. The agent can collect logs from various sources, including Windows event logs, custom logs, performance counters, and syslog. It supports both agent-based and agentless data collection and can be configured to collect data from on-premises and cloud-based environments. The Log Analytics agent is set up to monitor certain Windows event logs like security, system, or application logs. The data from these logs is then gathered and sent to Log Analytics for analysis using queries and visualizations. The Log Analytics agent is set up to monitor syslog servers or network devices. It collects data from these sources and sends it to Log Analytics, allowing for detailed analysis and troubleshooting. Both methods for collecting log data allow for centralized management and analysis of log data from multiple sources, which can help to improve visibility and streamline troubleshooting and issue resolution. You can expect to see a question related to Log Analytics agents and choosing either Windows event logs for a Windows agent or syslog for Linux agent on the exam. The next topic we'll be covering are Application Insights. Application Insights is an application performance management service, and it's a subservice of Azure Monitor. APM is all about the monitoring and management of performance and availability of software apps. It strives to detect and diagnose complex application performance problems to maintain an expected level of service. So, why use Application Insights? Automatic detection of performance anomalies. Application Insights automatically identifies performance anomalies in your system. Powerful analytics tools. It comes with robust analytics tools to help you diagnose issues and understand what users do with your app. Continuous improvement, it is designed to help you continuously improve performance and usability of your applications. Platform agnostic, it works for apps on .NET, Node.js, Java, and Python hosted on premises, hybrid, or any public cloud. DevOps integration, it can be integrated into your DevOps process. And mobile app monitoring, it can monitor and analyze telemetry from mobile apps by integrating with Visual Studio App Center. To use application insights, you need to instrument your application. This involves installing the instrument package or enabling application insights using the application insights agents where supported. There are many ways to view your telemetry data. Apps can be instrumented from anywhere. When you set up application insights monitoring for your web app, you create an application insights resource in Microsoft Azure. You open this resource in the Azure portal in order to see and analyze the telemetry collected from your app. The resource is identified by an instrumentation key. What does application insights monitor? Request rates, response times, and failure rates, dependency rates, response times, and failure rates, exceptions, page views and load performance, AJAX calls, user and session counts, performance counters, host diagnostics, diagnostic trace logs, and custom events and metrics. Where do I see my telemetry? Smart detection and manual alerts, application map, profiler, usage analysis, diagnostic search for instance data, metrics explorer for aggregated data, dashboards, live stream metrics, analytics, Visual Studio, etc. Overall, Application Insights is a comprehensive APM service that offers automatic detection of performance anomalies, powerful analytics tools, and is designed to help you continuously improve performance and usability. In this segment, we'll delve into the topic of Application Insights instrumentation. So, what is instrumentation? In simple terms, it's a way to make your application smarter. By adding a few lines of code, or in some cases, none at all, you can monitor how your app performs and where it might be running into issues. You instrument your application by adding the Azure Application Insights SDK and implementing traces. In the case of a Node.js application, you can install the Azure Application Insights SDK using npm with the following command: npm install application insights-save. Application Insights, this is the name of the package you are installing, which is Azure's SDK for Application Insights. -save, this flag saves the package as a dependency in your package.json file. Here, this piece of code lets you configure what you want to collect. Azure supports the following languages: .NET, Java, Python, Node.js, JavaScript. Auto instrumentation allows you to enable application monitoring with application insights without changing your code. This table shows which Azure services support application insights and in what programming languages. The services range from Azure App Service on Windows and Linux to Azure Functions, Azure Spring Cloud, Azure Kubernetes Service, and more. GA, general availability, meaning it's fully supported and ready to use. Public preview, still being tested, but you can use it. Not supported, you can't use application insights here. Through agent, you need to install a special piece of software to use this service. and BD on by default, meaning the feature is automatically enabled. Through extension, available but needs an extension to work. We won't go through the entire table, but we'll give a few examples. For applications written in .NET and hosted on Azure App Service on Windows, Application Insights is generally available and enabled by default. For applications written in Python and hosted on Azure Functions, Application Insights is available and enabled by default, but for dependencies monitoring, you will need to use an extension. So that's an overview of Application Insights instrumentation. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be covering Microsoft Sentinel, formerly known as Azure Sentinel. Microsoft Sentinel is a scalable, cloud-native solution that encompasses two key functionalities: security information event management. This is all about collecting and analyzing security-related data to provide real-time analysis of security alerts generated by applications and network hardware. Security orchestration automated response. This refers to the collection of tools that enable an organization to define, standardize, measure, and automate responses to security events. Microsoft Sentinel delivers intelligent security analytics and threat intelligence across the enterprise, providing a single solution for alert detection, threat visibility, proactive hunting, and threat response. With Microsoft Sentinel, you can collect data at cloud scale across all users, devices, applications, and infrastructure, both on premises and in multiple clouds. detect previously undetected threats, and minimize false positives using Microsoft's analytics and unparalleled threat intelligence. Investigate threats with artificial intelligence and hunt for suspicious activities at scale, tapping into years of cybersecurity work at Microsoft. Respond to incidents rapidly with built-in orchestration and automation of common tasks. Microsoft Sentinel comes with a number of connectors for Microsoft solutions, such as Microsoft 365 Defender, Office 365, Azure AD or Microsoft Entra ID, Microsoft Defender for Identity, and Microsoft Defender for Cloud Apps. You can use common event formats, syslog, REST API, Windows Event Logs, common event format, and trusted automated exchange of indicator information. One notable feature of Microsoft Sentinel is the ability to create Azure Monitor workbooks. Workbooks provide a flexible canvas for data analysis and the creation of rich visual reports within the Azure portal. They allow you to tap into multiple data sources from across Azure and combine them into unified interactive experiences. It tells a story about the performance and availability about your applications and services. Workbooks are temporary workspaces to define a document-like format with visualization intertwined to help investigate and discuss performance. Microsoft Sentinel uses analytics to correlate alerts into incidents. Incidents are groups of related alerts that together create an actionable possible threat that you can investigate and resolve. Microsoft Sentinel's automation and orchestration solution provides a highly extensible architecture that enables scalable automation as new technologies and threats emerge. Built on the foundation of Azure Logic Apps, includes 200+ connectors for services. Microsoft Sentinel also offers deep investigation tools that help you to understand the scope and find the root cause of a potential security threat. You can choose an entity on the interactive graph to ask interesting questions for a specific entity and drill down into that entity and its connections to get to the root cause of the threat. Additionally, Microsoft Sentinel's powerful hunting search and query tools, based on the MITRE framework, enable you to proactively hunt for security threats across your organization's data sources before an alert is triggered. After you discover which hunting query provides high-value insights into possible attacks, you can also create custom detection rules based on your query and service those insights as alerts to your security incident responders. While hunting, you can create bookmarks for interesting events, enabling you to return to them later, share them with others, and group them with other correlating events to create a compelling incident for investigation. Lastly, let's talk about pricing. Microsoft Sentinel has two different pricing models. Capacity reservations. This involves being billed a fixed fee based on the selected tier, enabling a predictable total cost for Microsoft Sentinel. Pay-as-you-go. With this option, bill per gigabyte for the volume of data ingested for analysis in Microsoft Sentinel and stored in the Azure Monitor Log Analytics workspace. And there you have it, a comprehensive look at Microsoft Sentinel, a robust SIEM and source solution that can help protect your organization's infrastructure, applications, and data.
Let's take a closer look at Kusto and its query language. So Azure Monitor Logs is based off of the Azure Data Explorer, and along came with it is the Kusto query language, also known as KQL. And this is the way we're going to filter and sort and do things with our logs. So Kusto is based on a relational database management system, and it supports entities such as database, tables, and columns. It also has this thing called clusters. And KQL actually has a lot of utility in Azure because it's not just in monitor logs and Data Explorer. You can use it in log analytics, log alert rules, workbooks, dashboards, logic apps, PowerShell, Azure Monitor Log APIs. So it's definitely something you're going to be using across the board in Azure. And so they have some basic operators, they have lots of operators that you can use. So you can do calculated columns, searching and filtering on rows, group by aggregates, join functions. And we're going to be looking at a lot of the operators in more detail after this slide here. But anyway, the queries execute in the context of a Kusto database that is attached to a Kusto cluster. And we will talk about clusters, database, tables, and columns up next. Let's take a look at what makes up something for Kusto. And so we have a bunch of entities here, clusters, database, tables, columns, and functions. And so I have this nice visual to help us kind of see how they all work together. So at the top, we have clusters, and these are entities that hold multiple databases. You can also have multiple clusters. but it's just not being shown there in that graphic. Then you have the databases themselves. These are named entities that hold tables and store functions. You have tables. These are named entities that hold data, and a table has an ordered set of columns and 0 or more rows of data, each row holding one data value for each of the columns of the table. Then there are the columns themselves, and these are named identities that have a scalar data type. Columns are referenced in the query relative to the tabular data stream, and that is the context of the specific operator referencing them. Then we have stored functions, and these are named entities that allow reuse of Kusto queries or query parts. And then you got these external tables, and these are tables that live outside of your cluster. I think that you're referencing them from storage accounts, and they're in blob storage, so I think they could be like CSV files and stuff like that. But these external tables are used for exporting data from Kusto to external storage, so storage accounts, as for querying external data without ingesting it actually into Kusto. So hopefully that gives you an idea, the lay of the land there.